Hello everyone, welcome to today's session. Today my topic is a study on scissor detection performance in an automated process by extracting.
Hi everyone, I'm Mohammed Sami Zaitouni, a faculty member at the College of Engineering and IT at the University of Dubai.
I am Abhinay Mepi. I am here to present my work on DeepSpeedNet, a deep learning.
The University of Dubai, UD, was founded in 1997 by the Dubai Chamber of Commerce and Industry. In June 2006, His Highness Sheikh Mohammed bin Rashid Al Maktoum, Vice President and Prime Minister of the UAE and ruler of Dubai, granted the university 3 million square feet of land in Academic City for construction of a green and sustainable campus. In addition to the UD campus buildings being LEED certified, the campus is also the first net zero energy building in the region, following the implementation of a solar power project at its campus. The university, which is licensed by the UAE Ministry of Education, has several professional certifications and 2 major international accreditations, ICSPIS and Abbott. It offers a variety of business, law, engineering, and IT programs. The university is committed to developing and educating leaders who can make a difference in the business world. The achievements of the University of Dubai's 3,000 alumni in various organizations and ranks of leadership are a reflection of this commitment. The university is also a hub for several research and business centers, including the Center of Business Research and Consultancy, CBRC, and the Entrepreneurship and Innovation Free Zone, EIFC. Likewise, the university's student services and alumni affairs units offer an abundance of engagement opportunities and extracurricular activities inside and outside the classroom that meet the students' diverse interests and enrich their learning experience. During and after the students' graduation period, the Internship and Career Development Center staff make sure to build a relationship between the students and employers and provide them with opportunities that help them pursue their dream jobs. In addition to its bachelor's, master's, and PhD degrees, the university offers professional training through its Center for Executive Development, also known as CED. The center designs and delivers customized executive management development programs along with open enrollment workshops, internationally accredited professional certifications, and online learning opportunities, in addition to national emeritization initiatives.
Good morning, everyone. Can everyone hear me? Okay. Good morning, everyone, and welcome to the second day of the ICSPIS conference hosted by the University of Dubai. I hope that you all enjoyed the first series of speeches and paper presentations and that you found them insightful. And I'm sure that we all look forward to hearing today's sessions. So without further ado, let's start our day by listening to our keynote speaker for today. Please join me in welcoming Dr. Elias Bouhard, who will be speaking to us on the topic of research and operational efforts for immuning cyberspace from IoT-centric attacks. Dr. Elias Bouhard is currently the director of the Cyber Center for Security and Analytics at the UTSA, where he leads, directs, and organizes university-wide innovative cybersecurity research, development, and training initiatives. He is also a tenured associate professor at the Department of Information Systems and Cybersecurity, specializing in operational cybersecurity and data science as applicable to national security challenges. Previously, he was a senior research scientist at Carnegie Mellon University, where he contributed to federally funded projects related to the critical infrastructure security and worked closely with the Software Engineering Institute. Dr. Bouhard holds a PhD degree in computer science from Concordia University in Montreal, Canada, which was executed in collaboration with the Public Safety Canada, Industry Canada, and NCFTA Canada. His research and development activities and interests focus on operational cybersecurity, attacks detection and characterization, malware investigation, cybersecurity for critical infrastructure, and big data analytics. Dr. Bouhard has authored over 130 refereed publications in leading security and data science venues. He has acquired significant state federal cybersecurity research grants and is the recipient of 5 Best Research Paper Awards, including the prestigious ACM's Best Digital Forensics Research Paper. Ladies and gentlemen, let us welcome Dr. Elias Bouhard.
Hello, everyone. I hope you are doing well. Thank you very much for this invitation as a keynote speaker. I wished actually to be in Dubai physically. I always like to visit the Emirates, but for now we will just stick to the virtual session. But I look forward to seeing many of you, hopefully in the near future, physically. So today, my keynote speaker session is related basically to what we have been doing, basically related to IoT attacks. What type of research and operational efforts have been going at our side here in terms of state-of-the-art contributions and as well as operational cybersecurity operations. So a bit about me before we actually begin this session. So I'm actually representing the University of Texas at San Antonio, specifically the Cyber Center for Security and Analytics. I'm a tenured associate professor here. My key areas of expertise are mostly related to network security, operational security, cyber forensics, and any type of the higher umbrella of digital forensics. It has been more like 10 years I've been doing, I've been in the academic life, either as a faculty or as an R&D scientist. I've published a large number of papers. Some of the collaborators are actually in Dubai and the UAE. I have very good connections with the federal government here in terms of research grants, and some other collaboration basically in terms of for dissemination and for tooling capabilities. Apart from my associate professor hat, if I may say, I'm also the director of the Cyber Center for Security and Analytics here at University of Texas, San Antonio. And the following slides, we're gonna give you a bit of ideas what I do specifically in terms of the research, as well as what is the center and where does it fit in this cybersecurity ecosystem that we have here in San Antonio, basically. Okay, so my key areas of expertise actually are at the intersection of these assets here or facets. So, for example, my key areas of research is related to cyber threat intelligence and cyber forensics, which basically means basically delving or ingesting a large diversity of empirical data and generating threat intelligence related to that by developing innovative applications. And these applications could be related to data science applications, could be related to machine learning applications. So this is a big part of what we address, contemporary evolving problems, for example, like ransomware problems, ransomware attacks, amplification, denial of service attacks, IoT attacks, that I will talk about a bit today. But also, we have other type of cross-disciplinary themes that my research group conducts, basically, which is related to the intersection of critical infrastructure and cyber operations and network provisioning, as well as data science. Okay, so once we address these problems, it becomes intuitive to note that there's significant impact of these disciplines on our society at large, as well as on the operational cybersecurity aspects of every nation's basically critical infrastructure and operations. And we have been, succeeding in not only publishing in very strong venues related to these, but also we are also in the training of the next generation of students that are actually contributing to the academic life as well as the industry side of things. As I mentioned, I also direct the Cyber Center for Security and Analytics, and I will talk a bit as well on this. But the vision of my research group and the Cyber Centers group is to have some sort of collaboration, affiliation, or three-dimensional, if you want, ecosystem from academia, from the public sector, and the private sector. And we have established these collaborations, throughout the years to enable research dissemination, to enable the understanding of the contemporary research problems, as well as help our students with post-graduation placement. So this type of three-dimensional aspect that you are seeing here is a very successful model in our opinion. One is to, for many reasons, one of them is to actually acquire significant research funds so we can sustain ourselves and the research funds and the research students, as well as, more importantly, is to actually delve into the research problems that the public sector and the private sector are facing. And when we pull these problems to academia, now the academia actually are working, or academicians will be working on state-of-the-art problems, which is very important, because sometimes academia they sit in their silos and they try to address problems that sometimes they don't exist or with low impact. So the idea here is to bring these people together, the three-dimensional ecosystem, to address impactful problems, contribute to strong dissemination, as well as maintain these type of collaborations for later connections and for the students' success. So throughout the years, we have done strong collaborations with many public sector initiatives. And recently, one of the newer, if you want, collaborations is actually with the NATO center that is typically, here in the US is hosted in Virginia, actually. But also their headquarters is in Brussels, in Belgium. And we have actually been supporting the NATO in many type of projects, including the cyber training conference that they have every year. They call it the Cyber Coalition Conference, where 22 plus nations come together basically and basically compete in certain scenarios. So we help them with establishing this scenario, and we help them during this exercises. We also have connections with some, for example, power companies here in San Antonio, which actually provide us with data and expertise related to certain problems related to the power critical infrastructure. Also, we always try to collaborate with other academic entities. Some of those are in Europe, some of us here in the US, and some actually are in the Gulf area. So I mentioned the cyber center that I direct here basically in San Antonio. And basically, to give you just an idea, what is the cyber center? So the cyber center is actually a cross-disciplinary center. It actually maintains around 30 plus faculty across the institution. So we have 30 to 35 faculty across the institution that are part of this center, and they bring their own expertise with them. So if you look at the portfolio of the center, we can see that we have expertise in literally any aspect of data science and cybersecurity and cyber forensics. So the intersection, if you will, between data science and cybersecurity. So we have people not only from computer science and engineering, whether it is mechanical, computer, or electric. We have also people from that address socio-technical problems related to cybersecurity and data science. Typically, they come from an information system background. We have also sociologists and psychologists that are part of the center, and they bring their own expertise. For example, one successful expertise that they brought in for addressing one project was related to insider threat detection and kind of the weakest link, and the fact that there are some internal entities they try to exfiltrate, for example, intellectual property and stuff like this. So they help us with understanding their how to approach them and how to characterize them from the psychological perspective as they actually collaborate or interact with the other users and other systems. So these 35 faculty that we have part of the center are actually conducting their own work, but also we are conducting collaborative work with them. This is very beneficial on many aspects. One aspect is that we produce stronger publications when we have different faculty work on this, so we can go for bigger venues, basically. Also, we go after bigger research grants from the public sector mostly, so we have more money basically to sustain our students and to sustain our research ecosystem. And also, it's very important for the students themselves to get exposure to a large number of research and development themes. So the center has been doing very well, increasing its funding portfolio. And since 3 years, I have been directing this center, and obviously, this center is collaborating with other institutes and centers within the institution as well. And one of the newest institutions that the San Antonio area that will be conceiving basically is the National Security Collaboration Center. So the NSCC, as we call it here, is actually a new one of the 2 new buildings that will be based in downtown San Antonio. This is a very nice, image, a model. It's as close as possible to reality, I would say. The river is not as blue, but it is really a very impressive building. So the National Security Collaboration Center, this building that you are seeing here, is actually encompassed within the School of Data Science. So we have the School of Data Science that will be based downtown, and part of it will be related to the National Security Collaboration Center. And our center that we direct basically will be within the NSCC center. So kind of it will be the research arm of the NSCC. The NSCC has 3 major initiatives, which are obviously to empower research, to educate the next generation of students, as well as to improve the research workforce development. And here, workforce here means research scientists, industry, researchers that are, getting into the track, the public sector. Okay, so this is what it really means. And the NSCC also, what we like about it, what we like the difference, if you want, between our center and the NSCC is that NSCC also shares the same vision of the Cyber Center, which basically kind of completes this industry, academic, public sector collaborations. Obviously, the NSCC is on a bigger scale, so it has a large number of collaborations with private industry, for example, across the United States. Also, with the public sector, it's very impressive the type of collaboration that we're able to establish. Here, for example, in San Antonio, locally to us, there's one of the biggest Air Force bases. We have also NSA Texas close to us, which facilitates these strategic collaborations. But also throughout the US, we have connections with a large number of public and private sector. We are actually moving to the NSCC by end of December, and we will continue our track basically of this type of collaborations across the institution. So this was a bit of nutshell of what we do basically here, kind of the framing of things. And we invite any audience that is attending this conference, if they are interested on some of the aspects, some of the R&D themes that you saw earlier, some of this model that we are putting here together in any capacity really, to reach out to me. And we can see how we can work together for to achieve some of the objectives of this ecosystem that we are building here in San Antonio. And obviously, I invite everyone, if they are in the US, to pass by to San Antonio. It's such a great city, and I'd be happy to show you around the NSCC and give you more briefings about the different projects that each of the faculties that are part of the center and part of the NSCC is actually conducting. So I will kind of dive down now towards the research topic that I wanted to discuss with you today, which is I picked basically a problem of IoT. Obviously, everyone knows now the insecurity of the Internet of Things, but a recent, if you want, applications of the Internet of Things have been related to the maritime operations and cargo operations. So basically, these are port operations, and I chose this topic, one, because we are actually working with a number of ports here in San Antonio, with a number of cities that have, that operate, for example, large ports related to their security. And this is a big thing now in the, in the industry, as a public sector. And there's already, money that is being put from the public government, towards maritime and cargo operations and port operations. Why? Because they are actually now a key infrastructure of a nation. It's one of the key critical infrastructure. And as they are becoming more modernized, the threats from state-sponsored actors, from actors that would like to impede the operational capabilities of nations, is actually are actually going after maritime operations. So you're talking about ships in the sea, they're talking about cargo operations at land, you're talking about GPS spoofing, for example. All of these basically are attacking or threatening the maritime operational aspects. And this is why I chose this topic, because IoT also plays a big role now, or it will continue to play a big role related to maritime problems, basically. So kind of the motivation would be really to maritime, but the actual research work could be, to IoT in general, though it's, we are trying to, we are endeavoring to address this problem of IoT that is specific to maritime operations. So this slide basically shows that on a daily basis, you see a lot of news, and some of the news you can see here. So from ransomware attacks attacking companies, the health entities. Also, we have some ransomware attacks on supply chain. And probably last year we heard two big supply chain attacks. One of them was the meat plant here in the US. We see basically a large number of attacks on ports. For example, there was a famous LA attack that actually affected the port operations. In general, the IoT insecurity is becoming even worse. We see a lot of GPS spoofing that is actually impacting the aviation sector. So there's security problems all over the place, and you see these news every day. And really, the cybersecurity topic or area, or the addressing different problems or different sectors is no longer a need to be motivated, basically, because it's kind of our daily life now. So part of this motivation, I wanted to put some slides related to maritime operations, and the idea that in a maritime operation, it's a complex system. Some of you might relate to it as a cyber physical system, right? So, for example, these ships are no longer just physical assets in the ocean, but they are actually cyber physical systems that are empowered by IoT devices. Here, these cyber physical systems, these IoT devices, are actually threatened by a various type of misdemeanors, basically malicious activities, and these ships, they can be their GPS could be spoofed, and they can be used as in terroristic activities, for example, directing them towards other ships or directing them towards assets at the land. Or they can be actually diverted, and then they are taken for ransom by people, actually by malicious people in the ocean, or even typical cyber attacks like ransomware. For example, there was an incident where a ransomware actually was loaded on the machinery management and the access control system of the ship, and was able to paralyze the ship completely. And then the attackers demanded the ransomware to be paid to actually allow that ship that is in the middle of the ocean, middle of nowhere, to actually proceed in its path. So there's a lot of problems, security problems, when you talk about maritime operations, given this complex cyber physical system interaction between different components, including the Internet of Things. One of the things that is very important as well is one project that we are actually working, and this project basically deals with how we can safely allow these ships to maneuver, and instead of relying actually on just GPS signals, we are relying on a bunch, basically a group of internet-wide distributed sensors that are typically placed on the land, but they can be set up by drones. They can be set up on the ocean as well, to allow these ships to maneuver in a correct manner, basically. The problem here is that these sensors are also, we found them that they are also susceptible to attacks. And when these IoT sensors become susceptible to attacks, they can also impact the ship themselves. So, for example, we know of an incident here in Virginia, actually, in Norfolk, where NATO, for example, resides. We have NATO there. As you see here on the left side, you see a very narrow pathway here, and there has been recent attacks on this, basically. Specifically there. Why? Because the path is so narrow. Any type, for example, of denial of service attack can actually directly affect the physical integrity of the ship, because it can hit other ships, for example. It can hit the land obstacles and stuff like this. So we are currently exploring this problem in a constrained type of environment. And this is an ongoing problem, but I just wanted to shed the light on it basically for a bit. Okay. One of the biggest motivation that I like to keep in my slides is this video. This is quite an old video of a large campaign that was detected back in the days. And the beauty of this campaign, if you want beauty between quotations, is that these red spots that you are seeing here, they are actually infected devices. Okay, and these infected devices, if you are just monitoring their activities independently, you see them as, they're generating very few malicious packets, and you see them as a really independent type of generating independent activities. However, when you analyze their activities in a broader scale, you actually discover that these infected IoT devices, or devices in general, are actually orchestrated in a very well organized manner. So the bot master who's controlling these infected devices, infected hosts, embeds an orchestration mechanism that basically allows these hosts to work in tandem in a very, very, very orchestrated fashion. And because of this orchestration, they can achieve a certain objective. So, for example, they can, scan the entire internet. They can infiltrate or brute force certain servers on the internet. They can do any type of malicious objective without really being detected. So it will maintain their stealthiness. And at the same time, they can achieve their objective by sending only very, very few packets in this time, basically. And as you saw here on the top, on the bottom right, you saw something moving around, which is basically, this is the entire IPv4 space. And you see that campaign that you saw was actually covered the entire IPv4 space, which means by using these independent sources with a well-orchestrated fashion, the hosts were never detected, and they were able to achieve their objective. And this is a good motivation. Why? Because we are actually, on a daily basis, we are actually detecting and monitoring these type of campaigns coming from infected IoT devices, hitting different objectives, malicious objectives on the entire internet, basically. So we see a large number, you're talking, hundreds of these campaigns, well-orchestrated campaigns with different orchestration mechanism hitting these basically IoT devices and hitting assets on the internet. Obviously, now that these IoT devices are deployed in a large variety on the internet at large, right? There's consumer products, there's sensors in critical infrastructures, and obviously we already know of attacks that hinder the security, privacy, and the resiliency of our nations, basically. Okay, so we know attacks of on the privacy of, for example, baby monitors, the one that you see here. We saw attacks, for example, on Jeep, the famous Jeep car, for example. There are researchers in Stanford that showed that basically by infecting a number of high voltage attacks, IoT devices, you can actually take down the state of California, for example. Also, there are IoT devices in the maritime, and this is a big problem nowadays. So these are some of the mitigations. So what is our objectives, right? So what we would like to do? What we would like to do is to try to mitigate IoT-generated attacks as soon as possible. And to do that, one should be able to detect these infections as soon as possible, basically. As soon as they are infected, we would like to detect that these are infected and try to do something about them, okay? Obviously, after detection, similar to the campaign that you saw, we would like to monitor the existence of these campaigns, because these campaigns are very stealthy. And when they operate in an orchestrated fashion, it means they are actually planning for something, quite bad. So we would like to not only detect the infection, but also correlate these infected devices by their orchestration fashion, which is very important objective. Lastly, we would like to share this cyber threat intelligence. We would like to share this type of information that we are receiving and what we are generating, basically, with people and entities that can actually do effective mitigation on the ground. And we actually are working with a number of computer emergency response teams in the US and in Europe, as well as with ISPs, internet service providers here in the US, and we are sharing these intelligence with them for proactive mitigation and thus remediation. Clearly, there are challenges related to this. One is that these IoT devices are distributed all over the place, all over the internet, in the entire world. So, getting access to their data is almost impossible, or not only to their data, because we're not really interested in their benign data, right? We're mostly interested in their malicious data. So what are the artifacts of the malicious data related to IoT devices? Typically, we don't know much, right? And given that they are internet-wide deployed, logistically and technically, it's infeasible to have this visibility of all these IoT devices. Also, even if we have some visibility, these IoT devices are extremely heterogeneous. So we would like to come up with a solution that works for a large number of variety of these devices. So when I talk about variety, I'm talking, for example, the differences between an IoT camera, a smart thermostat, an IoT sensor in a critical infrastructure coming from vendor A, B, and C. So this is the heterogeneous nature of IoT devices. And lastly, as I mentioned, because of the internet-wide deployment, we have lack of IoT-centric artifacts that we can use to detect maliciousness. So how do we approach this? We approach this in a manner that we have been using for a long time now, which is what we call a darknet. I'm sure some of the audience now is quite familiar with the terminology of the darknet, but it shouldn't be confused with the concept of a dark web. The dark web is basically this underground internet that is operated by Tor nodes, for example, and other type of nodes. This is not the darknet that I'm talking about. The darknet that I'm talking about is basically a set of IP addresses on the internet. Okay, as you see here, it's actually it's one block, but it's actually distributed all over the internet. So there are IPs, what we call dark IPs in the US. We have dark IPs in Europe. Back in the days, actually, there was initiative at NYU AD to develop this darknet as well. But basically, this darknet is a passive measurement utility where we have IP addresses, basically what we call dark IP addresses. These are routable IP addresses, but they are unused for legitimate machines. Okay, so they are basically used there to passively collect one-way malicious traffic. And then when they collect this dark traffic, they share it with researchers, including us, the operators of the darknet. Obviously, they share it with the researchers and other type of entities to actually develop analytics, cybersecurity analytics on this type of data to address different problems. Okay. So we've been working, for more than 10 years with darknet data, among obviously other data sources. But darknet data is very, is also a part of our type of work that we do. And we are working with a provider here in the US that actually is monitoring around 16.7 million IP addresses, darknet IP addresses that are distributed all over the internet, basically. And this not only gives us a large vantage point, a large visibility point related to internet scale maliciousness, but also allows us to develop very innovative algorithms and methodologies that can address specific problems, including the IoT security problem that I'm going to discuss next. So we receive around 1.2 terabytes of data per day, per 8 hours actually. So it's it's like 3 to 4 terabytes a day, a full day, 24 hours. And we actually index this darknet data, and we keep it historically for other research purposes, basically internet measurement study, for example, and to enable other researchers to use this data. Also, we enable access to some of this data through our servers that we have here. The concept of the darknet data is very simple, basically. It collects, as I mentioned, internet scale illicit malicious activities. Why? Because these, for example, take this. Suppose this is an IoT camera, and typically IoT cameras, they don't, they share information with other internet hosts, for example, this host or this host, but they almost never send information to the darknet, send packets to the darknet. Why? Because the darknet is unused. They are unallocated. It's unallocated to legitimate machines, right? So there's no business for the IoT camera to actually send traffic. So normally, one important aspect here is that if these devices, whether IoT or not, send information to the darknet, it means they are most probably infected, and they are trying to propagate by hitting all the internet, and some of their aspects, some of their packets are actually received by the darknet. So while we see attacks and, for example, here scanning activities or propagation attempts on the internet, we see a part of it on the darknet. And there's obviously a simple calculation to understand what is the probability of seeing stuff like this, which is quite significant given that the vantage point is around 16.7 million IP addresses. Similarly, on the left side here, you see a campaign similar to the video that you saw. And by analyzing basically independent activities coming from specific hosts, we can develop algorithms and methodologies to be able to classify and track these campaigns that are made from a large number of devices, focusing on using a specific orchestration manner in almost real time. So the darknet, as I mentioned, this is part of the explanation of the darknet. So it's part of the internet where some malicious activities will hit it. Part of this is that this darknet is not only used for propagations like this. It could be used for analyzing the victims of denial of service, and it can actually be analyzed to understand the if you want, the scan and attack infrastructure of amplification attacks. And there has been research on how we can leverage the darknet for stuff like this. I'm not going to delve into the denial of service paradigm per se, because this is requires probably another keynote. But I'll continue moving on to our research topic. And before I move on to the IoT problem, I just want to mention here, and again, I'm not going to go much into the details. Initially, apart from developing the algorithms, because the darknet data, if you want, paradigm or research area is extremely empirical, we wanted to kind of analyze analytically initially how this scanning packets or how these packets are arriving to the darknet needs to be analyzed, basically. Okay, so basically we said that some sort of attacker or a scanner or malware propagation will eventually hit the darknet. So we were interested in the impact of the size of the darknet with the detection probability, okay, and the minimum time to actually detect this type of infections. So we came up with a theoretical model, analytical model that we obviously vetted with empirical data that we have to interplay between the vantage width and the detection probability and the minimum detection time. Why this is insightful? Because if any now entity tells me, I would like to have a darknet, I would like to deploy a darknet, and I would like to have a detection probability of internet scale activities by this much, for example. Or I would like to build algorithms given this vantage width, for example, darknet vantage width, to be able to analyze the attacks. So now I can actually formulate an algorithm. I can formulate a darknet based on its analytical, model that will deliver what is actually asked from, right? And this is a very important characteristic that was, we believe, that was lacking in, how to deploy darknet and why to deploy darknet. And if I deploy darknet in this way, what will this impact my detection algorithms? I'm not going to again discuss this, but you can find a lot of our research in. I will provide some details later on where we can find our research. But basically, we did a lot of work on analytical capabilities. So, for example, one study we analyzed, the famous Zeek or Bro intrusion detection system versus the snort intrusion detection systems as it's deployed on the darknet, and who's more effective if the darknet size increases, etc. So I'm not gonna bore you with this information, but this gives insights based on this type of model. What can we develop and what can we deploy and how we can deploy the darknet. Going back to the problem of IoT security in general and how we can basically detect these infections, we basically formulate the problem of detecting or early detection of IoT devices as a fingerprinting problem. And the fingerprinting problem means if I receive two network flows or a stream of packets from a certain device, how can I distinguish between one host, which is a typical PC, for example, and another host that is an IoT camera or an IoT thermostat or a smart TV, for example, right? So why this is important? Because it is important because I am receiving a large amount of data on the darknet. Most of these are coming from infected hosts that are trying to propagate. I don't know what is the nature of the source of such traffic. Because if I'm able to solve this problem, then I can attribute not only the device nature, so I can say that, for example, this is an IoT and this is non-IoT, but I can also say that this is an IoT manufactured by vendor A or vendor B, and I can say this is the firmware that is actually running on this IoT device that got compromised, and I can even say what is the malware type that is actually running on that IoT device. So this is a very important problem, and we address it by using our darknet data that we are receiving, and also by developing some deep learning and machine learning mechanisms based on, for example, the deep learning here is based on the simplistic convolutional neural networks. But obviously, our research have kind of passed through the stage. But here I want to give you some kind of an idea how things can be done to be able to address this fingerprinting problem. So obviously, we receive this darknet data. The darknet data is sometimes polluted with noise, and this noise can be related to hardware issues, software issues, routers passing non-darknet data to the darknet. So there are a lot of what we call misconfigurations that hit the darknet. So we actually, throughout time, we have developed an operational basically capability that actually cleanses this darknet data. And actually, we don't use it anymore locally. We actually have provided to the provider, and the provider is actually using it before actually creating this darknet data samples, basically. What we did is also from that darknet data, we ran some algorithms to actually detect the probing activities, and we extracted certain features from the packet headers. Okay, so this is kind of the pre-processing phase. So the idea here is that after I receive, for example, scanning packets or propagation attempts coming to the darknet, what I do is directly, immediately, in real time, I actually execute active scans towards these sources that were previously hitting the darknet. So the darknet allows basically for passive measurements. So we wait for the packets to arrive. We take this information from them, and then we actively scan them with very low rate and with only very few packets, so we don't cause flooding on our networks or the ICSPIS network. We also don't want to harm the IoT device, for example, or the end host, basically. So we scan it in a very stealthy manner, but we scan around 45 ports, and mostly we scan a large number of application layer protocols. Why application layer protocols? Because we would like to understand what type of applications are running there, what type of ports that could be of interest to us are running there. And we can actually distinguish between hosts that are typically deployed behind net routers, for example, which is mostly in consumer environments, versus, for example, industrial control systems protocols that are running, in typical ICSs, whether it's, power generation, water facilities, factories, building operations, etc., etc. And what we do is we not only we do the scanning, but we do something called application banner extraction. And this procedure basically takes the application that is running there, and we extract certain information from that application protocol. And I'm going to show you a simplistic example here. So this is what we call a banner here on the right side. So from different application layer protocols, and you can see, for example, embedded within this banner is some server information and the vendor, which is Dahwa in this case. We can see, for example, this is just a router. We can see also that this, for example, web is running IIS and the version of it, etc., etc. So some information related to the applications. Now, please note that at this stage we don't have a good understanding of what is IoT and what is non-IoT. Okay, but what we are trying to do is we would like to build some sort of a ground truth, and eventually learn from this ground truth and keep learning as data comes in to put this classifier on the darknet to be able to distinguish between IoT versus non-IoT. And a part of the training that you don't see here was actually based on a large number of IoT devices that we collected on different directions. One is that we were provided with some IP information that are vetted here in the Texas area, basically through an ISP, to understand what is an IoT and what type of protocols and application banners are there. We also got access to a large number of databases that index IoT devices and their banner information. And we worked with one proprietary database that actually indexes application layer protocols and related firmware related to IoT devices to understand how the banner will appear when this firmware is deployed on IoT devices. And based on this, and based on the scanners that we are receiving, we actually train a different type of neural models. So we use actually deep learning, but we also use shallow, shallow learning, which is, in this case, we had the random forest. So we trained actually on the raw packet features as well as some feature statistics. I'm not going to go much into the technicalities of how did we calculate the statistic of the features, but all that is in our papers, and we can talk about them at a later stage. But this is what we did basically. So in terms of the obviously at the end of the day, we come up with this model that we would like to continue learning, as I mentioned, and we deploy on the darknet to actually do this type of classification between IoT and non-IoT devices. Also, since many years, we've been working on the problem of campaign analysis, or what we call orchestrated botnet analysis. And we divide, throughout these years, we have devised a large number of approaches. One of the approaches that you are seeing here that we are currently using is very simplistic, basically, type of clustering methodology. Why did we go with this? That I will explain, because it's very simple. It means it can run in almost real time. Obviously, we can use unsupervised learning and fancy mechanisms that we have used, time series analysis and all this. But for the sake of this problem, especially that the intention was to move this capability that we are building here in terms of detection of infected devices, detection of campaigns, and sharing of threat intelligence to a real-time fashion. And when we were talking about real-time fashion, it means the delay should be very, very minimal. And actually, we have many follow-up works that actually discuss how we did this from a technical kind of engineering perspective. And that was a paper at Dependable and Secure Networks last year. So what did we use here? We used a set of features, which is the targeted ports, the distribution of the targeted ports within a network flow, a flag, a bit basically if it's Mirai or not. And Mirai basically can be distinguished because its header, the destination IP address, is equal to the sequence number. And we use something called the address repetition ratio, which basically captures how the scanners or the propagation is actually repeating hitting basically the destination IPs. And then based on these rules, we used a clustering mechanism that is extremely prompt, obviously with some optimizations that we have done, which is the hierarchical algorithmic clustering mechanism. And we use the Jensen-Shannon divergence to identify whether these campaigns that we are receiving are close to each other or not. Obviously, the closer they are, it means they could be part of the same campaign. So this is kind of to limit our false positive in the sense that we have different campaigns, but they're actually part of the same campaign. So this has been very successful. We have actually implemented this on the real darknet, and we are actually be able to identify not only infected devices, but these orchestrated campaigns as well. So some of the results that I'm going to show you now are basically related to some of the classification metrics that we received. And by looking at the F1 score, we were able to achieve a moderately good result, which is around 94%. Now we have limitations on this, and this is why we got 94% of basically detecting an infected IoT device, because these IoT devices that are actually compromised most of the times do not reply to our requests, right? So when they are actually propagating, we see their IPs, we scan them back. And most of the time we don't see, or not most of the time, I would say, some of the times we don't receive feedback from them. And we postulate that because of basically the fact that they are behind the NAT without port forwarding, this could be a reason. Another reason, because there's a large number of actually IoT malware that have hit that device, and it's actually prohibiting locking the IoT device from communicating, at least from a microscopic perspective. And sometimes in fact the IoT device itself might be very kind of simplistic, or the software that is running there is very simplistic, so we don't really see many application banners that we can use for the training purposes. Okay, we were able to also see that we have quite a good balance between false positive and false negative for almost all the models. And with the features that we actually selected and with the performance that we wanted to achieve, actually the random forest continues to perform very well from a network packet perspective. And the random forest historically on network analysis or network security has been actually providing sometimes not only comparable to deep learning, which is a big hype, but also exceeds the performance of deep learning mechanisms, as well as obviously it's extremely efficient compared to other deep learning mechanisms. So what are we seeing here? This is a 1 hour. I'm not talking 1 day or 1 month. This is 1 hour of empirical data results that we ran back in end of early 2022, if I'm not mistaken, early 2022, or earlier this year. And in 1 hour, we saw all these vendors have IoT devices deployed on the internet that are actually compromised. Okay, so we saw a large number of Dahua devices dealing ransomware, mostly related, not ransomware, sorry, Mirai, IoT malware, Huawei, for example, ZTE. We saw stuff from Cisco, from other type of vendors, basically. We saw also something very critical, which is some systems that are typically used in critical infrastructure, not only in critical infrastructure, but also in military operations. And this is something that we have a project with one of the public sector entities here in the US, looking at basically the insecurity of the IoT, what's actually deployed for military operations. And this is an ongoing work, and this is actually a very important type of work because, you know, as the military and military operations, what we call here in the US kinetic operations, you know, continue to scale up, especially given now what's happening, you know, between Russia and Ukraine. These IoT devices are actually being deployed not only to monitor, for example, you know, war fighters on the ground, but also to control and guide, for example, missiles to maneuver, for example, certain assets on the ground. Drones, for example, drones that are used in military operations are, you know, implementing certain sensors that are, you know, could be susceptible to attacks as well. And actually, one of the projects is the forensics part of this, you know, part of the research that we're doing is the digital forensics of these devices, not from an internet darknet perspective, but from a, you know, typical traditional, if you want, digital forensics perspective. And we see here, you know, obviously these countries they change, but we saw at that time, at that period, basically a large number of IoT infected devices in Brazil. And actually back in 2021, even early 2022, where this data comes from, Brazil actually, from a consumer perspective, they were actually one of the very early adopters of IoT devices. You know, 40% of them infected, unfortunately. Obviously, that we have now capabilities to track these countries, you know, throughout the days and months. What you are seeing here is basically some of the campaigns, you know, similar to the basically the video that you saw initially, and you can see, for example, given a certain, this is one campaign, this is another campaign. You see, for example, the number of infected devices, what we call, you know, bots or infected IoT devices within each campaign. So, for example, this one we were able to detect it 140,000 infected devices. They are working together. They are controlled by a single entity that is doing some sort of scanning activities on the internet. In this case, you know, mostly trying to infect other IoT devices and some web servers as well. Some, for example, botnets are into, for example, this one is into telnet. So they can be used, for example, brute forcing, or they can infect other IoT devices that have their telnet port open. So we actually, throughout history, also throughout the years, we did a lot of visualization of these campaigns. So, you know, the darker it is, the more constraints, the more relational are these bots, and you know, those one is the loose ends basically. But you know, all these are actually independent campaigns. So in terms of the cyber threat intelligence, the data sharing, so part of our most of our research and development efforts is to actually move the research to operational capabilities for us to be able to have a broader situation awareness, but also to benefit entities that can actually do something on the ground related to infected devices, related to whatever objective we would like to achieve. So we came up with this platform, and the platform is obviously a front end and a back end. This is what you see, some samples of the front end, basically, where we can actually track, you know, on a real-time basis, and we receive around 1 million packets per second, basically. So we are able to process 1 million packets per second in real time. And then within a few minutes, we are able to actually depict here the infected devices on the broader internet, given that the darknet is actually being hit by the internet. So we are able to identify different threat categories, for example, you know, infected devices, IoT devices, infected typical hosts. We are able to understand these hosts, where are they deployed, not only geographically, but in which sector. So you can say, for example, as you see here on the top low, you can see, for example, the IoT devices are deployed in manufacturing sector, or deployed in the financial sector, or in the banking sector, or in the in the commercial, which is consumer right sector. Typically, it shows as an internet service provider sector. So we have different capability. We have capability to actually dig down in the map by using certain fields. And also we have the entire basically raw data that we can not only share, but we can use for different filters. So for example, I can tell you, within an hour, say, where in Dubai, for example, the infected IoT devices are, or where the, not only IoT, typical infected devices, where are basically the victims of denial of service are being hit, or are the Emirati, for example, servers are being susceptible to amplification attacks. So all of this information, we can have it within, I would say 20 minutes, because there's a bit of delay by the time we receive the data, we index, we curate, and then we generate. So within, I would say 20 minutes, we can generate a large number of cyber threat intelligence that could be benefit to entities that are deploying this and computer emergency response teams. The backend of the platform is basically an API that we use. This is back in 2021. This is a snapshot from 2021, where basically we expose this cyber threat intelligence that you saw here in a programmatical fashion, where other people can actually ingest it. So if you ask me, you would like to have access to some cyber threat intelligence related to infected devices in, say, in the Emirates, we have capability to give you access to this, for example, right? Or you tell me I want to have a broader look at some areas in the world, or maybe just focus on IoT devices, or just focus on North America. So we can give you this information in a program, and then you just ingest it. And we have a very operational tool that we call XIoT, exploited IoT, that we released basically last year for the public in that paper, in the Dependable and Secure Networking paper, where we actually not only show the capability of this and what we had from an engineering perspective, but we also vet our results with two computer emergency response teams here in North America and Czech Republic, and through a private industry here as well in the US. We also compare the data, the outcome of this cyber threat intelligence, with two very known cyber threat intelligence feeds, Gray Noise and D-Shield, which are basically they index other type of cyber threat intelligence, including IoT. And we were able to see that our capability not only is IoT centric. So for example, D-Shield does not have IoT information, but Gray Noise does. But compared to both, we are able to understand that or comprehend that XIoT, our capability, our tool, is not only able to identify, to focus on IoT devices per se, but also is able to get around 30 to 40% more IoT devices that are compromised and that are vetted by computer emergency response teams. At the same time, it's 50% more rapid, basically more prompt than any other type of feed. So we are basically, the moment these devices are infected, Gray Noise is taking hours and hours to actually appear or show that IP address as infected. But in our case, it's literally maximum 30 minutes or 40 minutes at the worst case scenario. So we were able to show that we are not only more comprehensive, but also very efficient from a CTI perspective. So that's kind of conclude my talk related to IoT security and forensics, and we have been doing on this. I just wanted to highlight quickly just three to four projects that we are currently active in, that we published earlier, but we currently in the same path that similar to what we have doing here. So this is one work, for example, that was published last year in ICSPIS, which is basically the characterization of IoT malware and their evolution, because this is an important problem. And basically what we did is we noticed that, certain classifiers that actually detect these IoT malware variants are being rapidly basically misclassified. Something that we call in the in the AI and machine learning is the classification decay problem. So the classification decay problem is actually causing as things evolve rapidly, your classification significantly is degraded basically. So what we did is we actually used some sort of information from source code analysis as well as binary analysis, and we were able to understand how these features or how these characteristics between the evolution of these IoT malware are actually changing. And we developed an online learning mechanism to be able to continue tracking of this basically evolution. So our classifier is more, if you want, aware now of what is shifting in the features of these IoT malware to be able to understand it and classify it. So if you're interested in this type of IoT malware characterization, you can look at that paper. Another paper that was published this year in ESORIX, one of the also very good security conferences, is related to an area that I'm currently also enjoying, which is programmable networks. Probably you're familiar with the concept of software development networks, software-defined networks, which has been, for some time now. Recently, since 2-3 years ago, there has been a shift towards the programmable data plane. Basically, you program the forwarding plane of typically switches. And what we are doing, basically, we are doing this type of infection propagation detection, botnet clustering, the same problem that you saw earlier, but we are doing it within the fabric, if you want, of the switch. So now as packets are going, we can do the classification in real time, in true real time, because once we are able to program the switch, the program that actually runs on the switch runs at a significant speed. You're talking at least minimum 12 terabit per second. Now we have switches that go up to 25 terabit per second. So you can imagine the amount of processing here. And the beauty of these programmable data planes is that, in contrast to traditional, say, switches, they are very easy to program. They are very agile. They process in true line rate. And we don't need the vendor intervention anymore. We can, as programmers, we can develop any type of analytics, including security analytics. So if you're interested on this type of network, type of security, you can also have a look at that paper. I still have two quick projects to mention. Last year also we published a paper in NDSS that was basically related to a health entity. So basically we have these health institutions and they would like to do anomaly detection basically. And anomaly detection is very important now in health environments because they have been actually being attacked so much recently, whether it's ransomware attacks, whether it's privacy violations. And in the health environment, there is the HIPAA, which actually controls the the legality of the data, where it's going to go and how it's going to be treated basically, and where it's going to be stored. So we kind of propose a federated learning architecture to address the problem of anomaly detection at the local host. So this is also a very important problem, and we were able to implement this in actually a real health environment to empirically evaluate it. And in terms of classification accuracy and detection, we were able to exceed the state of the art by a considerable fashion, while also obviously maintaining the privacy of the data. Another important thing is that here we used system logs, which are basically system interactions within the local nodes. And also we used the notion of attention, basically, which allows us to do interpretability related to the exact sequence of system logs that was actually causing the decision-making process. Something that is very important from the system administration and for the to understand where are the probabilities and to understand why these system logs actually cause the anomaly detection to say that this is a malicious activity. Lastly, is a paper that we got in this year's NDSS that we're going to be presented in February 23. And this is what we call charge print. This is actually in collaboration with Dr. Claude Fashka from UD. So that was a very fruitful work between North America and actually the UAE to actually make it to NDSS, which is obviously one of the the big four in security. So the idea was to analyze from a software perspective the security status of the management stations or the charging management stations of electrical vehicles. As now electric vehicles are being populated all over the world, basically, including North America and obviously also the Emirates. There's a big hype on how to manage these stations, and there's obviously a software that actually manages these stations to allow the charging for these EVs. From our black box and white box testing, we were not only able to identify a large number of EV charging management stations that are publicly available over the internet, but also detect around 24 zero-day vulnerabilities that actually were acknowledged by the vendor. So we actually, after discovering these vulnerabilities, we talked with the various vendors, and one of the biggest vendors actually acknowledged our basically vulnerabilities and actually created CVE IDs for these vulnerabilities that are actually working on them. So this is very impactful work, and if you're interested in software security in general and if you want the electrification and the security of this electrification ecosystem, I advise you to reach out to us or have a look, please, at this paper. Lastly, I promise this is the last thing that I would like to say. Given what's happening between Russia and Ukraine, we actually have a work under review in the communication magazine paper, where we actually discuss what we are seeing from a threat dynamics perspective related to what's happening with Russia and Ukraine. So we actually delve into attacks coming from Russia just prior to, for example, the invasion day, or reconnaissance activities, scanning activities on critical infrastructure within Ukraine prior and during the attack, the invasion, as well as how the European Union, if you want, or the NATO countries actually targeted Russia in some aspects. So we have this threat dynamic papers coming up soon, hopefully. And we used not only darknet data, but we used also sensors, amplification sensors. We use BGP routes to understand how things are being done over the infrastructure, the attack infrastructure, and also some what we call black holing, which is basically to prevent attacks from coming into your ASNs. So this is a new paper that is under review, and hopefully it will come up. Basically shows us, capability once we have, if we have a large number of data, what can we do with this data? So that's it for my talk. I hope it was enjoyable. Again, I want to thank you for extending this invitation for me to have a keynote here with you. I hope you have a fruitful conference, and I hope to see you again physically, hopefully in Dubai at some point. And please, if you have any questions, you can reach out to me anytime, and I would be happy to see where we can work together with. Thank you very much again, and have a blessed week ahead of you. Thank you very much.
Thank you, Dr. Elias, for this informative and insightful speech. You can contact Dr. Elias on his email address for any questions. And now we are going to have a short coffee break, after which we will resume with session 3 at 10:30. Thank you.
University of Dubai, UD, was founded in 1997 by the Dubai Chamber of Commerce and Industry. In June 2006, His Highness Sheikh Mohammed bin Rashid Al Maktoum, Vice President and Prime Minister of the UAE and ruler of Dubai, granted the university 3 million square feet of land in Academic City for construction of a green and sustainable campus. In addition to the UD campus buildings being LEED certified, the campus is also the first net zero energy building in the region, following the implementation of a solar power project at its campus. The university, which is licensed by the UAE Ministry of Education, has several professional certifications and 2 major international accreditations, AACSB and Abbott. It offers a variety of business, law, engineering, and IT programs. The university is committed to developing and educating leaders who can make a difference in the business world. The achievements of the University of Dubai's 3,000 alumni in various organizations and ranks of leadership are a reflection of this commitment. The university is also a hub for several research and business centers, including the Center of Business Research and Consultancy, CBRC, and the Entrepreneurship and Innovation Free Zone, EIFC. Likewise, the university's student services and alumni affairs units offer an abundance of engagement opportunities and extracurricular activities inside and outside the classroom that meet the students' diverse interests and enrich their learning experience. During and after the students' graduation period, the Internship and Career Development Center staff make sure to build a relationship between the students and employers and provide them with opportunities that help them pursue their dream jobs. In addition to its bachelor's, master's, and PhD degrees, the university offers professional training through its Center for Executive Development, also known as CED. The center designs and delivers customized executive management development programs, along with open enrollment workshops, The University of Dubai, UD, was founded in 1997 by the Dubai Chamber of Commerce and Industry. In June 2006, His Highness Sheikh Mohammed bin Rashid Al Maktoum, Vice President and Prime Minister of the UAE and ruler of Dubai, granted the university 3 million square feet of land in Academic City for construction of a green and sustainable campus. In addition to the UD campus buildings being LEED certified, the campus is also the first net zero energy building in the region, following the implementation of a solar power project at its campus. The university, which is licensed by the UAE Ministry of Education, has several professional certifications and 2 major international accreditations, AACSB and Abbott. It offers a variety of business, law, engineering, and IT programs. The university is committed to developing and educating leaders who can make a difference in the business world. The achievements of the University of Dubai's 3,000 alumni in various organizations and ranks of leadership are a reflection of this commitment. The university is also a hub for several research and business centers, including the Center of Business Research and Consultancy, CBRC, and the Entrepreneurship and Innovation Free Zone, EIFC. Likewise, the university's student services and alumni affairs units offer an abundance of engagement opportunities and extracurricular activities inside and outside the classroom that meet the students' diverse interests and enrich their learning experience. During and after the students' graduation period, the Internship and Career Development Center staff make sure to build a relationship between the students and employers and provide them with opportunities that help them pursue their dream jobs. In addition to its bachelor's, master's, and PhD degrees, the university offers professional training through its Center for Executive Development, also known as CED. The center designs and delivers customized executive management development programs, along with open enrollment workshops, internationally accredited professional certifications, and online learning opportunities, in addition to national Emiratization initiatives.
University of Dubai, the first LEED certified net zero building in the region. Ground-mounted solar panels spreading over 2 kilometers have been installed on the campus. They connect to the existing grid and produce solar energy to fulfill 100% of the university's electrical needs annually. The panels surround the campus to maximize solar contact to a capacity of 1,700 kilowatt peak per day, helping the university reduce CO2 emissions by 2,040 tons and save 1.2 million dirham annually. In 5 years, costs invested will be recovered, and the university's energy bill will be zero for the next 30 years. The project was approved and implemented by Diwa Sham's Dubai Solar Program to support His Highness Sheikh Mohammed bin Rashid Al Maktoum's vision of having all buildings in Dubai to be zero energy by 2030. The Dubai Chamber is proud to be a pioneer in green building and contribute to Dubai's sustainable city vision.
It has been 3 years since my grandmother Teta Laila passed away. She was a loving, beautiful old lady. Alhamdulillah, she lived a full life, almost 90 years. I still remember her voice when I visited her in her beautiful house in the mountains. She used to greet me and say, "Taya binti, Taya busik." Teta Laila raised 10 kids, including my father. They all went to school and graduated from university. This is why she used to always tell me, "You must study hard, ya binti. Always study hard to graduate from the top universities." Oh, Teta, don't worry. I promise you to study hard to graduate from the top university.
Every organization in the world gives priority to lifelong learning. And this is the reason why University of Dubai, through Center for Executive Development, offers professional training and professional certificates in order to develop the capabilities of human capital in UAE. So I urge everybody to be a part of this lifelong learning process in order to be ready for the jobs of the future.
Welcome to the University of Dubai and the Center for Executive Development Training Program. The University of Dubai was founded in 1997 by Dubai Chamber of Commerce to provide quality education and to develop human resources in the private and public sectors. The university's campus is a smart and green campus where business, IT, engineering, and law studies are provided in addition to various professional education programs. Most of the university programs are accredited internationally, like ICSPIS for business and Abbott for IT. The university provides bachelor's, master's, and PhD in business administration. Further, the College of Engineering and IT offers bachelor's and master's. Lastly, the university also provides masters of law in financial crimes and arbitration.
A big welcome to all of you. I'm Dr. Vidya, the Director at the Center for Executive Development at University of Dubai. We believe that your learning journey is a never-ending one. When you finish your degree, you enter the University of Life, which requires continuous learning to keep you relevant in the job market. Since our inception over 15 years ago, the center has trained over 10,000 professionals in diverse fields, from traditional to new age, from business to engineering and technology, and even entrepreneurship. We want you to know that at UD, quality is paramount, whether it's referred to in relation to content, delivery, student involvement, or engagement. We are proud of our huge talent of trainers, coaches, and mentors who design and deliver cutting-edge and hands-on programs in the region. Our trainers come from a variety of backgrounds, including both practitioners and professors. We have converted successfully our entire range of programs to the virtual platform with very engaging and dynamic delivery. In addition to public courses, we are also known for the customized programs that we offer to large key clients in multiple locations successfully.
His Highness Sheikh Mohammed bin Rashid Al Maktoum said, "Training opens your eyes to weaknesses, boosts your self-confidence, and brings you one step closer to victory. Our team at the Center for Executive Development is eager to help you get your victory. If you need anything during the training, do not hesitate to ask one of our team members. We look forward to taking this learning journey with you and hope you enjoy the experience."
Since 1998, Dubai Chamber has been committed to sustainability by reducing energy consumption and improving its environmental performance. This has resulted in the Chamber saving more than 21 million dirham over 15 years, becoming the first existing LEED certified building in the Arab world in 2009 and LEED Platinum in 2013 and 2018. Furthering its commitment, and as part of Dubai's vision to produce 75% of its energy from clean sources by 2050, Dubai Chamber has now also made its education initiative. University of Dubai, the first LEED certified net zero building in the region. Ground-mounted solar panels spreading over 2 kilometers have been installed on the campus. They connect to the existing grid and produce solar energy to fulfill 100% of the university's electrical needs annually. The panels surround the campus to maximize solar contact to a capacity of 1,700 kilowatt peak per day, helping the university reduce CO2 emissions by 2,040 tons and save 1.2 million dirham annually. In 5 years, costs invested will be recovered, and the university's energy bill will be zero for the next 30 years. The project was approved and implemented by Diwa Sham's Dubai Solar Program to support His Highness Sheikh Mohammed bin Rashid Al Maktoum's vision of having all buildings in Dubai to be zero energy by 2030. The Dubai Chamber is proud to be a pioneer in green building and contribute to Dubai's sustainable city vision.
The University of Dubai, UD, was founded in 1997 by the Dubai Chamber of Commerce and Industry. In June 2006, His Highness Sheikh Mohammed bin Rashid Al Maktoum, Vice President and Prime Minister of the UAE and ruler of Dubai, granted the university 3 million square feet of land in Academic City for construction of a green and sustainable campus. In addition to the UD campus buildings being LEED certified, the campus is also the first net zero energy building in the region, following the implementation of a solar power project at its campus. The university, which is licensed by the UAE Ministry of Education, has several professional certifications and 2 major international accreditations, AACSB and Abbott. It offers a variety of business, law, engineering, and IT programs. The university is committed to developing and educating leaders who can make a difference in the business world. The achievements of the University of Dubai's 3,000 alumni in various organizations and ranks of leadership are a reflection of this commitment. The university is also a hub for several research and business centers, including the Center of Business Research and Consultancy, CBRC, and the Entrepreneurship and Innovation Free Zone, EIFC. Likewise, the university's student services and alumni affairs units offer an abundance of engagement opportunities and extracurricular activities inside and outside.
Okay, good morning, everyone. Welcome to session 3 and day 2 of ICSPIS conference. My name is Sabina Abdulhadi. I'm a faculty at College of Engineering at University of Dubai, and I will be co-chairing this session 3 together with my colleague Sudat, who is also a faculty at College of Engineering and IT at University of Dubai. Today's session 3, we will start with the first talk titled Breast Cancer Detection Using Federated Multi-Criteria Machine Learning, which is authored by Dr. Marco Repetto and David Letor from University of Milan, Italy, and SKEMA Business School.
Okay, so thank you so much for having me here. So it's always a great pleasure to be here in even if it's online in a conference in the United Arab Emirates. So today I'm going to present you a work I did jointly with Professor Davide La Torre. And the aim of this paper, this work, is to study federated learning and more specifically its goal programming formulation, which we formulated first in a couple of works before. And in particular, we want to focus on the task of cancer detection or cancer prediction. So, of course, why do we use federated learning in the first place? Well, in an era of big data, federated learning essentially has emerged as a promising way of learning from scattered nodes. So, as you can imagine, this can be very useful in cases such as healthcare, in which we need to comply with privacy regulations. And in order to avoid data silos among healthcare institutions, then we can leverage federated learning. Moreover, the literature is all the literature agrees on the fact that there are significant challenges in the healthcare sector. So this is the reason why we wanted to focus on that in the first place. Because of this, we tested the federated goal programming, as I told you, and in particular, we provided a thorough analysis of all the results given different models. So more in detail, our contribution is that, of course, we provide a privacy-compliant federated learning framework, and which is suitable for classification, and in particular, cancer detection. Moreover, the result shows that indeed we can use this framework, and we don't lose any privacy because this method is privacy compliant. So in the next slide, we examine the relevant literature on the field regarding cancer detection with a specific focus on machine learning-based techniques. So let me start first with the work of Professor La Torre and colleagues that essentially states that AI will revolutionize health and medicine, but really the work on applying machine learning started even before machine learning was a thing, meaning was an actual word, because we have the primordial work of Mangasarian, which conducted first machine learning application on cancer detection. Then from the work of Mangasarian came other scholars, such as, for example, Setiono, which was the first to propose an artificial neural network to do breast cancer classification. And then a lot of other scholars proposed different techniques, ranging from supervector machine to gradient boosting machines. So in this case, as you can imagine, there is no federated learning in all the papers. Essentially, there is no actual federated learning going on. This is the reason why we wanted to propose a federated learning approach, but more specifically, we wanted to propose something based on multi-objective optimization, because as you can imagine, in a case in which, for example, in federated learning, where we have scattered nodes, we can see each node as actually an objective to fulfill. So let me spend a couple of words on goal programming. So goal programming is a multi-criteria decision-making methodology. I don't want to go into detail on the multi-criteria decision-making methodologies because there are many. Goal programming is one of those. And essentially what we want to do with goal programming is the following. So essentially we want to minimize a set of distances, say delta, that can either be positive distances or negative distances from the objective. And essentially, by minimizing these distances, given some weights, we can define a solution that satisfies, at least in a soft way, the different objectives. So in our cases, we have 3 different steps. The first one is the step in which each node performs its inference. So each node creates a model based on the data that the node has. Of course, this is simple learning done at the nodes level. The second step is the relevant part. So in the second step, what happens is that each node passes the actual model to the other nodes. So the other nodes receive the models from each node and starts to evaluate that particular model on the node's specific data set. So you have this kind of cross-validation, but done at each node's level. And then, of course, you have some results based on the cross-validation of these models. You pass all this result of this cross-validation to the master node, and the master node essentially run a goal programming optimization problem. In particular, we used a Chebyshev goal programming approach, but even weighted goal programming can be used. And with this optimization problem, the solution of this optimization problem determines the actual weights that then the final model will use in let's say in an ensemble to weight each particular model. So you see these weights as alpha, and what is performed is essentially a sequential ensemble. So we wanted to test our approach under different data sets. Luckily for us, we found 3 publicly available data sets. So the first one is kind of a benchmark and is used extensively in many papers, which is the Wisconsin breast cancer. Then we have the Caracas cervical cancer data set. In this case, the features cover other dimensions because in the case of the Wisconsin database, we have a set of features which are mostly clinical, but in this case we have also demographic features, and these compared to the Wisconsin is still a medium-sized data set, but we also wanted to test for cases in which we have fewer observations. So we also use the Coimbra breast cancer. All these 3 data sets can be found on the UC repository online. So here you see the results of our approach given the different models and given the data set. So you can see that, for example, in the breast cancer case, in the breast cancer Wisconsin dataset, we have that the federated learning approach is always better than the non-federated counterpart, meaning it's better for the what we can call complex models. So In the case of models such as, for example, the multi-layer perceptron, indeed, the federated approach will lead to higher performances. This, of course, is not the case for simpler models such as, for example, the logistic regression. And in this dataset, it's clear that in general, we have on par performances. And this is something that shouldn't be discarded because in this case, what we have is a situation in which the information is spread among many nodes. So remember that we should expect some loss in performances, but in this case, the loss in performance is minimal, and in some cases, it even helps in terms of the performances. As you can see in the other data sets, instead, we have no clear-cut solution. You see that sometimes, for example, in the Coimbra dataset, the federated learning approach seems better, but we cannot say for sure. At least we have on-par performances with the advantages of having a solution that is privacy compliant. So this is the main aim of the approach, and the main aim of the paper is not to beat the state-of-the-art performances because of the fact that we have scattered information, which in a non-federated approach we don't have in the first place, but having something that is on par in terms of performance. And this can be seen more in detail in this plot, in which you have each model and you have the facet for each data set, and you see that in general, even if we augment the number of nodes, so in this case you can see that the scattering is even more is even more large. For example, if we take 100 nodes, even in a case in which we divide the information into 100 nodes, we still have on-par performances of the federated approach against the base case in which you have just one node containing all the information. So to conclude, in this paper, we tested the federated goal programming approach proposed, as I told you, by us in a previous work. In particular, we tested an approach in a case in which privacy is important. So, for example, healthcare. And we wanted to ground these findings. We want to make this finding robust, essentially. So we conducted this experimentation under several data sets. The first clear result is that when the data is scattered, it's still possible, as we saw, to distill performant models. So we don't have the trade-off between centered information and scattered information in terms of performance. But what is more interesting is that in some cases, as we saw, for example, for the case of multi-layer perceptron, we have something that is even better than the case in which we have all the information clustered in a node. So this is the take-home message, essentially, of our work. And again, thank you so much for this opportunity.
Thank you, Repeto, for your presentation of your talk. And we're moving on with our next talk, which is titled A Study on Seizure Detection Performance in an Automated Process by Extracting Entropy Features. This is authored by Srisheta Parui and their international team.
Hello everyone, welcome to today's session. Today my topic is a study on seizure detection performance in an automated process by extracting entropy features. Hi, my name is Srisheta Parui and I'm a student of Indian Institute of Technology, Kharagpur, India. My co-authors are Devashish Samanto, Nishan Chakraborty, Wadik Mansoor and Uttam Ghosh. So let's start. So the abstract of this study is actually, we all know that millions of people of all ages have been diagnosed with epilepsy all over the world, and the number is pretty much higher. But there are several types of diagnosis methods are available, among which electroencephalography is one of them. It's a quantitative component and it's very vital in identifying and analyzing epileptic seizures. Manual EEG detection takes a long time and has serious consequences. So in this paper, like to prevent the circumstances, the world needs alternative detection technologies. For more than a decade, several strategies and procedures have been used to assist medical doctors in detecting technological improvement. So numerous automated seizure detection frameworks that use machine learning approaches have recently been presented to replace the traditional methodologies. But there are some problems. So because multi-channel EEG data is unpredictable, Selecting optimum channel as well as characteristics and classifying them remain unsolved issue. So during this automatic signal detection process, the gadget also emits noisy signal, making detection and prediction a pretty challenging job. So in this paper, what we have done, we have tested various entropy features and selected the best features to classify the seizure patients. So for that, first we preprocess the data using IMF, that means intrinsic mode decomposition function of the raw signal, and then entropy features were extracted to classify the epileptic patients. Now, the proposed channel selection method is SVM-GA, works well with the framework and successfully removes the redundant channels from the data. So let's talk about the content. First is introduction, then background. Then I'll talk about the motivation of the work, followed by literature review, objectives, methodology, then data set description, experiments and results, then discussion, conclusion, and future works, and references. So let's introduce the epilepsy thing. It's actually a neurophysiological disorder in the central nervous system, due to which abnormal activities are induced, causing behavioral issues, loss of awareness, and sometimes sensations. So treatment with surgery or medications will probably control seizures for the majority, but it takes a lifetime for some people to get treatment. So the seizures eventually go away, and some instruments that aid in the diagnosis of epilepsy are known as electroencephalogram. So using electroencephalogram, as it has very good temporal resolution, we can actually detect the seizure. But if you want to know that what are the common symptoms by which you can understand that the person is suffering from epilepsy or not, it basically some temporary confusion, a steering spell, stiff muscles, uncontrollable jerky movement of the arms and legs, loss of consciousness or awareness, psychological symptoms such as fear or anxiety. So these types of issues are there in case of epilepsy. But if you want to make sure that yes, a person is suffering from epilepsy or not, we need to take out the brain signals out of them, and then we have to understand that whether the features are related to the epilepsy or not, and then we have to take a decision. So the background study of what we have done is like treatment with surgery or medication, as I said already, will probably control seizure for the majority, but it will take lifetime for some people to get treatment. So this is not feasible, right? So that is why in epilepsy, that is why we need a treatment procedure which is much faster than the traditional treatment procedure. So that is why we need to understand that whether the person is suffering from epilepsy or not in much earlier stage. Next comes that what happens basically during the epilepsy. So the epileptic brain's electrical rhythms have a tendency to become imbalanced, resulting in recurrent seizures. In patients with seizures, the normal electrical pattern is disrupted by sudden and synchronized burst of electrical energy that may briefly affect their consciousness, movements, and sensations. So as I told you, some instruments are there to aid the diagnosis, which is very popular. That is called electroencephalogram. That is the main focus of our study today. So what is the motivation behind the study? Because as I said, that it has a very good temporal resolution, but it has limited spatial resolution. But for this study, we need a good temporal resolution. That is why we have selected EEG. And so EEG has been considered as one of the finest medical tests for assisting in epilepsy diagnosis. Next comes manual EEG detection. Takes a long time and has serious consequences. We can't afford that time. So to prevent these circumstances, the world needs alternate detection technologies. Next, however, because multi-channel EEG data is very unpredictable, selecting optimal channels is a challenging job, as well as the features and classifying those channels remain unsolved issues. Next, during automatic signaling, the gadget also emits a very noisy signal, making disease detection and prediction challenging. So we need to come up with an algorithm so that we can detect the noise and eliminate them from the signals to get the clean signals, so that we can get the proper information out of that signal. So we have done a good number of literature review, but for the space constraints, we have included few of them. So here you can see that one of the paper has reported that they have classified EEG signals into either focal or non-focal using intrinsic mode function. In our paper, we are also using IMF, and the authors applied EMG algorithm on each signal for decomposing the signals into subband coefficient. Now the bands are classified by support vector machine classification approach and achieved 93.6% of sensitivity and a good amount of specificity as well as the accuracy, 96.8%. Next, another paper that called automated identification system for seizure EEG signal using tunable Q wavelet transform. They applied tunable wavelet transform TWT for the decomposition of source EEG signals. Then the authors computed centered current entropy factor from each decomposed subbands, and then they tested their proposed methodology with 3 different classifiers, namely random forest, multilayer perceptron, logistic regression. Recently, in one paper called Epileptic EEG Activity Detection with Children Using Entropy-Based Biomarkers, which has been published in Neuroscience Informatics of Elsevier Journal, they actually done, the purpose of their study was to identify EEG biomarkers that may be used to distinguish between children with epilepsy and otherwise healthy and normal subjects. So they have also used entropy-based biomarkers here. Next, another paper, very popular paper called epilepsy detection based on variational mode decomposition and improved sample entropy. They proposed an epilepsy detection method in noisy environment with the help of variation, null mode decomposition, and sample entropy. So scope of the work, what we have understood from the related works, that during seizure, muscle movement is very common, right? So that is why we need to come up with a solution so that we can eliminate the muscle movement noises or artifacts from the signal. So most of the cases, the researcher has not focused to eliminate the muscle artifacts, which actually makes the research incomplete, and selection of proper channel is crucial to reduce the time of computation. Past researchers have not considered the reduced computation time, which is very much important in healthcare issues, because if you start early, then that treatment will get better. So the objectives of the study is actually proposing a method for channel selection to improve the seizure detection process and reduce the time complexity. Next is analyzing the trends and training a predictive classification model to distinguish seizure sleep patterns using available data set. Third is studying the feature extraction process of EEG signals using metrics such as fuzzy entropy and sample entropy on short-term EEG. Okay, so this is the methodology. First, we acquire the signals, and then we have done the data pre-processing technique to remove the artifacts and noise using the EMD CVT method. I will explain it later. And then we have selected the channels by SVMG algorithm, and then we have done the window analysis protocol. After that, we have extracted the features, especially fuzz entropy, sample entropy, and distribution entropy, and then we classify the signals based on the features. Then we detected the results. This is the binary class problem. So there is only two classes. One is scissor, one is non-scissor. Next comes the data pre-processing part. So as I said, the first step we have taken after downloading the data set is pre-processing the data to remove the noise and artifacts that have been generated during the collection of the data from the subjects. So due to unusual symptoms of this particular disease, lots of muscle movements are common, and that is why it's more likely will be imposed in the data set. A method called canonical empirical mode decomposition has been applied, which is a very popular method to remove those muscle artifacts, as well as a bandpass filter we have also used to get a noise-free data. Next comes intrinsic mode function. They are generated for each channel, and to separate the data, the canonical variant analysis method has been applied. Next is the channel selection algorithm. This is a very important part of this paper, as you know that identifying essential channels for this sort of experiment is very crucial, since the purpose of the study is to identify the optimal answer is in the shortest amount of time. So reducing the number of channels also reduces the data and simplifies the procedure and reduces the temporal complexity also. Here we have proposed an SVM-GA model to pick up the appropriate channel for this experiment. So as you know that SVM is a very promising machine learning classifier, and GA mimics and follows the GA means genetic algorithm. Basically, it follows the Charles Darwin's idea of natural selection. So there are three phases to these procedures. Here it is mentioned that selection, crossover, and mutation. In this study, first the permutation entropy was calculated for each channel used in this experiment. And this P is a very resilient time series approach that provides a quantifiable assessment of the complexity of a dynamic system by capturing the ordered linkage between time series data and providing a probability distribution of the ordinary patterns. Next, when we have calculated the permutation entropy, now next the SVM-GA takes a set of subjects data and represent one subject as one gene to make a chromosome. Various combination of genes is possible, and by this combination of various subjects data, a string has been generated where the one gene is selected out of a population. So as I said, that different entropy parameters, that is approximate entropy, sample entropy, combination entropy, entropy dependent functional dynamics, and fuzzy entropy also. And there are many other entropies were chosen since they are capable of applying complexity figures, a nonlinear dynamic biomarker for controlled physiology that relies on restricted states. But out of every entropy, what we have noticed that three of them are giving the best results. So after checking out the results, we have selected only three entropy out of them, that is sample, fuzzy, and distribution. So if you want to know what about the sample entropy, it's a kind of approximation entropy that used to analyze the complexity of the biological time series signals in order to diagnose 6 states. In fuzzy entropy, it is very popular and is used to calculate the subjective value of the information in the context of uncertainty in the seal impression problem. In case of distribution entropy, it is initially it was proposed for the mitigation of the parametric dependency and robustness of the approximate entropy and sample entropy, especially when extended to limited data set. So basically, these three entropy are working fine with our experimental data. And when we classify the data, we have just used a normal machine learning classifier to classify the whole data. And the best performer was SVM and random forest. We will talk about it in the result section. Now, dataset description. So in this for this work, we have used the online publicly available data set, and The database contains 5 subsets of EEG recording basically. They are noted as Z, O, N, F, and S, and each of which 100 singular channel EEG recordings with a duration of 23.6 seconds. Now, as I said, after visual inspection of the artifact, these signals were selected from continuous multi-channel EEG data recordings. Now, subsets Z and O were recorded extracranically, while subset NF and S were recorded intracranically. So here, this is the data set. It has been subdivided into a normal and epileptic data set. So ZO was normal, NFS was epileptic. Now, in normal, the Z data set was with eyes open, and the O data set was with when eye closed. In epileptic case, when the seizure-free data set is N and F, and S was during the seizure, it was collected. Now, in seizure-free zone, the epileptic zone was N, and hippocampal formation of the opposite hemisphere of the brain was F. So this is basically a description of the data set. Now the experiment. The first experiment was the entropy feature survey. Now on the dataset from one side, we have used fuzzy distribution sample entropy to analyze 5-second EEG. Now we found that we performed well at differentiating between interictal, ictal, and ictal from interictal EEG, but sample entropy has trouble with one of 3 classification issues, that is ictal from interictal EEG. For each window size, we obtained entropy values for all the 500 signals classified as JTFNO and S in different tabs. On the dataset, as I said, that 3 entropies have been used. But when we have done the experiment, the next experiment was classification process between seizure and non-seizure. Now, for each window size, we obtain entropy value for all the 500 signals classified as Z, F, NO, and S in different tabs. Now, we applied various classification algorithms like least square support vector mission using different kernels and random forest. So this is the experiments and results. You can see that for linear kernel, for RVF kernel, and random forest, we have recorded the accuracy, the specificity, and sensitivity. But when we are comparing all of them, you can see that the linear kernel actually giving the best results out of 3 classifiers. So we can say that linear kernel SVM is giving the best result for this case. This is the ROC curve for each classifier for SVM linear kernel, for SVM RVF kernel, and random forest. Now, if we compare the experiment with different types of features and different number of channels, you can see that the signal, like a classifier, works like differently with different types of features, and the number of channels are also varied. So this is very clear and compact picture of the whole experiment. Next, it has been noticed that the linear kernel is performing better than RVF kernel, and when we tested the dataset with random forest, it was giving better results than RVF kernel, but linear kernel outperformed. Now we are saying most of the cases because we have noticed for some number of channels RF is performing better. So we can say that RF and SVM linear kernel is good classifiers for this kind of experiment. Now, the proposed artifact removal method works well with our framework, successfully removes the noise from the data. Nonlinear features have been shown to be critical for this type of research. Furthermore, the inclusion of several week-long classifier distinguishing requires the study. Next is conclusion and feature scope. The cognitive framework that has been used can be improved in such a way that it can be utilized in real time, also for medical purpose. In this paper, we have just used the online dataset, so we cannot say that whether it will work in real time or not. Hopefully, it will work. An alarm system or sensor can be installed with the machine, and it will help the medical practitioner to understand the information quickly that the seizure is happening or not, or it is his epileptic patient or not. With the sensor, we can also make him or her understand. More clinical data set. Here only one data set has been used, but more clinical data set can be tested with this algorithm to understand that whether it is really good for all the data set or not. Next, designing new gadgets like smartphones or robots to assist epileptic patients can also be possible if a new algorithm has been incorporated. Here we have considered the machine learning method only, while the deep learning method can be used to extract features of the seizure, and it may help the process much faster, but it is also complicated, so we need a GPU for that. Next, a more hierarchical structure can be used using several entropies and deep learning methods. So these are the references of my presentation.
Okay, thank you, Dr. Paroui, for your presentation. And we are moving on with next talk titled Piezoelectric Energy Harvesting for Wearable and Implanted Devices, authored by our very own faculty, Dr. Zitouni and Dr. Wahba.
Hi everyone, I'm Mohammed Sami Zaytouni, a faculty member at the College of Engineering and IT at the University of Dubai, and I'm glad to be here today to present to you the literature review conducted by me and my co-author Maysam Wahba, entitled Piezoelectric Energy Harvesting for Wearable and Implantable Devices. So this is the outline of our presentation. So one of the most promising ways of energy harvesting is utilizing the properties of piezoelectric materials ever since the piezoelectric effect was discovered by the Curie brothers in 1880, it has been a subject of interest for human body energy harvesting. So basically, the piezoelectric effect is when the crystals are pressured, either by bending, twisting, or squeezing, electric field is generated. And the piezoelectric effect is also a reversible process. For example, production of sound waves by the piezoelectric material. The piezoelectric generator was not popular until recently, since the development and the advancement of low power embedded devices. So humans can generate sufficient electrical power with ordinary movement that can be harvested by piezoelectric materials. Now, piezoelectric materials act as a mechanical to electrical converter, which produce charges when stress or strain is applied. The amount of charge or polarization produced was found to be proportional to the applied force, which causes mechanical deformation. A piezoelectric power generator consists mainly of the piezoelectric ceramics as well as the electrodes, and they can be small enough to fit inside a micro electromechanical system so that it can be used as a self-powered energy harvesting device. Also, it has almost unlimited lifetime, given that the applied force and the environment temperature is within the operational range. And compared to other generators, such as heat conversion generators, it has no problem such as the heat isolation. So it makes it very suitable for biomedical wearables and implantables. Now, piezoelectric material is non-conductive, so no free electronics. They are made up of crystals with fixed electrons, which move slightly as the crystal deforms. So by altering the status in adjacent conductors, electric force is created, which pushes and pulls electrons in the electrodes. Now, while magnetic generators, for example, use mechanical energy to change the magnetic field, piezoelectric generators change the electric field. Now, talking about the applications of piezoelectric materials, a general example is the cigarette lighter. So piezoelectric elements are used to produce sparks by pressing a button, so it will deform the piezoelectric material, and that will cause a spark, which will heat the gas and start a fire. Another application is the piezoelectric transformers. So they are used as AC voltage multiplier and transformers, and they have a very decent efficiency of greater than 85%. Power generating shoes is another example of the use of piezoelectric materials. So it can be used to power some electronics or wearables for human beings, and the output powers from an average man walking is around 600 milliwatt. Another example is power generating tiles, where it can be installed at tourist attractions, crowded places such as malls, airports, and so on. And an example of that is one footstep can light 260-watt bulbs for 1 second. So it can be used to light dark places or store that power in batteries, so to keep the light on and reduce the power consumption. Now, moving to power biomedical energy harvesting devices. So this is an overview of piezoelectric energy harvesting system for biomedical applications. So for example, piezoelectric energy harvesting systems are used as biosensors to sense physiological signals of the body, human body energy harvesting for wearables, tissue regeneration applications that are under development, cell stimulation, and implantable devices that are self-powered. Stretchable piezoelectric sensors and energy harvesters are used now widely for wearables and implantable electronics. The enhanced stretchability and piezoelectric properties are enabled by advanced stretchable piezoelectric materials and stretchable structural design. Advanced stretchable piezoelectric materials include organic piezoelectric materials, piezoelectric composite, 3D piezoelectric microfoam, and novel stretchable structural designs include buckled shapes, serpentine layouts, kerigami designs, woven textile. These devices are used to harvest energy from heartbeat, wrist, arm, and other human motions. Furthermore, they have been explored as self-power sensors to monitor blood pressure, pulse, skin, and muscle movements. Now, let's start with some examples of applications in wearable devices. Now here, we can see a battery-free piezoelectric powered wearable switch sensor system for wireless and non-invasive molecular monitoring. So this work shows a robust, mass-producible, and battery-free wearable platform that efficiently extracts power from body motion through a flexible printed circuit board. It displays a high power output of around 400 milliwatt. Through the system integration and efficient power management, a battery-free driven system can power multiplexed switch biosensors and wirelessly transmit data to the user interfaces through Bluetooth during on-body human trials. Another example is a wearable self-powered active sensor for respiration and healthcare monitoring, which was fabricated based on flexible piezoelectric nanogenerator. When periodically stretched by a linear motor, the flexible piezoelectric nanogenerator generated an output open circuit voltage and short circuit current of up to 1.5 voltage and 400 nanoampere respectively. Through integration with an elastic bandage, a wearable self-powered sensor was fabricated and used to monitor human respiration, subtle muscle movement, and voice recognition. So this self-powered wearable active sensor has potential for application in pulmonary function evaluation, respiratory monitoring, and detection of gesture and vocal cord vibration for the personal healthcare monitoring and disabled or paralyzed patients. Here are some other examples of using piezoelectric energy harvesting as wearable devices. So A, we can see a flexible energy harvester placed on the back of the knee for harvesting energy from bending deformation. And B, we can see a self-powered system consists of piezoelectric energy harvester and a supercapacitor on the wrist to harvest the movement of the wrist. And C, we can see a piezoelectric energy harvester to harvest mechanical energies from wrist bending, finger tapping, and foot stepping by the heel. And D, we can see a harvester attached to the skin near the human eye to detect the wrinkling of a human face during blinking. Another example is a piezoelectric sensor attached to the human wrist for measuring wrist movement. And finally, a self-powered health monitoring system with the energy harvested from human motion to monitor leg motion, hand motion during sleep with a schematic as shown in B. Now let's move to examples from implantable devices. First of all, we can see the micro machine piezoelectric spiral and ultra-compliant packaging for blood pressure energy harvesters powering medical implants. This work shows an energy harvesting technique and an associated packaged device aimed at powering intracardiac active medical devices by scavenging energy from ordinary blood pressure variations. This concept shows that deforms due to cyclic blood pressure variation in the cardiac cavities can be used to power these implantable devices. This transmits stresses on the spiral-shaped piezoelectric transducers that converts mechanical deformation into electric energy. The particular shape of the different components, pillows and spiral, are designed to dramatically increase the mechanical energy that is harvested. Another example is powering in-body nanosensors with ultrasound. So embedded nanosensors will be a key feature of emerging medical monitoring system where power for these sensors could be harvested from ultrasonic vibration generated by portable miniature sources and converted to electrical energy by piezoelectric nanowires. This analyzes the frequency and intensity of ultrasounds required to power an embedded nanosensor subject to medical safety limits, absorption by human issue, and reflection from interfaces. This work suggests that ultrasounds can be a viable source for energy harvesting of in-body nanosensors. Now, the final example we have here for implantable devices is piezoelectric ceramics for electric power generation within orthopedic implants. So here we show or demonstrate the feasibility of using piezoelectric ceramics to generate electrical energy from orthopedic implants. Sensors encapsulates within implants could provide diagnostic capabilities such as the monitoring of the implant duty cycle, detecting abnormality asymmetric or high forces, sensing misalignment, and early loosening and early detection of wear of the device. Early diagnosis of abnormalities or embedding failure is critical to minimize patient harm. However, the routine use of sensors and microprocessors embedded within orthopedic implants for diagnostic and monitoring purposes has been limited by the lack of long-term self-contained power source capable of lasting the expected 20-year implant's lifetime. So the piezoelectric material comes as the solution for self-powering such an implants for a very long time. Now, let's briefly talk about the advantages and disadvantages of using piezoelectric materials for energy harvesting. So first of all, piezoelectric materials are a green source of energy. Generators have high efficiency, small in size, cost-effective, and sensors are using piezoelectric materials are accurate sensors. However, it requires maintenance. The crystals can be damaged when it's exposed to extra deformation outside the operation range or external temperature. Generators only work at low voltage, so it's only suitable for low energy devices, and it gets affected by high temperature, as we said, so it can be damaged. And finally, it can pick up stray voltages in connecting wires. Now, in conclusion, the design of wearable and implantable energy harvesting devices has drawn a lot of research attention in the past years. Piezoelectric materials provide the perfect candidate for such systems due to its long-term stability. It allows us to harvest energy from naturally available energy sources such as vibration, body movement, stress, and strain. So this allows us to utilize it for the increasing demand of self-power electronics. So in this study, we showed what researchers have carried out to harness energy from the body through implantable and wearable devices. Thank you for listening, and feel free to ask any question or email us if you have any inquiry.
Thank you, Dr. Zeitouni, for your interesting review of piezoelectric devices. You can email authors directly on their provided email addresses. And we are moving with our next talk titled Deep Skin Net, a novel deep learning model for skin cancer detection, authored by Dr. Pantakan from University of Dubai and his collaborators from TKM College of Engineering in India.
I am Abhinay Mepi. I am here to present my work on Deep Skin Net, a deep learning model for skin cancer detection. I am guided by Dr. Ansar Hassan, Department of ECE, TKM College of Engineering, and Dr. Alvin College of Engineering at IT University of Dubai. Let's see the outline to which my paper goes on. Introduction, literature review, background of the work, proposed methodology, results, and discussion, final analysis, conclusion. First, let's go to introduction. Introduction, as it's very well known that skin is the largest organ in a human for a human being, which provides us the sensation like touch, warmth, cold, etc. Skin lesion can occur by birth or due to improper skin care. The skin lesion becomes dangerous when it turns out to be cancerous. There are different types of skin cancer, like in which most deadliest one is melanoma, because it can spread very easily to other parts of our body, to other organs, etc. So that it's very important to detect skin cancer at the early stages. So the objective of my work is to find better solution for which is faced by the challenges of skin cancer detection. And in this work, I focus to develop a skin cancer detection algorithm on RGB imaging and in the HAM 10,000 dataset. The dataset which I had used here for the analysis is HAM 10,000 dataset. Then I developed a deep skin net model from scratch using CNN, which is dedicated for skin cancer detection, and compared its performance with already pre-trained models like AlexNet, VGG16 and Inception V3, and find out which model is best for skin lesion classification. The performance of the proposed system is analyzed in terms of classification accuracy, loss, confusion metrics. Now let's go to the literature review. They are the basic papers which I have gone through before doing my work. The first one is skin cancer classification. Skin cancer classification using deep learning and transfer learning algorithm. That is the technique used here is AlexNet, and they have done a comparison of their work with the existing work, and that is the main advantage. And they found that their accuracy is better than all the others. The disadvantage is that they are used PH2 dataset which has only 200 RGB images. The second one is melanoma skin cancer detection using deep learning and classical machine learning technique, a hybrid approach, in which they use a hybrid approach of using CNN, KNN, and SVM. Here they use 3 different models, and majority voting. So the output of the prediction does not depend on a single model. So the main disadvantage is also is the lack of data set. The next one is skin cancer classification using deep learning, deep convolution neural network. Here they use AlexNet and SVM. Here they classify 4 kinds of skin cancer, but the data set they collected from different related sites. So their data set cannot be reliable. And the fourth one is development of skin cancer classification system for pigmented skin lesion using deep learning. They used a technique called CNN. Here the main advantage is that they compared their predicted output with a set of they had used a set of qualified certified dermatologists, board of certified dermatologists, and the main disadvantage is that they only predicted 2 classes, that is melanoma and basal cell carcinoma. The fifth paper is intelligent skin cancer diagnosis using improved particle swarm optimization and deep learning model. They used segmentation methods like the ABCD, DLCM, along with CNN. The segmentation is done so the borders are well defined, and their main disadvantage is that they are also lacking their data set. The third main heading is background of the work. In the background of the work, we can look into AlexNet. AlexNet is comprised of the 8 layers. Each one has its own learnable parameters. The model is made up of total 5 convolution layers and one which combines with max pooling and other operations. Then comes 3 fully connected layers. There are about 63.7 million parameters in AlexNet model. To achieve better accuracy for AlexNet, hyperparameters are adjusted and the accuracy of the model is increased. And this is the basic architecture of AlexNet. Now let's see VGG16. VGG16 is from the name itself, there is 16 layers for VGG16. There are 13 convolution layer, 5 max pooling layer, and 3 dense layer. When we count total layers, there are 21, but 16 layers are only weighted. They take an input tensor of 24 cross 24, 224 cross 224 with the 3 channels. They focused a convolution layer with the 3 cross 3 filter, and stride and max pooling are always same. The same padding and max pooling layers with the stride 2 cross 2 and stride of 2. The convolution layer and max pooling layers are arranged throughout the design. Same throughout the design, and after a stack of convolution layer, a 3 fully connected layer is there, and the last fully connected layer is used for the classification of 7-class classification. This is the VGG16 architecture. Now let's go to Inception V3. Inception V3 is in Inception it is substantially that turns with its CNN classifiers. The deep neural network replicates the Inception module to achieve the required depth. And Inception is capable of functioning multi-level feature extraction, that is carrying out through 1 cross 1, 3 cross 3, and 5 cross 5 convolution filters that which is respectively for a single network module. There are about 24 million transfer learning parameters. This is the architecture of Inception V3. Now let's go to the 4th module of the paper, that is proposed methodology. In proposed methodology, we have developed a deep skin net model specifically for skin cancer detection. The major advantage of this model is that it requires very less pre-processing. The model is a combination of local and global pooling layers. Pooling layers are mainly used for the dimensionality reduction. There are different types of pooling layers in which there is some pooling, average pooling, and max pooling, in which I had used max pooling for this work. And fully connected layers are also used. Here, a traditional multi-layer perceptron is used as fully connected layers. Now, this is the architecture of deep skin net, the proposed model. And there is a flattened layer over here. Once the image is passing through the flattened layer, it gets converted to only array and then forwarded to fully connected layers. The model takes RGB image as input, and ham 10,000 dataset is used as the input over here. The proposed model consists of 7 layers, and it has 4 convolution layers with max pooling, along with 2 fully connected layers and 1 output layer. The activation we used throughout the model is ResNet, except for the output layer we use softmax, and the architecture contains 13.4 million learnable parameters. The final one before conclusion is result and discussion. In result and discussion, first we see what are the data set we use. It's AM 10,000 data set is used here, and it's already mentioned above. The data set consists of 10,025 skin lesion images of 7 different classes. It includes melanocytic nevi, adenoma, benign arthros, bacillocell carcinoma, echinocarditis, vascular cell lesion, and dermatofibromas. The main disadvantage is that imbalance between different classes. So for balancing that, data augmentation is done, and this is the data set details. These are the 7 different classes in which contains different amount of images. As already told that the data set is imbalanced. After the augmentation is done using a Python package called image data generator. After this problem is being solved, they are converted into 28x3. And for partial detection, they are converted into NumPy array. The experiment is done in Intel i5 processor with 8 GB RAM. Jupyter notebook is used for the coding, and optimizers used are Adam and NRM. Loss function used is fast categorical loss entropy. Reduce LR on plateau and early stopping is also being used. Batch size is 64, validation is 0.2, and epoch is fixed to 50. Performance metrics used are F1 score, precision, and recall. F1 score is harmonic mean between sensitivity and precision. Recall is the positive rate of hit rate. Precision is the correct positive result divided by number of positive results detected by the model. Now, let's go to performance with the deep skin net model. The deep skin net model is being implemented and the performance is being noted. The training accuracy of the model is 100%, and 97.92 and 97.34% is obtained for validation as well as testing accuracy. Precision and recall of the model is shown in the classification summary. This is the classification summary of deep skin net, and this is the classification summary happened for AlexNet. This graph shows the accuracy and loss curve of the deep skin net model. And then coming to the part of the graph, training accuracy starts from 0.32 and reaches to 1 at the 14th epoch, and validation curve starts from 0.6 and reaches up to 0.73 at the 16th epoch. From the graph, it's well known that training accuracy is 1 and validation accuracy is 0.9735. And the figure 5 shows the loss curve, and figure 6 shows the confusion matrix. These are the class labels for the confusion matrix, and this is the confusion matrix. Except 0 and 1, all the other classes are predicted accurately. And the 0 class, there is 1,332 322 images are predicted correctly, and in class 1, 204 images are predicted correctly, where 1 is predicted wrong. Result and discussion. Now let's look into the performance of state of art. As already told, AlexNet V16 and Inception V3 are used as the backbone of this work. NADAM and ADAM optimizers are used. Similar experimental setup, we have done this, and we use ham 10,000 dataset for that also. The comparison of skin cancer detection using ham dataset is shown in this table. Here it is well known that CNN module performs better than all other models. Inception V3 gives 86.25, which is the least one, and VGG16 with 86.35 testing accuracy. And among all the other models, AlexNet and NADAM optimizer give AlexNet with the N-Adam optimizer among all the other pre-trained models. I mean, with the BGG16 inception v3 and AlexNet shows the better accuracy for ham data set. And the final one is the conclusion. Let's see the conclusion. The biggest challenge in skin cancer detection is the availability of large and reliable data set. It is solved by hand 10,000 data set, which contains 10,015 images from 7 different classes. For skin lesion classification, the proposed deep SkinNet model is compared with the current model such as AlexNet V316 inception V3. The performance of the model is analyzed using accuracy, precision, and confusion metrics. From all these, we have found that Deep SkinNet has an accuracy of 100%, 97.92 and 97.34. Training, validation, and testing accuracy respectively, and it is superior to all the other models which have been done, like BGG16 inception v3 and AlexNet. So these are the reference papers which I have gone through. Thank you so much for such a wonderful opportunity provided to me.
Thank you so much for this interesting presentation. Now we have the paper titled Extracting Drug-Related Tweets in COVID-19 Pandemic, authored by Narjis Abbasi, Hamed Nejad from University of Barjand, Professor Wathiq Mansour from University of Dubai, and Dr. Fatma Salmani from University of Barjand, which will be presented next.
Hello, I am Nargis Abbasi, a master's student in computer from Barjand University. The title of the accepted article that I am going to present is Extracting Drug-Related Tweets in COVID-19 Pandemic.
My presentation is as follows: introduction, related work, proposed method, evaluation, discussion, and conclusion. Numerous comments from various world regions have been posted during the COVID-19 outbreak regarding the impact of drugs used on the COVID-19 disease. To analyze which one requires a data set of users' comment on drugs and COVID-19. Alongside this paper proposes a method for extracting drug-related tweets from the COVID-19 tweets dataset. Currently, social networking activity has taken over a significant part of people's life, especially in recent years when the COVID-19 pandemic has reduced face-to-face interactions. This has led to many comments about the COVID-19 virus being published on social media. By analyzing these opinions, one can gain insight into people's thoughts and emotions and gain valuable information. Social network data constitute the basic data set for natural language processing analysis. In the field of COVID-19, there are also different analyses of the opinions of social network users. The impact of the drugs used on COVID-19 is a popular topic among social media users. In addition, tweets from January 31 to April 23, 2020 were analyzed to examine users' views and concerns about drugs. The keyword of COVID and addiction were used to extract relevant tweets from the several countries. Finally, 3,301 tweets containing COVID and addiction were obtained. Additionally, in a separate study, tweets related to COVID-19 were analyzed to determine users' views and concerns about gambling addiction. The terms addiction and gambling were applied to a set of tweets related to COVID-19 posted in English between April 17 and 24, 2020. A total of 371 tweets were retrieved in the final search. Finally, the researchers obtained 144 unique tweets that were sent by 143 unique users, respectively. In the cited studies, many relevant tweets are erroneously discarded due to the lack of consideration of a broad range of keywords associated with drugs and gambling addiction. As a result, these researchers likely failed to identify most tweets related to drugs and gambling. In this study, we considered a dataset containing 5,911,000 1,252 English tweets posted from 23 March to 23 June 2020, containing one of the keywords corona, coronavirus, COVID, pandemic, SARS-CoV-2, or COVID-19. We propose a lexicon-based method, which is a natural language processing method for extracting drug-related tweets. A lexicon containing common drug terms such as addictive, synthetic, and herbal drugs was compiled using the Addiction Center and Oxford databases. The collected COVID-19 tweets were analyzed using the lexicon, which contained 557 related words. Then the drug-related tweets were extracted and compiled so that every word in the lexicon was matched with each word in the tweets. If the lexicon words appeared in tweets, the tweets were classified as drug-related. The initial lexicon containing 557 words resulted in the selection of 2,063,499 tweets. Afterward, the tagged tweets were examined, and the words that resulted in false tags were eliminated from the lexicon. The process was then iterated. Finally, we arrived at a lexicon of 132 words yielding 31,228 tweets following the 3 stages of lexicon filtering. To evaluate the proposed method, 3 criteria of precision, recall, and F1 score were calculated. Precision is a criterion that determines the percentage of true tweets returned by the proposed method. The recall criterion focuses primarily on the proportion of desired tweets that are retrieved. The F1 measure is on average between precision and recall parameters and fluctuates based on the precision and recall values. After applying the initial lexicon containing 557 words to the COVID-19 related data set, 2,063,499 tweets are obtained. Then 100 tweets are selected at random, with 20 tweets pertaining to drugs and 80 tweets unrelated to drugs. The preliminary lexicon has a precision value of 0.20. Given the low precision value, the proposed lexicon is modified, increasing its word to 376. When the modified lexicon is applied to the COVID-19 related data set, 643,615 tweets are obtained. At this time, the precision value is 0.48, which is not a high value. Thus, we modify the lexicon once. Further, by increasing the number of words to 132, after applying the ultimate lexicon to the COVID-19 related data set, 31,228 drug-related tweets with a precision of 0.78 are extracted. In order to calculate the recall evaluation index, 100 tweets from the COVID-19 related data are selected at random and analyzed. We delete irrelevant tweets and replace them with other tweets. There are 20 tweets about drugs and 80 that are unrelated. We applied the 557-word lexicon to 20 tweets related to drugs, which correctly recognizes the 20 tweets. The recall value of this lexicon is 1. Next, we apply the 376-word lexicon to the 20 relevant tweets, which correctly identifies 10 tweets related to drugs. The recall value of this lexicon is therefore 0.50. We eventually apply the 132-word lexicon to 20 tweets pertaining to drugs. The lexicon correctly identifies 9 related tweets. Consequently, 0.45 is the recall value for this lexicon. Table displays the precision recall, and F1 values calculated in 3 stages. The proposed lexicon contains herbal and synthetic drugs, including opium, opiates, heroin, cocaine, cigarette, nicotine, alcohol, marijuana, tobacco, liquor, poppy, etc., and some addictive drugs such as methadone, tramadol, dexamethasone, and morphine, among others. This lexicon identifies a vast array of drug-related tweets, whereas in previous research 8 and 9, only 1 or 2 keywords were used to extract related tweets. As the precision, recall, and F1 parameters were not calculated in prior research, we used the COVID-19 related dataset to obtain the values of these metrics for prior research 8 by applying the keyword addiction to the COVID-19 related dataset. Eventually, 418 drug-related tweets are collected. We select 100 drug-related tweets at random from a pool of 418. The precision value for it is 0.84. Moreover, to compute the recall value, we build on sampling to select 100 tweets from the dataset pertaining to COVID-19 for which the recall value is 0.15. In addition, in research 9, the keywords addiction and gambling were applied to the COVID-19 related dataset, yielding 807 tweets relating to gambling. We select 100 tweets at random from a total of 807 tweets on gambling and determine the precision value to be 0.36. Similarly, in order to calculate the recall value, 100 tweets related to COVID-19 were extracted from the dataset and analyzed, yielding a recall value of 0.66. Note, research 8 and 9 are related works to our article in slide 5. Figure compares the precision, recall, and F1 values of this study's proposed method with those of previous studies. Future research could expand the current studies methodology by incorporating natural language processing techniques such as sentiment analysis and by building on clustering techniques. Thanks for your attention.
Thank you very much. Now we will move to another paper titled Predicting Cardiovascular Disease in Patients with Machine Learning and Feature Engineering Techniques, authored by Dr. Piyush Maheshwari from British University in Dubai, Dr. Sapna Tayaji, and Dr. Priti Sirohi from Institute of Management Studies in India.
Hello everyone, I'm Dr. Sapna, and today I'm presenting my research work. The title of my work is Predicting Cardiovascular Disease in Patients with Machine Learning and Feature Engineering Techniques. As we know that condition affecting the heart and the blood arteries are called heart disease. And there are factors like smoking, excessive alcohol, caffeine use, stress, physical inactivity that can cause the heart disease. All of these factors, as well as psychological variables like obesity, high blood pressure, and pre-existing cardiac conditions contribute to the development of heart disease. As heart disease is actually a critical problem, it is very much vital to diagnose or forecast it well in advance. As per WHO statistics, cardiovascular disease is the leading cause of mortality in the world. As per WHO, it is estimated 12 million deaths every year due to the heart disease. The diagnosis of the disease is very significant and tedious task, and the treatment of this disease is actually very high and not affordable by many of the people, especially in the countries like India and underdeveloping countries. We know that technology is widespreading in almost every field, and healthcare is healthcare is one of the industry where the technology is spreading a lot. It is an industry that is constantly evolving. New technologies and treatments are being developed all the time, which can make it difficult for healthcare professionals to keep it up. Machine learning technology has become one of the most popular buzzwords in healthcare. Machine learning is a specific type of artificial intelligence that allows systems to learn from the data, unlike the traditional programming, and detect patterns without much human intervention. For the healthcare industry, machine learning is particularly valuable because it can help in making sense of the massive amount of healthcare data which is being generated through electronic health record. Nowadays, we are using mobile apps, web applications for our all healthcare related applications for our medicines, for our consultations, for any other healthcare related service. We are heavily dependent on these kind of digital platforms, and which are in turn generating a huge amount of data. Therefore, machine learning in healthcare will help us in finding the patterns and insight that would be impossible to find manually. As machine learning in healthcare gains widespread adoption, healthcare providers have an opportunity to take a more predictive approach that creates a more unified system with improved care delivery and patient-based process. In a nutshell, we can use the machine learning in improving the diagnosis, developing a new treatments, reducing the cost, improving care, prescription of the medicine, and whatnot else. For this work, we have predicted the heart disease using a machine learning techniques. It helps in reducing the treatment cost by providing the effective treatment well on time. For this work, we have used the model, logistic regression model, to predict the heart disease. Logistic regression is one of the most popular machine learning algorithm, which comes under the supervised learning technique. Supervised learning technique is that kind of a technique where the data is labeled. So therefore, in this work, we are using the data set, which is well labeled. That means we have a set of data which of the patients which are having the heart disease, and some of the patients are already there which are not having the heart disease, along with their independent variables. Logistic regression predicts the output of categorical dependent variable using a sigmoid function that actually calculates the probability. And based on the probabilities, we predict the target variable as 1 and 0. So 0 is the absence of the disease and 1 is the presence of the disease. This is the methodology we have used for this work. So data set we have captured, we have taken from the UCI, that's a Cleveland data set. Then we have applied various data preprocessing steps. Then we have also performed feature selections, and then finally to the data model, and then finally to the results. This is our data set, and associated with it, it's a description and the frequency, overall description of the data set. You can see here age, sex, chest pain, blood pressure, cholesterol, blood sugar, rest ECG, maximum heart rate, exercise-induced angina, depression, slope, vessels, thalassemia. These are the independent variables which are going to predict for our target variable, that is heart disease. That is your heart disease. The next step we performed on our data is to look for the null values and the noisy data. As data pre-processing is the technique of preparing the raw data to make it suitable for building and training the machine learning model. So in this work, we have used the simple imputer functions to handle our missing values. We have also removed our outliers by using the mean and the median values. Next step which we have performed is the feature engineering. Nowadays, we have a we are generating a huge amount of data that is multidimensional. We have a lot of features, and all the features do not contribute to the final prediction of the target variable. Therefore, in this research work, we have paired machine learning algorithm with a feature selection algorithm to achieve the better accuracy. The feature selection techniques are used to select the fewest possible feature variable that contribute to the prediction variable or output. We have used the Pearson correlation and select k-best. After performing the feature engineering, that is Pearson correlation and select k-best, we are able to find out the best features, that is age, chest pain, blood sugar, cholesterol, maximum heart rate, exercise-induced angina, depression, vessels. We have also applied a lot of optimization method to improve our model performance. We have used cross-validation, tenfold cross-validation approach for removing any biasness and for handling our overfitting and underfitting issues, which happens during the machine learning process. Results. Before applying to the logistic regression model, we have divided our data set into the training and the testing. 70% of the data is kept for the training, and 30% of the data we have kept for the testing. The model's accuracy with features engineering and cross-validation is 77% with the test data and 80% with the training data. Then we have also performed feature engineering. So that time, the feature after performing the feature engineering, that is, when we have used with a limited number of features, the accuracy of the model achieved is 81% on a complete data set. Then we have also performed tenfold cross-validation for improving our model. And at that time, after applying this tenfold cross-validation, the average accuracy is around 76.5% with a standard deviation of 10.2. So therefore, we can conclude here that along with the machine learning algorithm, if we keep on applying feature engineering and cross-validation, then we will be able to achieve the more better accuracy. Now, for the future work, we would like to increase our database set. So we would like to have more data set. We would like to also see the impact of other models. We want to test SVM model. We want to test decision tree classifier, and then maybe we can compare with what logistic regression is giving to us. And then finally, we can think of which model can be used best and best for the upcoming situation for the future. Thank you so much.
Thank you so much for this interesting presentation. We have the paper titled A Correlational Investigation of Personal Medical Data Safety and Blockchains, authored by Vernon Lewis and Piyush Maheshwari from British University in Dubai, which will be presented next.
Good day to one and all. My name is Vernon Lewis. I'm a member of the Faculty of Engineering and IT at the British University in Dubai. It is my privilege to present my study and findings at the International Conference, Signal Processing and Information Security. The study is titled A Correlational Investigation of Personal Medical Data Safety and Blockchains. Without further ado, let us begin. The following are the contents of my presentation. We will begin with a brief introduction, followed by a detailed discussion on the healthcare data status and the advantage of blockchains in the healthcare domain. We will then discuss the framework, methodology, results, and analysis of the data collected for this study. We will conclude with the limitations and the future scope of this study. Blockchains have been around for over a decade, and they've been widely adopted into the financial domain, in specific the decentralized financial domain. No trust model implementation eliminates the need for a middleman in conducting transactions. This has led to development of over 25 cryptocurrencies and has, in result, made it hard for blockchains to break free of the shackles of its most important implementation, or most, rather than important, the most popular implementation. The blockchain characteristics have found purpose in various other domains, including supply chain, e-governments, and healthcare. With its obvious advantages, it is a surprise that the real-world implementations are relatively slow and only a handful. Like any new technology, requires a catalyst to help propagate it. For example, the internet boomed under the development of handheld devices and mobile computing. the blockchain is in need of one such catalyst. In specific, the blockchain in healthcare needs one such catalyst. And analyzing the healthcare domain, it is evident that the end users are the people and in specific the patients themselves. And in essence, for a blockchain healthcare system implementation, it would be ideal that these people or patients are the catalysts of the system who help blockchains get adopted into mainstream usage. Hence, it's the focus of the study to gain the user perspective on their medical data and safety, with blockchains being in the vicinity of their perception. Before we dive into the framework and results of the study, it is necessary to understand why there is need for development in healthcare data management and protection. It was estimated that by 2020, over 2,300 exabytes of healthcare data would be generated. This was before the onset of the pandemic. And with the pandemic in the picture, it is intuition that says that the estimate is relatively low. Over 161 million health records have been exposed up until 2019, and the cause could be anywhere between data breaches and hacking. In the first half of 2022 alone, over 20 million healthcare data breaches were recorded in the United States. In another case, over 14,000 HIV patients had their personal information leaked due to a data breach incident. Now, bringing this into picture, it is evident that the current implementations or current systems are inadequate in maintaining the security of the healthcare data. It is not to say that they are absolutely inefficient. In fact, the 20 million data breaches in the United States in 2020 is 26% lesser than the previous year. This does, although this does provide a strong argument for blockchain implementations in healthcare. Again, we're not going as far as to say that blockchains are absolute, but through literature, it is evident that errors in blockchain have majorly involved a considerable amount of human errors. So blockchains could be a one-stop solution within the healthcare domain. And why do we make this point? Is because we look at the advantages blockchains have in the healthcare domain. Healthcare data needs trust as an inherent factor, and blockchains have trust induced into the system in the form of the consensus mechanism. Various consensus mechanisms have been developed over time, with proof of work and proof of stake being the most popular. Proof of work being a little more controversial in terms of their environmental impact and the possibility of centralization due to nodes with higher computing power. Proof of stake has advantages and allows equal rights for the participating nodes to stake a claim to verify the data. Apart from trust alone, it was also necessary to understand what other factors are necessary for healthcare data. And for this, we looked at the various data laws across various countries. And these data laws outline accountability, confidentiality, and integrity as three of the primary characteristics of healthcare data. Various blockchain implementations have addressed these characteristics. For example, a blockchain implementation addressed accountability in the form of transferring the control of data to the users themselves, where they decide who gets to access the data, what happens to the data, and they get to see what changes have been made to their personal medical data. Another study addressed confidentiality by bringing into the network key management and cryptographic entity, which was responsible for managing public and private keys, and hence maintaining the anonymous nature of the participants in the network. And another study addressed integrity. Although integrity is an inherent characteristic of blockchain itself, the data that is present is almost always non-repudiated and can be verified for historic accuracy. With these advantages, it is evident that blockchains are in fact feasible and an ideal fit for the healthcare, for any healthcare implementation. Moving on to the framework of the study. The framework builds on literature and behavioral assessments, which has been translated into data collections. People can visit a number of hospitals in a number of cities over time and generate a number of electronic health records. They can also have access to a number of electronic devices with which they use to access their personal information. Safety as an aspect has been identified as a major entity of both the electronic health records and the electronic devices. As visible from the framework, we have not associated blockchains with the people directly. This is because this study assumes that people have minimal knowledge of blockchains. This will be tested further down in this study. The blockchains are directly associated with the electronic health record alone, and this again is from literature where most of the proposals or implementations have been with regarding to the data alone. Moving on. With the framework in hand, we developed a survey, which thus makes this a quantitative research methodology. We have prefix responses for the 27 questions developed, and also questions with visual analog scales to measure extremities. The study had 4 predefined sections: general information, individuals' experience with healthcare organizations, access control and safety aspects of healthcare data, and knowledge of blockchains. Moving on to the results of the study, the survey received an almost equal split in terms of the gender of the respondents. The age of the respondents was another factor that was measured and is an important variable in this study. Over 80% of the respondents were below the age of 34. 18% of the respondents were above the age of 35 and below the age of 55. This suggests that we have a pretty decent split with regarding to age as a variable. Before jumping into analyzing data, it was necessary to establish whether the data was adequate. We considered and we performed the Kaiser-Meyer-Olkin or the KMO test. And a KMO value greater than 0.5 suggested that there is significant overlap between the variables of the data sample. We also checked whether the data is fit for factor analysis. The Bartlett's test was conducted for this, and the significant Bartlett's value establishes that there are relationships inherent to the variables in this data set. In order to understand how many factors or hidden factors are there in the data, we perform the principal component analysis test. Through the results of this test, it is evident that there are 3 factors that explain 71% of the variances among the sample set. We then move ahead to perform the exploratory factor analysis, and we considered only the metric values for this test. There are 9 metric values in our survey, but we considered only 8 of them, discarded 1 because it had a fairly insignificant KMO value. After analyzing the variable rotated matrix results, the study inferred 3 hidden factors as follows: personal healthcare data safety, importance of control in healthcare data, and data access using personal devices. We will carry this forward. We'll carry these interpreted factors forward into the first case of analysis. We first analyze whether age is a deciding factor. We conduct a one-way ANOVA test with age as the independent variable and the 3 interpreted factors as the dependent variables. The hypothesis developed for this test is as follows. The null hypothesis goes like this: age has no significance on the individual's perception of interpreted factors, and the alternative hypothesis is that age has significance on the individual's perception of interpreted factors. From the results of the ANOVA test, it's visible that that the p-value is insignificant, and hence we fail to reject the null hypothesis. This thus results in the study assuming that people have developed socially acceptable norms in terms of personal data safety, and during the pandemic, they have increased familiarity with electronic devices and how they work. With regards to accessing personal medical data or any other data. The next test was regarding the knowledge of blockchain, and for this, we consider just 2 variables. One is the identified inherent variable, which here is the independent variable, and the dependent variable is the people's knowledge of blockchains, or have they heard of the term blockchains before? A boxes M test was conducted for this. The hypothesis for this test goes as follows. The null hypothesis is that the variance of the dependent variable are equal. The alternative hypothesis is that the variances of the dependent variable are not equal. The significant value, or the value of the boxes M tests, helps us reject the null hypothesis, and it thus establishes that people's familiarity with working with their devices is an important factor in people's perception and knowledge of blockchain and whether they've come across the term blockchains. Now, on analyzing the data sample set, it was evident that 69% of the population had heard of the term blockchains before. 78% of the population have heard of the term Bitcoin before. But there's a caveat here where 17% of the population believe that both Bitcoin and blockchain are the same entity. This thus supports our previous assumption that people have minimal, or people have misconceptions about blockchains and Bitcoin being the same entity. Again, this does also support our previous statement saying that blockchains have not been able to break free of their shackles of their most popular implementation. From this test, it is evident that for blockchains to be successful, it is important to keep it in familiar grounds to the end users themselves. So app-based implementations of blockchains in healthcare are ideal and necessary to help propagate and help its adoption into mainstream usage faster. Moving on to the limitations and future implications. Education as a variable and people's work experience has not been considered for this study, but the author does believe that these are important factors and are the future scope of this study, where understanding the perception of people with experience in the respective fields could help establish a benchmark for the regular or other users to move forward to. In conclusion, this study identified why blockchains are an ideal fit for the healthcare domain. We built a conceptual framework for data collection. We performed quantitative analysis on the data set. We established that age is not a significant factor that affects people's perception of data safety and security. We did establish that people's familiarity with electronic devices or their personal devices has an effect on their perspective or knowledge of blockchains. The study concluded by saying that an app-based approach to a blockchain healthcare system is necessary to help propagate blockchains in the healthcare domain. I thank you for your time.
Thank you very much. This is the end of session 3. Now we will have a lunch break and we will be back at 1. Thank you.
The University of Dubai, UD, was founded in 1997 by the Dubai Chamber of Commerce and Industry. In June 2006, His Highness Sheikh Mohammed bin Rashid Al Maktoum, Vice President and Prime Minister of the UAE and ruler of Dubai, granted the university 3 million square feet of land in Academic City for construction of a green and sustainable campus. In addition to the UD campus buildings being LEED certified, the campus is also the first net zero energy building in the region, following the implementation of a solar power project at its campus. The university, which is licensed by the UAE Ministry of Education, has several professional certifications and 2 major international accreditations, AACSB and Abbott. It offers a variety of business, law, engineering, and IT programs. The university is committed to developing and educating leaders who can make a difference in the business world. The achievements of the University of Dubai's 3,000 alumni in various organizations and ranks of leadership are a reflection of this commitment. The university is also a hub for several research and business centers, including the Center of Business Research and Consultancy, CBRC, and the Entrepreneurship and Innovation Free Zone, EIFC. Likewise, the university's student services and alumni affairs units offer an abundance of engagement opportunities and extracurricular activities inside and outside the classroom that meet the students' diverse interests and enrich their learning experience. During and after the students' graduation period, the Internship and Career Development Center staff make sure to build a relationship between the students and employers and provide them with opportunities that help them pursue their dream jobs. In addition to its bachelor's, master's, and PhD degrees, the university offers professional training through its Center for Executive Development, also known as CED. The center designs and delivers customized executive management development programs along with open enrollment workshops, internationally accredited professional certifications, and online learning opportunities, in addition to national Emiratization initiatives.
University of Dubai, the first LEED certified net zero building in the region. Ground-mounted solar panels spreading over 2 kilometers have been installed on the campus. They connect to the existing grid and produce solar energy to fulfill 100% of the university's electrical needs annually. The panels surround the campus to maximize solar contact to a capacity of 1,700 kilowatt peak per day, helping the university reduce CO2 emissions by 2,040 tons and save 1.2 million dirham annually. In 5 years, costs invested will be recovered, and the university's energy bill will be zero for the next 30 years. The project was approved and implemented by Dewa Sham's Dubai Solar Program to support His Highness Sheikh Mohammed bin Rashid Al Maktoum's vision of having all buildings in Dubai to be zero energy by 2030. The Dubai Chamber is proud to be a pioneer in green building and contribute to Dubai's sustainable city vision.
It has been 3 years since my grandmother Teta Layla passed away. She was a loving, beautiful old lady. Alhamdulillah, she lived a full life, almost 90 years. I still remember her voice when I visited her in her beautiful house in the mountains. She used to greet me and say, "Taya binti, Taya busik." Teta Layla raised 10 kids, including my father. They all went to school and graduated from universities. This is why she used to always tell me, "You must study hard, ya binti. Always study hard to graduate from the top universities." Oh, Teta, don't worry. I promise you to study hard to graduate from the top university.
Every organization in the world gives priority to lifelong learning. And this is the reason why University of Dubai, through Center for Executive Development, offers professional training and professional certificates in order to develop the capabilities of human capital in UAE. So I urge everybody to be a part of this lifelong learning process in order to be ready for the jobs of the future.
Welcome to the University of Dubai and the Center for Executive Development Training Program. The University of Dubai was founded in 1997 by Dubai Chamber of Commerce to provide quality education and to develop human resources in the private and public sectors. The university's campus is a smart and green campus where business, IT, engineering, and law studies are provided in addition to various professional education programs. Most of the university programs are accredited internationally, like AACSB for business and Abbott for IT. The university provides bachelor's, master's, and PhD in business administration. Further, the College of Engineering and IT offers bachelor's and master's. Lastly, the university also provides Masters of Law in Financial Crimes and Arbitration.
A big welcome to all of you. I'm Dr. Vidya, the Director at the Center for Executive Development at University of Dubai. We believe that your learning journey is a never-ending one. When you finish your degree, you enter the University of Life, which requires continuous learning to keep you relevant in the job market. Since our inception over 15 years ago, the center has trained over 10,000 professionals in diverse fields from traditional to new age, from business to engineering and technology, and even entrepreneurship. We want you to know that at UD, quality is paramount, whether it's referred to in relation to content, delivery, student involvement, or engagement. We are proud of our huge talent of trainers, coaches, and mentors who design and deliver cutting-edge and hands-on programs in the region. Our trainers come from a variety of backgrounds, including both practitioners and professors. We have converted successfully our entire range of programs to the virtual platform with very engaging and dynamic delivery. In addition to public courses, we are also known for the customized programs that we offer to large key clients in multiple locations successfully.
His Highness Sheikh Mohammed bin Rashid Al Maktoum said, "Training opens your eyes to weaknesses, boosts your self-confidence, and brings you one step closer to victory." Our team at the Center for Executive Development is eager to help you get your victory. If you need anything during the training, do not hesitate to ask one of our team members. We look forward to taking this learning journey with you and hope you enjoy the experience.
Since 1998, Dubai Chamber has been committed to sustainability by reducing energy consumption and improving its environmental performance. This has resulted in the Chamber saving more than 21 million dirham over 15 years, becoming the first existing LEED certified building in the Arab world in 2009 and LEED Platinum in 2013 and 2018. Furthering its commitment, and as part of Dubai's vision to produce 75% of its energy from clean sources by 2050, Dubai Chamber has now also made its education initiative. The University of Dubai, the first LEED certified net zero building in the region. Ground-mounted solar panels spreading over 2 kilometers have been installed on the campus. They connect to the existing grid and produce solar energy to fulfill 100% of the university's electrical needs annually. The panels surround the campus to maximize solar contact to a capacity of 1,700 kilowatt peak per day, helping the university reduce CO2 emissions by 2,040 tons and save 1.2 million dirham annually. In 5 years, costs invested will be recovered, and the university's energy bill will be zero for the next 30 years. The project was approved and implemented by Diwa Sham's Dubai Solar Program to support His Highness Sheikh Mohammed bin Rashid Al Maktoum's vision of having all buildings in Dubai to be zero energy by 2030. The Dubai Chamber is proud to be a pioneer in green building and contribute to Dubai's sustainable city vision.
The University of Dubai, UD, was founded in 1997 by the Dubai Chamber of Commerce and Industry. In June 2006, His Highness Sheikh Mohammed bin Rashid Al Maktoum, Vice President and Prime Minister of the UAE and ruler of Dubai, granted the university 3 million square feet of land in Academic City for construction of a green and sustainable campus. In addition to the UD campus buildings being LEED certified, the campus is also the first net zero energy building in the region, following the implementation of a solar power project at its campus. The university, which is licensed by the UAE Ministry of Education, has several professional certifications and 2 major international accreditations, AACSB and Abbott. It offers a variety of business, law, engineering, and IT programs. The university is committed to developing and educating leaders who can make a difference in the business world. The achievements of the University of Dubai's 3,000 alumni in various organizations and ranks of leadership are a reflection of this commitment. The university is also a hub for several research and business centers, including the Center of Business Research and Consultancy, CBRC, and the Entrepreneurship and Innovation Free Zone, EIFC. Likewise, the university's student services and alumni affairs units offer an abundance of engagement opportunities and extracurricular activities inside and outside the classroom that meet the students' diverse interests and enrich their learning experience. During and after the students' graduation period, the Internship and Career Development Center staff make sure to build a relationship between the students and employers and provide them with opportunities that help them pursue their dream jobs. In addition to its bachelor's, master's, and PhD degrees, the university offers professional training through its Center for Executive Development, also known as CED. The center designs and delivers customized executive management development programs, along with open enrollment workshops, internationally accredited professional certifications, and online learning opportunities, in addition to national emeritization initiatives.
University of Dubai, the first LEED certified net zero building in the region. Ground-mounted solar panels spreading over 2 kilometers have been installed on the campus. They connect to the existing grid and produce solar energy to fulfill 100% of the university's electrical needs annually. The panels surround the campus to maximize solar contact to a capacity of 1,700 kilowatt peak per day, helping the university reduce CO2 emissions by 2,040 tons and save 1.2 million dirham annually. In 5 years, costs invested will be recovered, and the university's energy bill will be zero for the next 30 years. The project was approved and implemented by Diwa Shams Dubai Solar Program to support His Highness Sheikh Mohammed bin Rashid Al Maktoum's vision of having all buildings in Dubai to be zero energy by 2030. The Dubai Chamber is proud to be a pioneer in green building and contribute to Dubai's sustainable city vision.
It has been 3 years since my grandmother Tita Layla passed away. She was a loving, beautiful old lady. Alhamdulillah, she lived a full life, almost 90 years. I still remember her voice when I visited her in her beautiful house in the mountains. She used to greet me and say, "Taya binti, Taya busik." Tita Layla raised 10 kids, including my father. They all went to school and graduated from universities. This is why she used to always tell me, "You must study hard, ya binti. Always study hard to graduate from the top universities." Oh, Tita, don't worry. I promise you to study hard to graduate from the top university.
Every organization in the world gives priority to lifelong learning. And this is the reason why University of Dubai, through Center for Executive Development, offers professional training and professional certificates in order to develop the capabilities of human capital in UAE. So I urge everybody to be a part of this lifelong learning process in order to be ready for the jobs of the future.
Welcome to the University of Dubai and the Center for Executive Development Training Program. The University of Dubai was founded in 1997 by Dubai Chamber of Commerce to provide quality education and to develop human resources in the private and public sectors. The university's campus is a smart and green campus where business, IT, engineering, and law studies are provided in addition to various professional education programs. Most of the university programs are accredited internationally, like ICSPIS for business and Abbott for IT. The university provides bachelor's, master's, and PhD in business administration. Further, the College of Engineering and IT offers bachelor's and master's. Lastly, the university also provides Masters of Law in Financial Crimes and Arbitration.
A big welcome to all of you. I'm Dr. Vidya, the Director at the Center for Executive Development at University of Dubai. We believe that your learning journey is a never-ending one. When you finish your degree, you enter the University of Life, which requires continuous learning to keep you relevant in the job market. Since our inception over 15 years ago, the center has trained over 10,000 professionals in diverse fields from traditional to new age, from business to engineering and technology, and even entrepreneurship. We want you to know that at UD, quality is paramount, whether it's referred to in relation to content, delivery, student involvement, or engagement. We are proud of our huge talent of trainers, coaches, and mentors who design and deliver cutting-edge and hands-on programs in the region. Our trainers come from a variety of backgrounds, including both practitioners and professors. We have converted successfully our entire range of programs to the virtual platform with very engaging and dynamic delivery. In addition to public courses, we are also known for the customized programs that we offer to large key clients in multiple locations successfully.
His Highness Sheikh Mohammed bin Rashid Al Maktoum said, "Training opens your eyes to weaknesses, boosts your self-confidence, and brings you one step closer to victory." Our team at the Center for Executive Development is eager to help you get your victory. If you need anything during the training, do not hesitate to ask one of our team members. We look forward to taking this learning journey with you and hope you enjoy the experience.
Since 1998, Dubai Chamber has been committed to sustainability by reducing energy consumption and improving its environmental performance. This has resulted in the Chamber saving more than 21 million dirham over 15 years, becoming the first existing LEED certified building in the Arab world in 2009 and LEED Platinum in 2013 and 2018. Furthering its commitment, and as part of Dubai's vision to produce 75% of its energy from clean sources by 2050, Dubai Chamber has now also made its education initiative, the University of Dubai, the first LEED certified net zero building in the region. Ground-mounted solar panels spreading over 2 kilometers have been installed on the campus. They connect to the existing grid and produce solar energy to fulfill 100% of the university's electrical needs annually. The panels surround the campus to maximize solar contact to a capacity of 1,700 kilowatt peak per day, helping the university reduce CO2 emissions by 2,040 tons and save 1.2 million dirham annually. In 5 years, costs invested will be recovered, and the university's energy bill will be zero for the next 30 years. The project was approved and implemented by Diwa Sham's Dubai Solar Program to support His Highness Sheikh Mohammed bin Rashid Al Maktoum's vision of having all buildings in Dubai to be zero energy by 2030. The Dubai Chamber is proud to be a pioneer in green building and contribute to Dubai's sustainable city vision.
The University of Dubai, UD, was founded in 1997 by the Dubai Chamber of Commerce and Industry. In June 2006, His Highness Sheikh Mohammed bin Rashid Al Maktoum, Vice President and Prime Minister of the UAE and ruler of Dubai, granted the university 3 million square feet of land in Academic City for construction of a green and sustainable campus. In addition to the UD campus buildings being LEED certified, the campus is also the first net zero energy building in the region, following the implementation of a solar power project at its campus. The university, which is licensed by the UAE Ministry of Education, has several professional certifications and 2 major international accreditations, AACSB and Abbott. It offers a variety of business, law, engineering, and IT programs. The university is committed to developing and educating leaders who can make a difference in the business world. The achievements of the University of Dubai's 3,000 alumni in various organizations and ranks of leadership are a reflection of this commitment. The university is also a hub for several research and business centers, including the Center of Business Research and Consultancy, CBRC, and the Entrepreneurship and Innovation Free Zone, EIFC. Likewise, the university's student services and alumni affairs units offer an abundance of engagement opportunities and extracurricular activities inside and outside the classroom that meet the students' diverse interests and enrich their learning experience. During and after the students' graduation period, the Internship and Career Development Center staff make sure to build a relationship between the students and employers and provide them with opportunities that help them pursue their dream jobs. In addition to its bachelor's, master's, and PhD degrees, the university offers professional training through its Center for Executive Development, also known as CED. The center designs and delivers customized executive management development programs, along with open enrollment workshops, internationally accredited professional certifications, and online learning opportunities, in addition to national emeritization initiatives.
University of Dubai, the first LEED certified net zero building in the region. Ground-mounted solar panels spreading over 2 kilometers have been installed on the campus. They connect to the existing grid and produce solar energy to fulfill 100% of the university's electrical needs annually. The panels surround the campus to maximize solar contact to a capacity of 1,700 kilowatt peak per day, helping the university reduce CO2 emissions by 2,040 tons and save 1.2 million dirham annually. In 5 years, costs invested will be recovered, and the university's energy bill will be zero for the next 30 years. The project was approved and implemented by Diwa Shams Dubai Solar Program to support His Highness Sheikh Mohammed bin Rashid Al Maktoum's vision of having all buildings in Dubai to be zero energy by 2030. The Dubai Chamber is proud to be a pioneer in green building.
The University of Dubai, UD, was founded in 1997 by the Dubai Chamber of Commerce and Industry. In June 2006, His Highness Sheikh Mohammed bin Rashid Al Maktoum, Vice President and Prime Minister of the UAE and ruler of Dubai, granted the university 3 million square feet of land in Academic City for construction of a green and sustainable campus. In addition to the UD campus buildings being LEED certified, the campus is also the first net zero energy building in the region, following the implementation of a solar power project at its campus. The university, which is licensed by the UAE Ministry of Education, has several professional certifications and 2 major international accreditations, AACSB and Abbott. It offers a variety of business, law, engineering, and IT programs. The university is committed to developing and educating leaders who can make a difference in the business world. The achievements of the University of Dubai's 3,000 alumni in various organizations and ranks of leadership are a reflection of this commitment. The university is also a hub for several research and business centers, including the Center of Business Research and Consultancy, CBRC, and the Entrepreneurship and Innovation Free Zone, EIFC. Likewise, the university's student services and alumni affairs units offer an abundance of engagement opportunities and extracurricular activities inside and outside the classroom that meet the students' diverse interests and enrich their learning experience. During and after the students' graduation period, the Internship and Career Development Center staff make sure to build a relationship between the students and employers and provide them with opportunities that help them pursue their dream jobs. In addition to its bachelor's, master's, and PhD degrees, the university offers professional training through its Center for Executive Development, also known as CED. The center designs and delivers customized executive management development programs, along with open enrollment workshops, internationally accredited professional certifications, and online learning opportunities, in addition to national emeritization initiatives.
University of Dubai, the first LEED certified net zero building in the region. Ground-mounted solar panels spreading over 2 kilometers have been installed on the campus. They connect to the existing grid and produce solar energy to fulfill 100% of the university's electrical needs annually. The panels surround the campus to maximize solar contact to a capacity of 1,700 kilowatt peak per day, helping the university reduce CO2 emissions by 2,040 tons and save 1.2 million dirham annually. In 5 years, costs invested will be recovered, and the university's energy bill will be zero for the next 30 years. The project was approved and implemented by Diwa Shams Dubai Solar Program to support His Highness Sheikh Mohammed bin Rashid Al Maktoum's vision of having all buildings in Dubai to be zero energy by 2030. The Dubai Chamber is proud to be a pioneer in green building and contribute to Dubai's sustainable city vision.
It has been 3 years since my grandmother Tita Layla passed away. She was a loving, beautiful old lady. Alhamdulillah, she lived a full life, almost 90 years. I still remember her voice when I visited her in her beautiful house in the mountains. She used to greet me and say, "Taya binti, Taya busik." Tita Layla raised 10 kids, including my father. They all went to school and graduated from university. This is why she used to always tell me, "You must study hard, ya binti. Always study hard to graduate from the top university." Oh, Tita, don't worry. I promise you to study hard to graduate from the top university.
Every organization in the world gives priority to lifelong learning. And this is the reason why University of Dubai, through Center for Executive Development, offers professional training and professional certificates in order to develop the capabilities of human capital in UAE. So I urge everybody to be a part of this lifelong learning process in order to be ready for the jobs of the future.
Welcome to the University of Dubai and the Center for Executive Development Training Program. The University of Dubai was founded in 1997 by Dubai Chamber of Commerce to provide quality education and to develop human resources in the private and public sectors. The university's campus is a smart and green campus where business, IT, engineering, and law studies are provided in addition to various professional education programs. Most of the university programs are accredited internationally, like AACSB for business and Abbott for IT. The university provides bachelor's, master's, and PhD in business administration. Further, the College of Engineering and IT offers bachelor's and master's. Lastly, the university also provides Masters of Law in Financial Crimes and Arbitration.
A big welcome to all of you. I'm Dr. Vidya, the Director at the Center for Executive Development at University of Dubai. We believe that your learning journey is a never-ending one. When you finish your degree, you enter the University of Life, which requires continuous learning to keep you relevant in the job market. Since our inception over 15 years ago, the center has trained over 10,000 professionals in diverse fields, from traditional to new age, from business to engineering and technology, and even entrepreneurship. We want you to know that at UD, quality is paramount, whether it's referred to in relation to content, delivery, student involvement, or engagement. We are proud of our huge talent of trainers, coaches, and mentors who design and deliver cutting-edge and hands-on programs in the region. Our trainers come from a variety of backgrounds, including both practitioners and professors. We have converted successfully our entire range of programs to the virtual platform with very engaging and dynamic delivery. In addition to public courses, we are also known for the customized programs that we offer to large key clients in multiple locations successfully.
His Highness Sheikh Mohammed bin Rashid Al Maktoum said, "Training opens your eyes to weaknesses, boosts your self-confidence, and brings you one step closer to victory." Our team at the Center for Executive Development is eager to help you get your victory. If you need anything during the training, do not hesitate to ask one of our team members. We look forward to taking this learning journey with you and hope you enjoy the experience.
Since 1998, Dubai Chamber has been committed to sustainability by reducing energy consumption and improving its environmental performance. This has resulted in the Chamber saving more than 21 million dirham over 15 years, becoming the first existing LEED certified building in the Arab world in 2009 and LEED Platinum in 2013 and 2018. Furthering its commitment, and as part of Dubai's vision to produce 75% of its energy from clean sources by 2050, Dubai Chamber has now also made its education initiative. The University of Dubai, the first LEED certified net zero building in the region. Ground-mounted solar panels spreading over 2 kilometers have been installed on the campus. They connect to the existing grid and produce solar energy to fulfill 100% of the university's electrical needs annually. The panels surround the campus to maximize solar contact to a capacity of 1,700 kilowatt peak per day, helping the university reduce CO2 emissions by 2,040 tons and save 1.2 million dirham annually. In 5 years, costs invested will be recovered, and the university's energy bill will be zero for the next 30 years. The project was approved and implemented by Diwa Sham's Dubai Solar Program to support His Highness Sheikh Mohammed bin Rashid Al Maktoum's vision of having all buildings in Dubai to be zero energy by 2030. The Dubai Chamber is proud to be a pioneer in green building and contribute to Dubai's sustainable city vision.
The University of Dubai, UD, was founded in 1997 by the Dubai Chamber of Commerce and Industry. In June 2006, His Highness Sheikh Mohammed bin Rashid Al Maktoum, Vice President and Prime Minister of the UAE and ruler of Dubai, granted the university 3 million square feet of land in Academic City for construction of a green and sustainable campus. In addition to the UD campus buildings being LEED certified, the campus is also the first net zero energy building in the region, following the implementation of a solar power project at its campus. The university, which is licensed by the UAE Ministry of Education, has several professional certifications and 2 major international accreditations, AACSB and Abbott. It offers a variety of business, law, engineering, and IT programs. The university is committed to developing and educating leaders who can make a difference in the business world. The achievements of the University of Dubai's 3,000 alumni in various organizations and ranks of leadership are a reflection of this commitment. The university is also a hub for several research and business centers, including the Center of Business Research and Consultancy, CBRC, and the Entrepreneurship and Innovation Free Zone, EIFC. Likewise, the university's student services and alumni affairs units offer an abundance of engagement opportunities and extracurricular activities inside and outside the classroom that meet the students' diverse interests and enrich their learning experience. During and after the students' graduation period, the Internship and Career Development Center staff make sure to build a relationship between the students and employers and provide them with opportunities that help them pursue their dream jobs. In addition to its bachelor's, master's, and PhD degrees, the university offers professional training through its Center for Executive Development, also known as CED. The center designs and delivers customized executive management development programs, along with open enrollment workshops, internationally accredited professional certifications, and online learning opportunities, in addition to national Emiratization initiatives.
University of Dubai, the first LEED certified net zero building in the region. Ground-mounted solar panels spreading over 2 kilometers have been installed on the campus. They connect to the existing grid and produce solar energy to fulfill 100% of the university's electrical needs annually. The panels surround the campus to maximize solar contact to a capacity of 1,700 kilowatt peak per day, helping the university reduce CO2 emissions by 2,040 tons and save 1.2 million dirham annually. In 5 years, costs invested will be recovered, and the university's energy bill will be zero for the next 30 years. The project was approved and implemented by Diwa Sham's Dubai Solar Program to support His Highness Sheikh Mohammed bin Rashid Al Maktoum's vision of having all buildings in Dubai to be zero energy by 2030. The Dubai Chamber is proud to be a pioneer in green building and contribute to Dubai's sustainable city vision.
It has been 3 years since my grandmother Tita Layla passed away. She was a loving, beautiful old lady. Alhamdulillah, she lived a full life, almost 90 years. I still remember her voice when I visited her in her beautiful house in the mountains. She used to greet me and say, "Tai ya binti, tai la busik." Tita Layla raised 10 kids, including my father. They all went to school and graduated from university. This is why she used to always tell me, "You must study hard, ya binti. Always study hard to graduate from the top university." Oh, Tita, don't worry. I promise you to study hard to graduate from the top university.
Every organization in the world gives priority to lifelong learning. And this is the reason why University of Dubai, through Center for Executive Development, offers professional training and professional certificates in order to develop the capabilities of human capital in UAE. So I urge everybody to be a part of this lifelong learning process in order to be ready for the jobs of the future.
Welcome to the University of Dubai and the Center for Executive Development Training Program. The University of Dubai was founded in 1997 by Dubai Chamber of Commerce to provide quality education and to develop human resources in the private and public sectors. The university's campus is a smart and green campus where business, IT, engineering, and law studies are provided in addition to various professional education programs. Most of the university programs are accredited internationally, like AACSB for business and Abbott for IT. The university provides bachelor's, master's, and PhD in business administration. Further, the College of Engineering and IT offers bachelor's and master's. Lastly, the university also provides masters of law in financial crimes and arbitration.
A big welcome to all of you. I'm Dr. Vidya, the Director at the Center for Executive Development at University of Dubai. We believe that your learning journey is a never-ending one. When you finish your degree, you enter the University of Life, which requires continuous learning to keep you relevant in the job market. Since our inception over 15 years ago, the center has trained over 10,000 professionals in diverse fields, from traditional to new age, from business to engineering and technology, and even entrepreneurship. We want you to know that at UD, quality is paramount, whether it's referred to in relation to content, delivery, student involvement, or engagement. We are proud of our huge talent of trainers, coaches, and mentors who design and deliver cutting-edge and hands-on programs in the region. Our trainers come from a variety of backgrounds, including both practitioners and professors. We have converted successfully our entire range of programs to the virtual platform with very engaging and dynamic delivery. In addition to public courses, we are also known for the customized programs that we offer to large key clients in multiple locations successfully.
His Highness Sheikh Mohammed bin Rashid Al Maktoum said, "Training opens your eyes to weaknesses, boosts your self-confidence, and brings you one step closer to victory." Our team at the Center for Executive Development is eager to help you get your victory. If you need anything during the training, do not hesitate to ask one of our team members. We look forward to taking this learning journey with you and hope you enjoy the experience.
Since 1998, Dubai Chamber has been committed to sustainability by reducing energy consumption and improving its environmental performance. This has resulted in the Chamber saving more than 21 million dirham over 15 years, becoming the first existing LEED certified building in the Arab world in 2009 and LEED Platinum in 2013 and 2018. Furthering its commitment, and as part of Dubai's vision to produce 75% of its energy from clean sources by 2050, Dubai Chamber has now also made its education initiative, University of Dubai, the first LEED certified net zero building in the region. Ground-mounted solar panels spreading over 2 kilometers have been installed on the campus. They connect to the existing grid and produce solar energy to fulfill 100% of the university's electrical needs annually. The panels surround the campus to maximize solar contact to a capacity of 1,700 kilowatt peak per day, helping the university reduce CO2 emissions by 2,040 tons and save 1.2 million dirham annually. In 5 years, costs invested will be recovered, and the university's energy bill will be zero for the next 30 years. The project was approved and implemented by Diwa Sham's Dubai Solar Program to support His Highness Sheikh Mohammed bin Rashid Al Maktoum's vision of having all buildings in Dubai to be zero energy by 2030. The Dubai Chamber is proud to be a pioneer in green building and contribute to Dubai's sustainable city vision.
The University of Dubai, UD, was founded in 1997 by the Dubai Chamber of Commerce and Industry. In June 2006, His Highness Sheikh Mohammed bin Rashid Al Maktoum, Vice President and Prime Minister of the UAE and ruler of Dubai, granted the university 3 million square feet of land in Academic City for construction of a green and sustainable campus. In addition to the UD campus buildings being LEED certified, the campus is also the first net zero energy building in the region, following the implementation of a solar power project at its campus. The university, which is licensed by the UAE Ministry of Education, has several professional certifications and 2 major international accreditations, AACSB and Abbott. It offers a variety of business, law, engineering, and IT programs. The university is committed to developing and educating leaders who can make a difference in the business world. The achievements of the University of Dubai's 3,000 alumni in various organizations and ranks of leadership are a reflection of this commitment. The university is also a hub for several research and business centers, including the Center of Business Research and Consultancy, CBRC, and the Entrepreneurship and Innovation Free Zone, EIFC. Likewise, the university's Student Services and Alumni Affairs units offer an abundance of engagement.
Center for Executive Development offers professional training and professional certificates in order to develop the capabilities of human capital in UAE. So I urge everybody to be a part of this lifelong learning process in order to be ready for the jobs of the future.
Welcome to the University of Dubai and the Center for Executive Development Training Program. The University of Dubai was founded in 1997 by Dubai Chamber of Commerce to provide quality education and to develop human resources in the private and public sectors. The university's campus is a smart and green campus where business, IT, engineering, and law studies are provided in addition to various professional education programs. Most of the university programs are accredited internationally, like AACSB for business and Abbott for IT. The university provides bachelor's, master's, and PhD in business administration. Further, the College of Engineering and IT offers bachelor's and master's. Lastly, the university also provides Masters of Law in Financial Crimes and Arbitration.
A big welcome to all of you. I'm Dr. Vidya, the Director at the Center for Executive Development at University of Dubai. We believe that your learning journey is a never-ending one. When you finish your degree, you enter the University of Life, which requires continuous learning to keep you relevant in the job market. Since our inception over 15 years ago, the center has trained over 10,000 professionals in diverse fields, from traditional to new age, from business to engineering and technology, and even entrepreneurship. We want you to know that at UD, quality is paramount, whether it's referred to in relation to content, delivery, student involvement, or engagement. We are proud of our huge talent of trainers, coaches, and mentors who design and deliver cutting-edge and hands-on programs in the region. Our trainers come from a variety of backgrounds, including both practitioners and professors. We have converted successfully our entire range of programs to the virtual platform with very engaging and dynamic delivery. In addition to public courses, we are also known for the customized programs that we offer to large key clients in multiple locations successfully.
His Highness Sheikh Mohammed bin Rashid Al Maktoum said, "Training opens your eyes to weaknesses, boosts your self-confidence, and brings you one step closer to victory." Our team at the Center for Executive Development is eager to help you get your victory. If you need anything during the training, do not hesitate to ask one of our team members. We look forward to taking this learning journey with you and hope you enjoy the experience.
Since 1998, Dubai Chamber has been committed to sustainability by reducing energy consumption and improving its environmental performance. This has resulted in the Chamber saving more than 21 million dirham over 15 years, becoming the first existing LEED certified building in the Arab world in 2009 and LEED Platinum in 2013 and 2018. furthering its commitment and as part of Dubai's vision to produce 75% of its energy from clean sources by 2050. Dubai Chamber has now also made its education initiative. The University of Dubai, the first LEED certified net zero building in the region. Ground-mounted solar panels spreading over 2 kilometers have been installed on the campus. They connect to the existing grid and produce solar energy to fulfill 100% of the university's electrical needs annually. The panels surround the campus to maximize solar contact to a capacity of 1,700 kilowatt peak per day, helping the university reduce CO2 emissions by 2,040 tons and save 1.2 million dirham annually. In 5 years, costs invested will be recovered, and the university's energy bill will be zero for the next 30 years. The project was approved and implemented by Diwa Sham's Dubai Solar Program to support His Highness Sheikh Mohammed bin Rashid Al Maktoum's vision of having all buildings in Dubai to be zero energy by 2030. The Dubai Chamber is proud to be a pioneer in green building and contribute to Dubai's sustainable city vision.
The University of Dubai, UD, was founded in 1997 by the Dubai Chamber of Commerce and Industry. In June 2006, His Highness Sheikh Mohammed bin Rashid Al Maktoum, Vice President and Prime Minister of the UAE and ruler of Dubai, granted the university 3 million square feet of land in Academic City for construction of a green and sustainable campus. In addition to the UD campus buildings being LEED certified, the campus is also the first net zero energy building in the region, following the implementation of a solar power project at its campus. The university, which is licensed by the UAE Ministry of Education, has several professional certifications and 2 major international accreditations, AACSB and Abbott. It offers a variety of business, law, engineering, and IT programs. The university is committed to developing and educating leaders who can make a difference in the business world. The achievements of the University of Dubai's 3,000 alumni in various organizations and ranks of leadership are a reflection of this commitment. The university is also a hub for several research and business centers, including the Center of Business Research and Consultancy, CBRC, and the Entrepreneurship and Innovation Free Zone, EIFC. Likewise, the university's student services and alumni affairs units offer an abundance of engagement opportunities and extracurricular activities inside and outside the classroom that meet the students' diverse interests and enrich their learning experience. During and after the students' graduation period, the Internship and Career Development Center staff make sure to build a relationship between the students and employers and provide them with opportunities that help them pursue their dream jobs. In addition to its bachelor's, master's, and PhD degrees, the university offers professional training through its Center for Executive Development, also known as CED. The center designs and delivers customized executive management development programs, along with open enrollment workshops, internationally accredited professional certifications, and online learning opportunities, in addition to national emeritization initiatives.
University of Dubai, the first LEED certified net zero building in the region. Ground-mounted solar panels spreading over 2 kilometers have been installed on the campus. They connect to the existing grid and produce solar energy to fulfill 100% of the university's electrical needs annually. The panels surround the campus to maximize solar contact to a capacity of 1,700 kilowatt peak per day, helping the university reduce CO2 emissions by 2,040 tons and save 1.2 million dirham annually. In 5 years, costs invested will be recovered, and the university's energy bill will be zero for the next 30 years. The project was approved and implemented by Diwa Shams Dubai Solar Program to support His Highness Sheikh Mohammed bin Rashid Al Maktoum's vision of having all buildings in Dubai to be zero energy by 2030. The Dubai
Hello, everyone, and welcome back from the break. I am Dr. Maisam, an assistant professor at the University of Dubai, and we're going to start our session 4. The first article will be titled Conform Symbols Identification System Using Correlation Technique, and it has been authored by Dr. Alavi, Dr. Hussein Al-Ahmad, Shahid Al-Shaybani, and Mina Al-Saad.
Hi everyone, this is Shahid Al-Shahabi, a second-year electrical engineering student at the University of Dubai, and in this presentation, I'll be discussing the research paper on cuneiform symbols identification system using the correlation technique. Starting with the introduction, around 3000 BC, the Sumerians developed the ancient cuneiform writing system, and is considered as one of the oldest forms of writing used in the ancient Middle East, as it provides information about the ancient Sumerian history and the history of humanity as a whole. The development of cuneiform writing system was one of the most significant and valuable contributions in the history. From these beginnings, a variety of ancient civilizations valued the development of cuneiform and utilized it due to its usefulness. Cuneiform simply means wedge-shaped because people used to write it using a reed stylus cut to make a wedge-shaped mark on a clay tablet. Reading and identifying those symbols is an essential step to interpreting the meaning and the hidden treasures of cuneiform tablets, which will be achieved through this presentation. Moving on to the objective of this paper, which is aimed to develop an algorithm to read, identify, and recognize cuneiform characters. The proposed method is aimed to design a powerful methodology of recognizing cuneiform characters and extend it to develop an autonomous system to translate and decode cuneiform symbols, which can be utilized in historical museums. And continuing with the literature review, most of the existing approaches of cuneiform recognition are applied on single characters that are processed individually and recognized separately. Thus, these proposed methods and algorithms limit the number of characters that can be recognized using the same program. And as discussed in some research papers, the use of neural network can be implemented to recognize cuneiform characters. So let's start discussing the main topic of this research paper, which is the cuneiform symbols recognition algorithm. The proposed cuneiform symbols recognition technique is explained using the pseudocode on the left side and shown with a block diagram on the right side. The process starts with uploading the cuneiform image, followed by the pre-processing phase where the image is enhanced using some techniques such as binarization and noise removal, followed by the segmentation phase where the cuneiform image is divided into symbols using row and column segmentation, and then the relationship between the cuneiform symbols and the database is computed using the correlation coefficients. And finally, The recognized symbols are displayed. So starting with the first phase, which is binarizing the cuneiform image, where the image is converted into a two-level or black and white image, as shown in the figure on the right side. Moving on to the noise removal phase. In this phase, the binarized image is subjected to medium filtering to remove nonlinear noise, as shown in the figure. Medium filtering, which is a nonlinear digital filtering technique, is used to remove noise from the cuneiform image in order to enhance the performance of this image. This filter is very important in the field of image processing. It is a typical pre-processing step to improve the results for later processing. And the next phase is the segmentation. Segmentation is a necessary process to isolate the cuneiform symbols, which are then passed to the recognition stage to correctly recognize the symbols. The cuneiform image is segmented into a series of images that contain only one symbol. And in order to achieve this, the process is divided into two different stages: row segmentation, followed by column segmentation. So let's see how the row segmentation works. The segmented rows of the image are accomplished by first summing the image horizontally to compute the vertical profile of the image. Then the rows with texts are extracted, followed by finding the top and bottom lines of each row, which is used to extract the individual rows of text from the cuneiform image as shown in the first figure, which is followed by column segmentation. This process starts with creating morphological structuring elements of each row, followed by labeling 8 connected objects of the rows, where the pixels labeled 0 are the background, the pixels labeled 1 make up the first object or the first cuneiform symbol in our case, and pixels labeled 2 make up the second object, and so on. In this process, the bounding boxes of each character are also computed, which are sorted according to the x-coordinate to ensure that the order of the characters is conserved and that the output will yield the segmented cuneiform symbols without changing their orders. The result of this phase is the segmented cuneiform characters of each row, which is shown in the second figure. Next is the correlation phase. So first of all, what is correlation? Correlation is a statistical term that describes the extent to which two variables move in agreement with each other, or simply the relationship between two variables, or in our case, between two images. This phase compares the reference database characters with the segmented cuneiform character by finding the correlation coefficients between the two images. The process starts with reading the two images, applying some morphological operations, such as removing isolated pixels, and computing the correlation coefficients using the equations shown with the defined parameters. And moving on to the final phase, which is the character recognition phase. In this final stage, the computed correlation coefficients are compared to find the maximum index that points to the intended letter from the reference database, and thus translating each cuneiform character or symbol. The results are also displayed as shown in the figure below. So let's move forward with the results and discussions. The proposed algorithm is conducted on cuneiform characters extracted and segmented from Sumerian writings. The image of the Sumerian writing is enhanced through pre-processing techniques such as binarization and noise removal. Segmentation techniques are then applied to the enhanced image to extract the individual cuneiform characters. The correlation coefficients were computed by finding the segmented characters and comparing them with the reference database characters. These correlation coefficients were compared again to find the maximum index that points to a specific character from the database. The output of this program yields the segmented cuneiform characters of the Sumerian writing and the corresponding translation to the English alphabet. This translation is compared manually with the ground truth of these characters to evaluate the performance and the efficiency of the method as shown in the figure, which presents the accuracy percentage of 3 different Sumerian cuneiform samples, with a maximum accuracy of 100%. And to conclude everything, in this presentation, we have presented a cuneiform symbols identification system using correlation technique. A huge amount of cuneiform writings and tablets developed by the Sumerians have been discovered over the past years. They influence cultural development in their era and can transform human understanding of the history. The translation of these cuneiform tablets interprets the meaning of the Sumerian writings and thus allows the explorations of history to move forward with the development. The algorithm demonstrated efficient results when it was tested on Sumerian writings, as discussed earlier. And finally, the future work. As discussed, the proposed algorithm of recognizing cuneiform characters represents the first phase of the work. The cuneiform recognition result was computed using the correlation technique, which will be replaced with deep learning technique in phase 2. And in further phases of this work, Hammurabi code will be considered to decode and translate its character using its first law. So thank you for listening to my presentation. Please feel free to contact us if you need any further information. And thank you.
Thanks for the group for their impressive work. Now we'll move into article number 2 titled Comparison of Food Calorie Measurement Using Image Processing and Machine Learning Techniques. This work has been prepared by Bushra Al-Shuja, Fatima Al-Nuaimi, Professor Wafiq Mansour, and Dr. Shadi Atallah.
Hello everyone, this is Bushra Abdullah and I'll be presenting our research, which is a comparison of food calorie measurement using image processing and machine learning techniques. In this presentation, I'll give a brief introduction and then I'll move to the research problem and the methodology, and then I'll talk about the literature review and results before concluding the presentation. So, as you might have noticed that people nowadays are more aware of the risks and consequences of bad eating habits, which include diabetes, obesity, and many other health problems. Therefore, many people are trying to monitor their eating behavior and maintain a healthy lifestyle. One way to do that is to pay attention to how much they're eating by tracking their daily calorie intake. The amount of calories needed to maintain the weight differs from one person to the other depending on many factors such as age, weight, and activity level. The simplest way to estimate food calorie content is by multiplying food weight by the calorie per gram for the specific type of food. However, with modern lifestyle, this is not always possible because people need to travel more, they tend to eat out multiple times during the week, and unfortunately, not all restaurants offer calories estimation for their menu. That makes it difficult for people to track their calorie intake, and at the same time, it makes way for scientists to innovate in this area. Some of them have developed a calorie estimator that works by image processing. Others took it even further, where healthier food options are suggested just by uploading an image of the dish or the plate. So, to overcome this difficulty of monitoring food calorie content using the traditional ways, image processing approach has been considered an easy and always available approach. The challenge is to optimize the reliability of such approach, which basically depends on the accuracy of image processing techniques used to develop the application model. Another challenge is to choose the best training and testing food image datasets to enhance the performance. In our research, we have conducted a comparative study that investigates the machine learning algorithms and datasets used to develop food image processing models for the purpose of food calorie estimation. This effort was performed to identify the most reliable food processing method for accurate food calorie estimation. Our methodology is to understand the problem, define its scope, and then compare three main features from different food calorie estimation models, which are the machine learning algorithms, the data sets, and the calories calculation techniques. So we have already looked at the problem in the previous slides. The scope of this research is the image processing-based calorie estimation models developed within the last 5 years. In the next slides, I'll go through the results of the literature review and the comparisons. Again, the comparisons will be done on the machine learning algorithms, the data sets, and the approaches followed to calculate the calories amounts. Starting with the data sets, there were 13 different food images, data sets, and combinations of them that were used in training and testing the machine learning algorithms developed to estimate the calories content of food. Among these 13 datasets, we have found that the most outstanding food images datasets were the ICSPIS dataset, the second one is the Food 101 dataset, and the third one is the UEC Food 100, which was very popular in many of the proposed models. Now, looking at the features of each of these datasets, now the first one is the ECUSTFD, which contains 2,978 images of 19 different types of food. It actually has the top and side views of each food item. Each picture contains a reference object with the diameter of 25 millimeters, and here it's represented by a 1 yen coin. It has the images in two circular plates colors, and this dataset includes the volumes and masses of the food. The second dataset, which is Food 101, contains 101,000 images belonging to 101 food categories, which has no standards, and that makes this dataset complex, actually. The third dataset, which is the UEC Food 100, contains 100 kind of food. The images in this dataset includes a bounding box to indicate the food location in the photo. It has popular Japanese food images, which is rarely found in any other food images dataset. Moving to the machine learning algorithms used to develop the food image processing models, it was found that the most of the models used one of these 7 machine learning algorithms. Models that use convolutional neural network and support vector machine were found to be the most accurate ones. One of the studies have proposed 3 models using different machine learning algorithms, and it was found that the convolutional neural network had the highest accuracy, followed by the SVM and the random forest. Looking at the most accurate 2 models, which were the CNN and the SVM, starting with the CNN, one study have resulted in a training accuracy of 93.29% and testing accuracy of 78.7%. Another study has scored an accuracy of 97%, which is considered really high. On the other hand, for the SVM, one method used a multi-kernel SVM and it scored 96% of accuracy. The other one used a linear kernel SVM and scored 90.66% accuracy. And the third one proposed a sphere-shaped SVM method, which have achieved 95% accuracy. However, we have noticed that the second study that used linear kernel have pre-processed a selected set of images for the testing, which we think added some bias to the accuracy. And the third method, the one with the sphere-shaped SVM, used only 100 images for testing, which we think is not enough to correctly judge the 95% accuracy. The last part here is the third feature that has been compared, and it's the way the calories are estimated or calculated. It has been found that most of the researchers have followed one of these three methods, either the mathematical model or direct estimation or reference tables. For the mathematical model, the researchers will develop a mathematical model that uses the features extracted within the model to calculate the accurate amount of calories in the food. For example, after computing the food volume, the mathematical model will transform this volume into the calories content of food. The second type is the direct estimation, which depends on the recipes and ingredients of the food. So after recognizing the type of food, the model will refer to the database containing the recipes and ingredients and cooking process and directly estimates the calories content accordingly. The last approach is the reference tables, which depends on the area detection and not the volume. And here, after detecting the food area, it will estimate the portion size of the food and then refer to some reference tables where it links the portion size with the calories content by comparing this area and portion size. Looking at these approaches, we have found that the most accurate one is the one that depends on the volume and uses the mathematical model. But this will mostly need a reference object in the image, so it can accurately calculate the food volume. One study actually proposed a calorie estimation application that requires the user to put a reference object next to the plate, which can be a coin or a thumb, just to calculate the volume accurately. To conclude, we can say that the most reliable and suitable food images datasets to train the machine learning image processing algorithm is the ECUSTFD, the Food 101, and the Food 100. And the most reliable machine learning algorithms for food image processing are the CNN and the SVM. And lastly, the most preferable calories estimation technique is the mathematical model depending on the food volume. Here we are suggesting some future work to expand this study. First, by testing machine learning algorithms with different datasets and different calories calculation techniques. And the second, by testing different algorithms with different cuisines. And lastly, we think that using such applications can help in creating new food images databases or datasets by using the pictures uploaded by the users. Of course, this will require the user permission. This is the end of the presentation. Thank you for listening. And if you have any questions, please go ahead and ask.
Thanks for the group for presenting their work. We will move now into article number 3, which is about measuring employee productivity through comparisons using RFID within the workplace. This work has been prepared by Abdullah Al-Marri, Bakhit Benjar, Professor Wasq Mansour, Dr. Shad Kalla, and Dr. Sami Minouin.
Welcome, everyone. This is Bakhit Benjar. I'm with me and my colleague Abdullah Al-Marri. We are master students of data science in University of Dubai. Today, I'm going to talk about our paper, measuring employee productivity through co-presence using RFID within the workplace. At work, managers use manual methods to measure the productivity of their teams, and this is usually done by the line manager that can be subjective. Organizations need to introduce new ways to accurately measure the employees' productivity which will help measure organizational performance.
Why are we trying to tackle this? So the objective is to find methods to measure objective methods to measure performance. And in recent years, there are many experiments being done in terms of IoT devices to automate the measurement of productivity. It's essential for us to for organizations to measure employee productivity to understand the progress and growth of the business. They require to baseline that information to assess the effects of decisions made by the organization and factors being internal or external that affect the business or the organizational performance. There are numerous variables that affect the productivity of an employee, such as health, well-being, work-life balance, knowing employee burnout, having the right tools available, being trained on such tools, having clear processes, roles and responsibilities defined and communicated to the employees, having clarity in terms of what is expected by an employee. A healthy organization culture also affects the employee performance. But also there's a main factor, which is knowledge sharing and communication. So knowledge is a powerful tool which can consist of insights, information, and experiences, where we would like, we were looking into measuring the effects of co-presence and information sharing to the employee performance. So one of the factors that affect, that will be a factor in our study is the RFID tag that has information about the object or the person that is it is connected to. Here we have two types of RFID technologies just to have an understanding about. RFID can be passive, which is like the ID cards that are used to open a gate or a door, which require no power and have low radius of signal, and the active RFID, which we'll be focusing on, which has a battery source and can identify the location of an employee or a person or an object within a certain premises.
We'll go to the basic of any project and by answering the 5 Ws. So what are we asking here in our project? It's to use the RFID technology to identify employees' co-presence for a particular time to measure its effects on employee work performance. And why? To empower the organizations to accurately evaluate their employees' performance as a means to improve the organization's performance. Of course, this will be done by the HR department. And who participated in this experiment? The employees of a Dubai-based organization in their premises, which spans a 3-floor office building. During the working hours from 7:30 till 3:30, Monday to Thursday, and 4.5 hours on Friday, for a total of 14 days.
So just to give a reference to our work, in our research, we found one of the main sources of information, which is the journal titled Exploring the Relationship Between Face-to-Face Interaction and Team Performance Using Wearable Sensor Badges. So this helps us guide our way in terms of developing our paper. This is close to our topic in terms of the technology being an RFID tag, but with an addition of an IR sensor and measuring interactions between employees and the effects on the performance. So in this case, this was a Japanese-based call center, which had two different sites, Site A and Site B. And they measured the effects of interactions between the managers and team leaders and their employees with the number of calls closed per hour. So they baseline that information prior to manipulating the way the call center operates, and they found that lower performing employees had very little interaction with their managers. So as an effect of that analysis, they implied to one of the call centers that the manager should reach out to those underperforming employees to understand if they require any assistance, and that effect showed that managers reaching out to those employees had a positive effect in the number of calls being closed per hour. The difference between this journal and our work is that their focus was with a call center where the floor is open between all employees. Ours has different floors and different mechanism of work, where we have different departments working together on projects, being corporate services and the core business and their daily operation. Additionally, the technology we have used is active RFID, and theirs was active RFID with IR sensors.
Talk about the methodology we use in our paper. It's a quantitative research using systematic investigation of measuring employee productivity by gathering quantifiable data and perform mathematical and computational techniques. Also by collecting information from existing employees using sampling methods. The experimental data has been collected from RFID tags of employee IDs. The method we use was the data science method of identifying the problem statement and then collecting the data, exploring and cleansing the data. After that, we analyze the data and build the model and deploy it. At the end, we review. The system architecture, we have the active RFID tags embedded in employee's ID card for a total of 220 tags. The wireless controller receives the data related to the movement of each RFID tag that connects to 10 different access points span through the 3 floors. Data collected through Cisco wireless controllers sent to Cisco cloud services, and from there, data will be pushed through the APIs to the local database, where HR will take care of the
with the analysis analysis of the data. So the architecture, as we can see, as just explained, comprises of RFIDs being with the employee around the work premises, where they are linked to the Wi-Fi controllers, Wi-Fi access points, to the controller, to the Cisco cloud, to the Google API, which pushes the data to the database, which admins or HR can see the end result.
Their role will be by continue.
The collected data and analysis. So we've collected an average of 6.8 million records per day for a total of 14 days. After cleansing the data and focusing only on the main office, that was reduced to 138,000 records per day. The data analysis we are focusing on is looking at the total time spent in office by the employee, a breakdown of the time spent in each zone, and for example, identifying areas where time is spent incorrectly, like an HR policy can be a limitation on time spent in breaks or being in pantries. Another part would be measuring time of co-presence between employees within a zone to indicate collaboration. And we have used 2 different methods. For employees working in the same floor, we are measuring a limit of 5 minutes, a minimum of 5 minutes to indicate collaboration between employees as they are located in the same floor. As for employees that move between floors, they usually have an intention of meeting others, and with that, a duration of 30 minutes is expected. And that's our measuring methodology. The raw data compromises of multiple attributes. We can see that we start with the record ID, user identification, wireless device identification, and the time of the activity. Zone ID is the zone based on the floor plan, connecting that to the Wi-Fi access point. Zone type ID is the building identification. Created on and processed are the time of processing the data on our premises, and a binary indication of being processed or not. A sample of the results would be for such an employee within a specific zone. They have multiple activities. I have identified in this case 2 separate 30-minute sessions within the same zone. And then we collectively find the time spent in each zone for a specific employee, and that can help identify the user activity between office premises and where the most of the productivity happens. And at the end, we have the collective view of one employee highlighted in green in this case, and the co-presence with other employees, as we can see, having different colors. So wherever this employee in a specific zone has been with other employees, we can see the overlap being true or false.
We come to the results. We have the average and the overall time of work for each employee as a result of this project. Then we get the percentage of time spent by each employee in each zone and floor. They also calculate the co-presence of employees within a zone. We have a few challenges and limitations. I'm going to talk about it.
So our challenges were, our device limitations were the capacity and the ability to process a huge number of data. And we saw some limitations while using Excel and Power BI due to the high number of records. So we opted to use Python as a solution with NumPy and Pandas as libraries, where we found substantial performance enhancements and efficiency in terms of processing time and the ability to find the final results. For future work, we're looking into linking the employee to a project and the relevant stakeholders and the departments that they are linked to. This will help us identify the time spent for a specific employee, for a specific project, and the relevant stakeholders of that project, and identify the effects of the co-presence or the location of both employees and the ability to efficiently complete a project. Additionally, we are looking into improving the technology we have used from just active RFID badges to badges that can identify face-to-face proximity to accurately identify employee interactions. We would like to thank you for listening to our presentation, and we hope that you have benefited from the presentation.
Thank you.
Thanks to the group for their work. Proceeding with article number 4, which is titled Deep Neural Networks for Transmission Impairment Mitigation in Long Reach 5G Access Network. This work has been prepared by Tomaz Maniak, Dr. Rahat Iqbal, Zoran Bergisis, Charalampos Koriotis, and Nikos Pastas, Fayaz Doctor.
Hello, my name is Charalambos Kariotis, and I'm going to present to you our paper, Deep Neural Networks for Transmission Impairment Mitigation in long-reach 5G access networks. In this paper, we consider the application of continual learning in deep neural networks for transmission impairments in long-haul transmission systems. Our work investigates the novel use of continual learning in order to overcome catastrophic forgetting and remembrance in deep neural networks that can potentially be used for dispersion and nonlinearity mitigation in long-haul transmission systems. In our paper, we perform comparisons between state-of-the-art methods such as ICAL, DGR, EWC, XTG, and traditional deep neural network implementation typically used in optical networks. Our results demonstrate improvements in training accuracy towards signal recovery and decreased flexibility for deep neural network equalization applications. Nowadays, the mitigation of transmission impairments in optical communication systems requires implementation of digital signal processing that can be easily adapted to changing conditions and work on continuous streams of data. Therefore, the main objective of this work is to validate and compare the available methods of continual learning and provide a proof of concept for a novel approach in the context of long-reach access networks. Machine learning techniques are applied as an efficient tool to mitigate nonlinear effects in optical fibers. These techniques can easily outperform some more simple, inaccurate analytical models that simply cannot model the effects of cell-phase modulation, cross-phase modulation, chromatic dispersion, and other similar effects that cause prohibitive levels of signal distortion at the receiver and considerably degrade its sensitivity. Supervised machine learning models can be designed in such a way to directly capture and model these effects. This is done by using historical data and learning the input-output relations between the monitor parameters and the desired outputs. Deep neural networks are used as the base for developing intelligent solutions in a wide spectrum of application areas. Several recent studies have showcased the potential of deep learning to deal with the nonlinearities occurring in fiber optic systems. The deep neural networks create a static model that requires retraining every time new information needs to be added. This implies that deep neural networks can be very efficient on a specific problem that is fixed in a specific time. Therefore, DNN lack the ability of adapting to new tasks without losing prior knowledge. To address this challenge, it is a common practice to keep previous data samples and add new data each time there is a need. However, this practice quickly becomes intractable, especially for long data streams, and leads to problems such as lack of data storage, long processing times, and computational limitations. Deep neural networks can achieve high impairment distortion cancellation when trained on fixed fiber lengths. Learning how to perform well on multiple tasks for dynamically changing base conditions, for example, for varying fiber lengths, still remains a challenging issue. Continual learning is a new approach to the problem of learning from an infinite stream of data that can gradually extend acquired knowledge with no need to retain the data samples used previously in the training process. Its main objective is to address catastrophic forgetting, basically the performance degradation on previous tasks, and catastrophic remembering, the worsening ability to discriminate between data from different tasks. The experimental setup that we used consisted of a common deep neural network scenario where the network has been trained on a total number of 20 tasks. Each task corresponds to a different fiber length from 0 to 200 kilometers, considering standard single-mode fiber and an externally generated signal using a fully random binary sequence. Our networks have 4 fully connected layers. The output layer is a softmax. The activation function is ReLU, with the exception of the output, which uses a sigmoid function. We use Adam's stochastic gradient descent algorithm and mean square error as the loss function. The learning rate was set to 0.001, and all the models have been trained for 500 epochs. The same architecture has been used for comparison purposes for all the continual learning methods. Our dataset consists of randomly generated symbols with input-output pairs, and as per any machine learning problem, the dataset has been divided into testing, training, and validation with the following ratio of 70, 20, and 10% respectively. As part of our experiments, we compared ICARL, TGR, EWC, and XTG continual learning methods. Initially, the deep neural networks were trained on a dataset of fixed 100-kilometer length. As we can see from the results in the table, we can see that the accuracy decreases when the fiber length increases. This is logical since the total accumulation dispersion increases as well. The equalizer accuracy, which is almost 100%, for all the fiber lengths that are lower than the one used for training. This could imply that the deep neural network can be trained on the longest possible fiber length to provide the best coverage for all the different fiber lengths. Therefore, our next experiment consisted of the 200-kilometer length case, where we trained the network on the highest considered fiber length, meaning the 200 kilometers. However, the results clearly show that training a network on a fixed fiber length is not enough to create a viable equalizer for all different fiber lengths. For our next experiment, we trained the deep neural network in incremental steps. The networks were trained with a dataset considering a back-to-back scenario, meaning the parameters were saved and used to initialize the weights of another network that was trained on the data for 10-kilometer fiber transmission, and the process was repeated up to the 200-kilometer length. The results show that this incremental approach suffers from catastrophic forgetting. For our next experiment, we trained the DNN on the dataset of all fiber lengths, and this was basically done to create a baseline for investigation on the performance of the continual learning methods. The results show a considerable improvement over the incremental approach. We can see that for most lengths, we're talking about 100%. However, we must mention that this training cannot be efficiently performed in a real-life context. Our main focus was to compare continual learning approaches, and for our experiments, we compared different approaches to identify the most suitable approach for our paper. Our results show a spread concerning the accuracy ranging from 91 to 99.9%. All methods, we can observe that they have achieved higher accuracy compared to the incremental approach with no continual learning. The most successful method was the XTG concerning accuracy. However, we must keep in mind that this method requires a specific task information identifier to add in the input. This is not preferable since it affects the flexibility of applying deep neural networks. The next best result is achieved by using the DGR, which does not require an identifier, therefore it's our preferable choice. The accuracy results for the DGR are lower than the results compared to the DNN that are trained on the entire dataset for all fiber lengths. This is understandable since when the networks are trained on the entire dataset, they cannot suffer from catastrophic forgetting. However, continual learning enables learning from continuous streams of data, potentially increasing the performance accuracy on a set of given tasks. It allows flexibility and adaptation to new tasks without a loss of prior knowledge. To quantify these benefits, we use the models trained on all task arrows-based model and compare it with the performance of the DGR. The DGR has been trained using a continuous stream of data as opposed to a fixed dataset. The mean accuracy achieved for signal equalization improved from 98 to 100%. Given our results, we can say that our paper demonstrated the potential of continuous learning to improve transmission impairment mitigation compared to standard deep learning approaches. We tested several continuous learning techniques, exploring the benefits and characteristics, and identified the optimal CL configuration. The proposed approach was able to overcome the problem of catastrophic forgetting and remembrance. It removed the need of retraining the network for each fiber length and enabled training on a continuous stream of data with no loss of prior knowledge while maintaining a very high degree of accuracy. Our future work will include experiments with other deep neural network architecture and more specifically convolutional neural networks. We will also focus on identifying the most optimal setup for continuous learning in the context of signal equalization for long-reach, high-capacity optical access, considering a number of additional continual learning methods. Thank you very much.
Thank you so much for the interesting topic and results as well. So I'm Dr. Diana Dawood, an assistant prof at the University of Surrey, and I will be chairing the rest of this session, starting with the paper titled Neural in ILM, Learning Paradigms from Centralized to Decentralized Learning. This paper is authored by Hafsa, Christoph, Yassine, Wilfried, Abis, Professor Wathiq, and Dr. Shadi Atallah. So the floor is yours, Hafsa.
Hello and welcome in this talk. I'm Hafsa Bousbiat and I'm a final year PhD student at the University of Klagenfurt. The main topic of this presentation is going to be the learning paradigms in NELM, mainly the centralized and decentralized learning, or more commonly known as federated learning. In summary, the content of the presentation is going to be about presenting the basic concepts for each one of them, the advantages, the drawbacks, and highlighting the main challenges facing real implementation of these learning paradigms in smart grids. And finally, of course, suggesting some future directions. Before we dig deeper into the main concepts of these learning paradigms, I would like first to introduce the term of load disaggregation. So load disaggregation actually relies on identifying the power consumption of different appliances that are present inside the household using a single metering point that gathers only the aggregate power. And the idea of using a deep learning model is to use one neural network per appliance, where this neural network will get the aggregate power as input and give as output the power consumption of the target appliance. The basic idea of NERM, or more commonly known as load disaggregation, actually didn't appear in a single contribution. It rather developed through the years. The current slide presents the number of publications per year as retrieved from the Scopus database in the topic of NELM. The first contribution actually was made in the early 90s by a professor at the MIT, but still the idea didn't receive a lot of attention till the year of 2010, where climate change discussions emerged. For example, in the COP16, which is the UN Climate Change Conference. And starting from there, a lot of attention actually was given to the topic, but still, most of the contributions were about combinatorial optimization and probabilistic models for NELM. Till the year of 2015, where the first deep neural NELM was presented. And started from there, actually, we could see the last few years as the neural network era, where the majority of publications are all about deep neural networks. As the previous slide demonstrated, there is an increasing number of contributions that have been proposed in recent years. And to summarize all the literature, we suggest the taxonomy that is presented in the current slide. The taxonomy is composed actually of 3 levels, representing 3 different criteria that allow to differentiate between the models. The first level is the learning goal. So we have models that adopt a single task learning approach and models that adopt multitask learning approach. So the main idea here is to see if the model is focused on performing both power estimation, so the value estimation of the power consumption, and the state of the appliance, so if the appliance is on or off, or the model focused on performing either of them. The second level of the taxonomy actually details the single task models based on this concept, so the type of the task. If the task is a classification task, where the goal is to, as I said, estimate the state of the appliance. And here also we could distinguish between 2 subclasses, so models based on the event detection that operates only when there is a significant difference between 2 consecutive measurements, or models that perform state estimation, so they estimate at each time of the point, of the time, pardon. The second type of task is a regression task, where the goal, as previously said also, is to estimate the power values of the target appliance. And this actually brings us to the third level of the taxonomy, where we could distinguish between the models of this class based on the type of the output. So we have models that perform a direct mapping between a sequence of measurements from the aggregate power and a sequence of measurements from the target appliance, and models that perform mapping between a sequence of measurements from the aggregate power and only a single point from the corresponding window from the aggregate appliance. All classes of models that have been previously presented could be trained using 2 different approaches. The first one is a centralized learning approach, where it is assumed that the energy data of different consumers is gathered in a central server for training and processing. The second approach is a federated learning approach, where the data is assumed to remain locally at the consumer's level, and it's the neural network that travels to the consumer, performs the learning locally, and then travels back to a central server for aggregation of the knowledge to obtain a global model that could be used in further iterations. Considering the first learning paradigm, which is centralized neural network, a careful look at the literature would reveal that the majority of these models follow a single task model. And the results that have been obtained in the literature are very promising, but in the case of appliances with high power values. So little evidence can be found for appliances with lower power consumptions like the television and other appliances. As a follow-up to the previous slide, we have investigated the results reported considering the mean average error for several contributions in the past few years, considering 2 most popular energy datasets, the UK DAL and the RED dataset. As the slides show, the distribution of the results considering the dishwasher, the fridge, and the washing machine for the case of the UK DAL is more or less symmetric distribution, which actually shows the stability of the results obtained for these 3 appliances considering this dataset. Unfortunately, the results do not generalize in the case of the RED dataset for the 3 appliances, but only in the case of the dishwasher. But still, even in the case of the fridge and the washing machine, the results, or the median value of the results, is lower than 30 watts, which is actually very interesting. The two remaining appliances, which are the kettle and the microwave, have results that are more or less skewed towards lower values in the case of UK dull. So we have median values that are lower than 10 watts, which is actually very interesting. On the other hand, in the case of the red data sets, the results are more sparse, which is due to a few contributions considering these two appliances for the case of the red data sets. The second learning paradigm, called federated learning, is actually a new learning paradigm that was introduced in the case of low disaggregation. To face several challenges that have been present for quite a time. The main advantages of this learning paradigm in this case are in the number of three. The first one is that it enables the local processing of the data, and thus it allows to overcome the problem of privacy concerns from the consumer side, which is actually quite a big topic in the field. The second one is that it allows for collaborative learning, where the global model is trained for several communication rounds and thus aggregates the knowledge gained by locally training several smaller versions of the model. The third one is that it allows to overcome the data zero problem related to the ownership of energy data by different grid operators in the new smart grid setup. A careful look at the literature would reveal that only a handful set of federated disaggregation frameworks exist, and the reported results are actually relatively low compared to the centrally trained models. And this is understandable due to the novelty of the topic. Despite the tremendous progress that has been made in the field in the recent years, both learning paradigms still face several challenges. Considering the centralized learning, the first challenge is the reluctance of power grid operators to share their data due to competitiveness and also strict law regulations. The second challenge is the considerable communication bandwidth that is required to transfer all this highly sampled data from the consumer to the central server. The third challenge is actually the privacy leakage, where energy consumer would argue that this energy data reveal that their daily routines. And even when models that have been centrally trained are implemented or embedded devices so that they can operate locally, this approach actually prohibits knowledge sharing among consumers and thus prevents from enhancing the performance and establishing an online learning approach. The second learning approach, which is federated learning, is also faced by several challenges. And the first one is directly related to the low power, low performance that is reported. And the main cause behind it is the non-evenness of the energy data, which means that the energy data coming from different consumers is not generated from the same distribution because consumers have different routines, and thus this would directly reflect on their energy or their power consumption curve. The second challenge is the lack of labeled data set at the consumer's level. So most of the approaches that have been proposed to date are adopting a supervised learning approach, while we don't have submitted energy data at the consumer level, but only the aggregate power consumption. And the last challenge that is faced by federated learning is the security issue, since it is widely acknowledged that the standard federated learning framework is very sensitive to data injection attacks. Coming to the end of the talk, I would say that federated learning, despite all the challenges that it's still facing, is the future for smart grid. And all the challenges that are actually present could be faced by adopting different approaches. We suggest actually three main future directions that could be investigated. The first one is the adoption of clustering techniques to mitigate the effect of non-evenness of the data, or let's say the heterogeneity of energy consumption from different consumers. The second one is the adoption of more robust security mechanisms, such as blockchain and cryptography or homocryptography, which allows actually to protect the standard federated learning approach. And finally, to use a semi-supervised or self-supervised approaches in federated learning to overcome the problem of non-availability of labeled data at the consumer's level. This ends my presentation. I would like to thank you all for your attention, and I kindly invite you to read our paper and reach to me or one of the co-authors in the case if you have further questions.
Thank you, Hafsa, for sharing your results with us. Now we will shift to a paper titled Range Estimation of Radar Targets Using a Temporal Convolutional Network, authored by Wibbert.
Greetings, everyone. My name is David Chung, and today I'm excited to be presenting to you the findings from my research paper, Range Estimation of Radar Targets Using a Temporal Convolutional Network, which I wrote in association with my colleague Zachary Poole at the Johns Hopkins University and Dr. Weber Montluis, who is a PhD and the fellow at the IEEE. The topic that we are interested in investigating in this paper is radar systems. Now, radar systems have been around for multiple decades, and they have numerous commercial and military applications. Radars are comprised of multiple subsystems, and many of these have been getting more complex over the years. In particular, the analog to digital converter in radars have been getting much more complex and are now capable of sampling at radio frequency directly, which makes for an interesting data processing problem. Fast and high maneuvering targets stress these data and signal processors. And so our interest in this paper is optimizing the signal processor system. Now, artificial intelligence is a tool that we will be using to solve this problem. And artificial intelligence is very good at solving problems with high computational complexity. For example, in the medical field, and even doing things like traffic monitoring. Now, due to the high data rate of modern radars, AI is particularly helpful in solving radar signal processing problems. Trained AI networks can actually provide really fast signal processing response times as compared to traditional signal processing techniques. Now, where does deep learning come into all of this? Well, deep learning is the modern approach to sensing hidden features in a data set. What we're interested in doing is performing sequence-to-sequence classification on a radar signal and distinguishing between what is target and what is noise. And we're specifically interested in using the temporal convolutional network architecture in order to do this. But before we can get into any of the neural networks, we have to first talk about what kind of data that we will be training our neural network with and also testing our neural network with. And in order to do this, we have this radar data model. And so we are trying to essentially model what a real radar signal would look like. Now, the assumption here is that we are simulating a low velocity target. And we are also using linear frequency modulation in order to transmit our signal. So you can see in equation 1, that is the equation for the signal that we will be transmitting, where U of t is the envelope of the LFM waveform, t is our pulse width, and k is our linear modulation rate. So essentially describing how fast our frequency will be increasing. Now, that is the RF signal that we described in equation 1, but we are really interested in the baseband signal. And so there is a down conversion process that happens here. And so the baseband signal is really what we are going to receive. And if we look at equation 2, we can see that. Now, in addition to down converting the RF signal to baseband, we also have to add some noise and delay in this signal. And we do that in equation 3. You can see we add a small time delay and we also add some Gaussian noise. Now, the intensity of our signal is given by the radar range equation. And basically, we're giving the signal to noise ratio based on some parameters, many of which are inherent to the radar itself, such as the peak transmit power, the array gain for the antennas, and then obviously the signal wavelength, so the frequency that we're transmitting at. But also there are some things that like are a characteristic of our environment. So for example, the radar cross-section, that would be the target, and then the noise figure and the total system losses would also be characteristic of our environment. Now, the neural network architecture we're interested in using, as mentioned before, is the temporal convolutional network, also known as TCN. Now, TCN is unique because it utilizes these things called dilated causal convolutional layers to process past and present data, which gives temporal context to the neural network. And we can use this in order to perform sequence-to-sequence classification on a totally brand new radar signal that the neural network has never seen before, and it can reasonably make certain predictions about that radar signal, distinguishing between what is noise and what is a target. And if you look at the photo on the right, that is kind of what a dilated convolutional layer looks like. It starts with a larger input, but then it dilates itself essentially. Now, receptive field size is what we're really interested in when it comes to these convolutional layers. And we have this equation here that describes what we can change, what variables we can change in order to change the receptive field size. And the two hyperparameters we're interested in here is the F for the filter size and K, which is the number of convolutional layers that we have. Now, if we increase F and we increase K, we get a larger receptive field size, which leads to more temporal context. But it also occupies a larger memory footprint, which is not optimal. And so essentially our challenge here is, balancing these two and doing kind of a trade-off analysis. Now, there are other layers that we're also using aside from the convolutional layer, and this helps increase the performance of our system. So for example, we have normalization layers, which kind of normalize the weight of our parameters. We have a spatial dropout layer, which is really, really important because it zeroes out certain parameters to decrease our reliance on them, and it reduces overfitting, which we do not want in our neural network because we want it to be able to generalize for many, many radar signals, not just a small set. And then finally, we have a ReLU layer. This is used for our activation function. Now, this is a layer graph of what our final radar architecture actually look like. As you can see, we have 4 of these sub blocks, and this is actually a really important hyperparameter because depending on the number of sub blocks that you have, you can actually increase or decrease overfitting, and you can actually use more blocks to increase the information that we are gathering. But again, this is a thing that we have to trade off. We went with 4 because when we found that we use fewer, such as 2 or 3, we weren't able to detect targets properly. But if you use too many, again, your memory footprint gets much too large. So the training methodology here. So in order to train our neural network, we had to generate some artificial data. And the way we approached this at first was using a uniform approach. And so we generated signals within a range band of interest, which was 100 to 1,000 kilometers. And we generated 10 signals with various noise level at each range. And the ranges we used were determined by a step size, which is defined by the range resolution, which is given by the propagation speed of light, as well as our radar bandwidth. Now, this approach has the advantage of being very resistant to noise and having a very high volume, but it was far too slow and leads to overfitting. So it wasn't a very practical approach for us to take. Instead, we went with something that was much more straightforward, which is the random method. We generated, again, a high volume of signals, but much less than the one before. And we generated them with completely random ranges within our range band and associated them with random noise levels as well, so that our neural network could be resistant to noise. Now, this is resistant to overfitting, and it's also much faster to train. And we had very good results using this method. So if we actually take a look at our simulation results, we can see that we generated 100 validation sequences with 3 targets in each sequence, which gives us a total of 300 targets. And we have an accuracy rate of 99%. 297 out of the 300 targets were actually detected accurately. And if we see in this plot to the right, green, all the green is basically accurate detections. And so that's defined as anything that falls within the range resolution of the actual range of the target. An inaccurate is in yellow, and I think we have 2 inaccurate detections here. And these are ones that fall outside of the range resolution, but they're still within the radar range window. So the radar picks it up, but it detects it as the wrong range. Now, we're really interested in utilizing this neural network in order to detect high velocity targets as well. And when we did 1 out of 3 targets as a high velocity target, generating those 300 targets again, this led us to a 97.33% accuracy rate. So we missed a few more targets this time. We missed about 7 targets, and you can kind of see that with those red X's on the plots. But this is actually still quite good. Even though we trained our neural network with low velocity models, high velocity targets actually still get detected relatively well. So this leads to a decrease in accuracy, but we can see that our neural network actually still adapts pretty well. So what are some conclusions from the findings that we discovered in this paper? Well, we discovered that using deep learning, it is possible to detect targets and predict the ranges in real time without any pre-processing. Current radar systems in their signal processor subblock have to do pre-processing, which takes a great deal of time. And when we want to detect faster targets, we want a really instant response. And so we can accomplish this using our neural network, which makes predictions about targets rather than actually processing all the data, which is really advantageous for us. We discovered that we have a very high accuracy rate with low velocity targets of 99%, and we still have a quite high accuracy rate of 97.33%, even with 1 out of 3 targets being high velocity. So our recommendation from the findings of this paper is that we should explore the limits of this neural network by using a random number of targets. Since we use 3 targets in each sequence this time, maybe switch it up with 1, 2, 5, maybe even 10 targets in the same range window, and also varying other target parameters such as angle of arrival and SNR and other things like that. So I would like to thank you all very much for your time. I appreciate getting the opportunity to present at the International Conference for Signal Processing and Information Security. Thank you to all the event organizers, and especially thank you to my collaborators for helping me write this paper.
Thank you for sharing your work with us. Now we are going to conclude this session with the work on blind source separation, a performance review approach. This work was done by Luay Yassin Taha and Isam Abdurrahman.
Hi, everyone. My name is Luay Taha. I am going to present the paper Blind Source Separation, a Performance Review Approach. Authors, Luay Taha and Isam Abdurrahim. I am from Pennsylvania State University, and Dr. Isam Abdurrahim, he is from University of Windsor. So the outline of this paper, introduction, classification of BSS algorithms, aim of this paper, BSS linear model and BSS problem, BSS extraction metrics, and performance review of BSS algorithms, conclusion, and future work. So what's the blind source separation? It is the reconstruction of some unobserved sources like time series and images from a set of observed signals. And in BSS problem, only the mixtures of the sources are available. So as you see in the next slide now, the input signals, these are the unknown signals, are mixed by another unknown, which is the mixing matrix here or mixing system, and we have only the sensors here. So then we need, of course, the blind source separation algorithms here to estimate the unknown signals. So this is the complete picture of the blind source separation. The application of BSS algorithms is in the audio and speech signal separation, digital communication, bio, medical signal analysis, image restoration, denoising, feature extraction, machine learning, and others also. This is an example of a cocktail party effect in the speech, where two persons, they are talking together, and the pickup signal is a mixture between the two. So the conventional bandpass filter does not work here because they are sharing the same frequency band. So we need this type of algorithm, blind source separation algorithm, to separate the signals. Another example of blind source separation found in biomedical signal analysis, it is the EEG signal separation. So look at, this is X1 of T, this is X2 of T, and these two are picked out coming from a mixture between the two sources like S1 of T, S2 of T. So that's why, of course, the signals are being mixed, and S1 of T, S2 of T are low frequency, and they are sharing the same value. So we need some algorithms to separate the signals. So again, the conventional filters does not work here in this application. So to classify the blind source separation algorithms, we have deterministic approach, we have stochastic approach, and we have a mixture. In the deterministic approach, we have segmentation, block component analysis, sparse component analysis, and non-negative matrix factorization. In the higher order statistics, we have, sorry for this slow transfer. So in the stochastic approach, we have higher order statistics and second order statistics. In the higher order statistics, we have the fast ICA, we have JD, we have Informax. And in the second order statistics, of course, we have others. There are many here. In the second order statistics, we have MUs, we have SOBI, we have LP, we have PCA. And the deterministic approach, combination between them, we have the null space, we have also the null space ITM. So the aim of this paper is to explain the BSS problem and the extraction metrics. We have also we will do the review of 27 selected algorithms. And the impact of reviewing this algorithm is to select the most suitable BSS algorithm that improves the separation of the signals and the images, of course. Linear model. So for the BSS linear model, this is X of n, which is the mixture vector. It's A, which is the mixing matrix multiplied by the unknown sources plus some noise. Most of the time, we care about only the noiseless case, which is this one, X tilde of n, which is just A times S of n. So the BSS problem, the goal of the BSS problem is, if I have this, then I have to find out an estimated vector called Z of n, which is the H matrix, which is the inverse of A, multiplied by X, then this is the noiseless case here. So we have HA S of n. So the question arises whether HA is identity or not. So let us see the next slide now to give you more details. So HA is the G matrix, which is L by L matrix, square matrix. So if G is identity, it means we have a perfect extraction. However, the general case, G cannot be equal to 1 because of many problems coming from the algorithms itself and from the artifacts in the signals. So in general, we have non-perfect extraction. And because of that, all researchers, they propose the extraction metrics that can show, that examine how well or bad the algorithms are. So these are the extraction metrics available now by researchers, and we use all of them in this paper. So let's start now with the review of the papers and this. Sorry for the slow transition from the slides. So we have, for example, this paper 34. We have 5 algorithms, and we use only SDR here for extraction metric. As you see here that the ILRMA is the best here, and the others are coming next to it here. So in the second paper, we are also checking the speech signal using another algorithms. Of course, it shows that the canonical correlation CC base is the best. When apply the extraction metrics, these are SIR, and so on. So the slides shows this is the correlation. Okay, so this is the CC based BSS algorithm for the first signal, and for the second signal also, still the CC based is the best in the extraction. In the second paper, we have also 4 BSS algorithms, and we have again 4 extraction metrics. As you see, the NSITM shows the best here in this one. The others are coming next one. The other paper, we use 6 BSS algorithms, and we use only extraction metric MSE, the mean squares error. So as you see now, the ZEOTS is the best here because this is the mean square error. This is the recto, which is the original signal. This is the extracted one, and this is the error here. The error is negative because it's logarithmic of very small error gives me negative values here. So this is the best, and this is the worst case when you use the PCA here. Now let's go to another paper, which is that shows the performance review of EEG signal for algorithms using PI and SPI. As you see that SLTP, it is the best here, and the other coming is the fast ICA and the JD. Doesn't mean here that fast ICA and JD is bad. No, it's a little bit less than this algorithm. So there is some improvement here in this algorithm as compared with the others. Now let's go to another paper that examine the ECG signal separation, 5 algorithms, and using the correlation here. As you see here that this algorithm, the algorithm GFLA. So the GFLANN, which is the artificial neural network, is the best here in this one. The other paper shows the EEG signal extraction using 5 algorithms, and the extracted data are evaluated according to the SDR and SNR. So here in this one, for the SDR, it shows BMICA is the best. 60% only of the time is the best. Whereas if I use the SNR, extraction metric, the fast ICA shows better than the other. So I think that's okay. It seems that they are overlapping. So we can say that both fast ICA and BMICA are good in this case. So that's why we decided to put evaluation scores for our research for all these papers. So we put high score to indicate the best extraction performance, and low score indicate the worst case extraction. So this is our results. So these are the best algorithms being used for all these papers here. And these are the applications: speech, ECG, and image, EEG signals here. So the conclusion says that conclusion is for the speech signal separation, these are the best algorithms. For the image, this is the best algorithm. For the ECG signal separation, we have NSITM and GFLANN algorithm. And for EEG, we have 3 algorithms being used in this one. So the future work is to extend the review of the BSS algorithms to include more algorithms. And also more applications can be added, like, for example, in the digital communication, denoising, feature extraction, and machine learning. Thank you so much. And if you have any questions, please, you can ask me. Thank you.
Since 1998, Dubai Chamber has been committed to sustainability by reducing energy consumption and improving its environmental performance. This has resulted in the Chamber saving more than 21 million dirham over 15 years, becoming the first existing LEED certified building in the Arab world in 2009 and LEED Platinum in 2013 and 2018. Furthering its commitment and as part of Dubai's vision to produce 75%
The University of Dubai, UD, was founded in 1997 by the Dubai Chamber of Commerce and Industry. In June 2006, His Highness Sheikh Mohammed bin Rashid Al Maktoum, Vice President and Prime Minister of the UAE and ruler of Dubai, granted the university 3 million square feet of land in Academic City for construction of a green and sustainable campus. In addition to the UD campus buildings being LEED certified, the campus is also the first net zero energy building in the region, following the implementation of a solar power project at its campus. The university, which is licensed by the UAE Ministry of Education, has several professional certifications and 2 major international accreditations, AACSB and Abbott. It offers a variety of business, law, engineering, and IT programs. The university is committed to developing and educating leaders who can make a difference in the business world. The achievements of the University of Dubai's 3,000 alumni in various organizations and ranks of leadership are a reflection of this commitment. The university is also a hub for several research and business centers, including the Center of Business Research and Consultancy, CBRC, and the Entrepreneurship and Innovation Free Zone, EIFC. Likewise, the university's student services and alumni affairs units offer an abundance of engagement opportunities and extracurricular activities inside and outside the classroom that meet the students' diverse interests and enrich their learning experience. During and after the students' graduation period, the Internship and Career Development Center staff make sure to build a relationship between the students and employers and provide them with opportunities that help them pursue their dream jobs. In addition to its bachelor's, master's, and PhD degrees, the university offers professional training through its Center for Executive Development, also known as CED. The center designs and delivers customized executive management development programs, along with open enrollment workshops, internationally accredited professional certifications, and online learning opportunities, in addition to national emeritisation initiatives.
University of Dubai, the first LEED certified net zero building in the region. Ground-mounted solar panels spreading over 2 kilometers have been installed on the campus. They connect to the existing grid and produce solar energy to fulfill 100% of the university's electrical needs annually. The panels surround the campus to maximize solar contact to a capacity of 1,700 kilowatt peak per day, helping the university reduce CO2 emissions by 2,040 tons and save 1.2 million dirham annually. In 5 years, costs invested will be recovered, and the university's energy bill will be zero for the next 30 years. The project was approved and implemented by Diwa Sham's Dubai Solar Program to support His Highness Sheikh Mohammed bin Rashid Al Maktoum's vision of having all buildings in Dubai to be zero energy by 2030. The Dubai Chamber is proud to be a pioneer in green building and contribute to Dubai's sustainable city vision.
It has been 3 years since my grandmother Teta Laila passed away. She was a loving, beautiful old lady. Alhamdulillah, she lived a full life, almost 90 years. I still remember her voice when I visited her in her beautiful house in the mountains. She used to greet me and say, "Taya binti, Taya busik." Teta Leila raised 10 kids, including my father. They all went to school and graduated from universities. This is why she used to always tell me, "You must study hard, ya binti. Always study hard to graduate from the top universities." Oh, Teta, don't worry. I promise you to study hard to graduate from the top university.
Every organization in the world gives priority to lifelong learning. And this is the reason why University of Dubai, through Center for Executive Development, offers professional training and professional certificates in order to develop the capabilities of human capital in UAE. So I urge everybody to be a part of this lifelong learning process in order to be ready for the jobs of the future.
Welcome to the University of Dubai and the Center for Executive Development Training Program. The University of Dubai was founded in 1997 by Dubai Chamber of Commerce to provide quality education and to develop human resources in the private and public sectors. The university's campus is a smart and green campus where business, IT, engineering, and law studies are provided in addition to various professional education programs. Most of the university programs are accredited internationally, like ICSPIS for business and Abbott for IT. The university provides bachelor's, master's, and PhD in business administration. Further, the College of Engineering and IT offers bachelor's and master's. Lastly, the university also provides masters of law in financial crimes and arbitration.
A big welcome to all of you. I'm Dr. Vidya, the Director at the Center for Executive Development at University of Dubai. We believe that your learning journey is a never-ending one. When you finish your degree, you enter the University of Life, which requires continuous learning to keep you relevant in the job market. Since our inception over 15 years ago, the center has trained over 10,000 professionals in diverse fields, from traditional to new age, from business to engineering and technology, and even entrepreneurship. We want you to know that at UD, quality is paramount, whether it's referred to in relation to content, delivery, student involvement, or engagement. We are proud of our huge talent of trainers, coaches, and mentors who design and deliver cutting-edge and hands-on programs in the region. Our trainers come from a variety of backgrounds, including both practitioners and professors. We have converted successfully our entire range of programs to the virtual platform with very engaging and dynamic delivery. In addition to public courses, we are also known for the customized programs that we offer to large key clients in multiple locations successfully.
His Highness Sheikh Mohammed bin Rashid Al Maktoum said, "Training opens your eyes to weaknesses, boosts your self-confidence, and brings you one step closer to victory." Our team at the Center for Executive Development is eager to help you get your victory. If you need anything during the training, do not hesitate to ask one of our team members. We look forward to taking this learning journey with you and hope you enjoy the experience.
Since 1998, Dubai Chamber has been committed to sustainability by reducing energy consumption and improving its environmental performance. This has resulted in the Chamber saving more than 21 million dirham over 15 years, becoming the first existing LEED certified building in the Arab world in 2009 and LEED Platinum in 2013 and 2018. Furthering its commitment, and as part of Dubai's vision to produce 75% of its energy from clean sources by 2050, Dubai Chamber has now also made its education initiative. The University of Dubai, the first LEED certified net zero building in the region. Ground-mounted solar panels spreading over 2 kilometers have been installed on the campus. They connect to the existing grid and produce solar energy to fulfill 100% of the university's electrical needs annually. The panels surround the campus to maximize solar contact to a capacity of 1,700 kilowatt peak per day, helping the university reduce CO2 emissions by 2,040 tons and save 1.2 million dirham annually. In 5 years, costs invested will be recovered, and the university's energy bill will be zero for the next 30 years. The project was approved and implemented by Dewa Sham's Dubai Solar Program to support His Highness Sheikh Mohammed bin Rashid Al Maktoum's vision of having all buildings in Dubai to be zero energy by 2030. The Dubai Chamber is proud to be a pioneer in green building and contribute to Dubai's sustainable city vision.
The University of Dubai, UD, was founded in 1997 by the Dubai Chamber of Commerce and Industry. In June 2006, His Highness Sheikh Mohammed bin Rashid Al Maktoum, Vice President and Prime Minister of the UAE and ruler of Dubai, granted the university 3 million square feet of land in Academic City for construction of a green and sustainable campus. In addition to the UD campus buildings being LEED certified, the campus is also the first net zero energy building in the region, following the implementation of a solar power project at its campus. The university, which is licensed by the UAE Ministry of Education, has several professional certifications and 2 major international accreditations, AACSB and Abbott. It offers a variety of business, law, engineering, and IT programs. The university is committed to developing and educating leaders who can make a difference in the business world. The achievements of the University of Dubai's 3,000 alumni in various organizations and ranks of leadership are a reflection of this commitment. The university is also a hub for several research and business centers, including the Center of Business Research and Consultancy, CBRC, and the Entrepreneurship and Innovation Free Zone, EIFC. Likewise, the university's student services and alumni affairs units offer an abundance of engagement opportunities and extracurricular activities inside and outside the classroom that meet the students' diverse interests and enrich their learning experience. During and after the students' graduation period, the Internship and Career Development Center staff make sure to build a relationship between the students and employers and provide them with opportunities that help them pursue their dream jobs. In addition to its bachelor's, master's, and PhD degrees, the university offers professional training through its Center for Executive Development, also known as CED. The center designs and delivers customized executive management development programs along with open enrollment workshops, internationally accredited professional certifications, and online learning opportunities, in addition to national emeritization initiatives.
University of Dubai, the first LEED certified net zero building in the region. Ground-mounted solar panels spreading over 2 kilometers have been installed on the campus. They connect to the existing grid and produce solar energy to fulfill 100% of the university's electrical needs annually. The panels surround the campus to maximize solar contact to a capacity of 1,700 kilowatt peak per day, helping the university reduce CO2 emissions by 2,040 tons and save 1.2 million dirham annually. In 5 years, costs invested will be recovered, and the university's energy bill will be zero for the next 30 years. The project was approved and implemented by Diwa Sham's Dubai Solar Program to support His Highness Sheikh Mohammed bin Rashid Al Maktoum's vision of having all buildings in Dubai to be zero energy by 2030. The Dubai Chamber is proud to be a pioneer in green building and contribute to Dubai's sustainable city vision.
It has been 3 years since my grandmother Tita Layla passed away. She was a loving, beautiful old lady. Alhamdulillah, she lived a full life, almost 90 years. I still remember her voice when I visited her in her beautiful house in the mountains. She used to greet me and say, "Taya binti, Taya busik." Tita Layla raised 10 kids, including my father. They all went to school and graduated from universities. This is why she used to always tell me, "You must study hard, ya binti. Always study hard to graduate from the top universities." Oh, Teta, don't worry. I promise you to study hard to graduate from the top university.
Every organization in the world gives priority to lifelong learning. And this is the reason why University of Dubai, through Center for Executive Development, offers professional training and professional certificates in order to develop the capabilities of human capital in UAE. So I urge everybody to be a part of this lifelong learning process in order to be ready for the jobs of the future.
Welcome to the University of Dubai and the Center for Executive Development Training Program. The University of Dubai was founded in 1997 by Dubai Chamber of Commerce to provide quality education and to develop human resources in the private and public sectors. The university's campus is a smart and green campus where business, IT, engineering, and law studies are provided in addition to various professional education programs. Most of the university programs are accredited internationally, like AACSB for business and Abbott for IT. The university provides bachelor's, master's, and PhD in business administration. Further, the College of Engineering and IT offers bachelor's and master's. Lastly, the university also provides masters of law in financial crimes and arbitration.
A big welcome to all of you. I'm Dr. Vidya, the Director at the Center for Executive Development at University of Dubai. We believe that your learning journey is a never-ending one. When you finish your degree, you enter the University of Life, which requires continuous learning to keep you relevant in the job market. Since our inception over 15 years ago, the center has trained over 10,000 professionals in diverse fields, from traditional to new age, from business to engineering and technology, and even entrepreneurship. We want you to know that at UD, quality is paramount, whether it's referred to in relation to content, delivery, student involvement, or engagement. We are proud of our huge talent of trainers, coaches, and mentors who design and deliver cutting-edge and hands-on programs in the region. Our trainers come from a variety of backgrounds, including both practitioners and professors. We have converted successfully our entire range of programs to the virtual platform with very engaging and dynamic delivery. In addition to public courses, we are also known for the customized programs that we offer to large key clients in multiple locations successfully.
His Highness Sheikh Mohammed bin Rashid Al Maktoum said, "Training opens your eyes to weaknesses, boosts your self-confidence, and brings you one step closer to victory." Our team at the Center for Executive Development is eager to help you get your victory. If you need anything during the training, do not hesitate to ask one of our team members. We look forward to taking this learning journey with you and hope you enjoy the experience.
Since 1998, Dubai Chamber has been committed to sustainability by reducing energy consumption and improving its environmental performance. This has resulted in the Chamber saving more than 21 million dirham over 15 years, becoming the first existing LEED certified building in the Arab world in 2009 and LEED Platinum in 2013 and 2018. Furthering its commitment, and as part of Dubai's vision to produce 75% of its energy from clean sources by 2050, Dubai Chamber has now also made its education initiative, the University of Dubai, the first LEED certified net zero building in the region. Ground-mounted solar panels spreading over 2 kilometers have been installed on the campus. They connect to the existing grid and produce solar energy to fulfill 100% of the university's electrical needs annually. The panels surround the campus to maximize solar contact to a capacity of 1,700 kilowatt peak per day, helping the university reduce CO2 emissions by 2,040 tons and save 1.2 million dirham annually. In 5 years, costs invested will be recovered, and the university's energy bill will be zero for the next 30 years. The project was approved and implemented by Diwa Shams Dubai Solar Program to support His Highness Sheikh Mohammed bin Rashid Al Maktoum's vision of having all buildings in Dubai to be zero energy by 2030. The Dubai Chamber is proud to be a pioneer in green building and contribute to Dubai's sustainable city vision.
The University of Dubai, UD, was founded in 1997 by the Dubai Chamber of Commerce and Industry. In June 2006, His Highness Sheikh Mohammed bin Rashid Al Maktoum, Vice President and Prime Minister of the UAE and ruler of Dubai, granted the university 3 million square feet of land in Academic City for construction of a green and sustainable campus. In addition to the UD campus buildings being LEED certified, the campus is also the first net zero energy building in the region, following the implementation of a solar power project at its campus. The university, which is licensed by the UAE Ministry of Education, has several professional certifications and 2 major international accreditations, AACSB and Abbott. It offers a variety of business, law, engineering, and IT programs. The university is committed to developing and educating leaders who can make a difference in the business world. The achievements of the University of Dubai's 3,000 alumni in various organizations and ranks of leadership are a reflection of this commitment. The university is also a hub for several research and business centers, including the Center of Business Research and Consultancy, CBRC, and the Entrepreneurship and Innovation Free Zone, EIFC. Likewise, the university's student services and alumni affairs units offer an abundance of engagement opportunities and extracurricular activities inside and outside the classroom that meet the students' diverse interests and enrich their learning experience. During and after the students' graduation period, the Internship and Career Development Center staff make sure to build a relationship between the students and employers and provide them with opportunities that help them pursue their dream jobs. In addition to its bachelor's, master's, and PhD degrees, the university offers professional training through its Center for Executive Development, also known as CED. The center designs and delivers customized executive management development programs, along with open enrollment workshops, internationally accredited professional certifications, and online learning opportunities, in addition to national Emiratization initiatives.
University of Dubai, the first LEED certified net zero building in the region. ground-mounted solar panels spreading over 2 kilometers have been installed on the campus. They connect to the existing grid and produce solar energy to fulfill 100% of the university's electrical needs annually. The panels surround the campus to maximize solar contact to a capacity of 1,700 kilowatt peak per day, helping the university reduce CO2 emissions by 2,040 tons and save 1.2 million dirham annually. In 5 years, costs invested will be recovered, and the university's energy bill will be zero for the next 30 years. The project was approved and implemented by Diwa Sham's Dubai Solar Program to support His Highness Sheikh Mohammed bin Rashid Al Maktoum's vision of having all buildings in Dubai to be zero energy by 2030. The Dubai Chamber is proud to be a pioneer in green building and contribute to Dubai's sustainable city vision.
It has been 3 years since my grandmother Teta Layla passed away. She was a loving, beautiful old lady. Alhamdulillah, she lived a full life, almost 90 years. I still remember her voice when I visited her in her beautiful house in the mountains. She used to greet me and say, "Taya binti, Taya busik." Teta Layla raised 10 kids, including my father. They all went to school and graduated from universities. This is why she used to always tell me, "You must study hard, ya binti. Always study hard to graduate from the top universities." Oh, Teta, don't worry. I promise you to study hard to graduate from the top university.
Every organization in the world gives priority to lifelong learning. And this is the reason why University of Dubai, through Center for Executive Development, offers professional training and professional certificates in order to develop the capabilities of human capital in UAE. So I urge everybody to be a part of this lifelong learning process in order to be ready for the jobs of the future.
Welcome to the University of Dubai and the Center for Executive Development Training Program. The University of Dubai was founded in 1997 by Dubai Chamber of Commerce to provide quality education and to develop human resources in the private and public sectors. The university's campus is a smart and green campus where business, IT, engineering, and law studies are provided in addition to various professional education programs. Most of the university programs are accredited internationally, like ICSPIS for business and Abbott for IT. The university provides bachelor's, master's, and PhD in business administration. Further, the College of Engineering and IT offers bachelor's and master's. Lastly, the university also provides Masters of Law in Financial Crimes and Arbitration.
A big welcome to all of you. I'm Dr. Vidya, the Director at the Center for Executive Development at University of Dubai. We believe that your learning journey is a never-ending one. When you finish your degree, you enter the University of Life, which requires continuous learning to keep you relevant in the job market. Since our inception over 15 years ago, the center has trained over 10,000 professionals in diverse fields from traditional to new age, from business to engineering and technology, and even entrepreneurship. We want you to know that at UD, quality is paramount, whether it's referred to in relation to content, delivery, student involvement, or engagement. We are proud of our huge talent of trainers, coaches, and mentors who design and deliver cutting-edge and hands-on programs in the region. Our trainers come from a variety of backgrounds, including both practitioners and professors. We have converted successfully our entire range of programs to the virtual platform with very engaging and dynamic delivery. In addition to public courses, we are also known for the customized programs that we offer to large key clients in multiple locations successfully.
His Highness Sheikh Mohammed bin Rashid Al Maktoum said, "Training opens your eyes to weaknesses, boosts your self-confidence, and brings you one step closer to victory." Our team at the Center for Executive Development is eager to help you get your victory. If you need anything during the training, do not hesitate to ask one of our team members. We look forward to taking this learning journey with you and hope you enjoy the experience.
Since 1998, Dubai Chamber has been committed to sustainability by reducing energy consumption and improving its environmental.
Hello everyone, welcome to the 5th session of the ICSPIS conference. I'll be chairing the session along with my colleague Dr. Yassin, and we will start with the first paper presented under Prediction of Electric Vehicle Charging Stations Distribution using Machine Learning by Dr. Marwa Irrai, Dr. Sabina Abdelhadi, Engineer Haytham Abu Damis, and Dr. Amjad Ghawanme.
Everyone, my name is Marwa Shantib Al-Rai. I am going to present our research work entitled Prediction of Electric Vehicle Charging Station Distribution using Machine Learning. It is a part of a graduation project performed at University of Dubai. In this presentation, I will introduce the problem statement of the implementation of electric vehicle charging stations, the motivation and intuition behind the study. Our contributions and how we created the data set are explained. Then I will talk about the obtained results. At the end of the presentation, I will conclude with some perspectives. Every day, more and more electric vehicles are hitting the road as consumers are buying electric vehicles at a rapidly growing rate. In United Arab Emirates, 30% of residents consider switching to electric vehicle, survey finds. Every single automobile company focused on producing electric vehicles. As the number of electric vehicles exponentially grows, there is an immediate need for more charging stations around the country. With this advent of all of these electric vehicles, the question begs itself, where does the next electric vehicle charging station go? What is the solution? We address this problem in this study. Our approach to tackling this problem is to create a machine learning model that can accurately predict the best locations to implement electric vehicle charging stations in Dubai. The machine learning approaches include k-nearest neighbors, neural network, support vector machine, logistic regression. Our contribution aims to determine ideal locations for electric vehicles charging spots consistent of building up a training, validation, testing dataset of random coordinates dispersed throughout Dubai and finding the features for each of these coordinates. The features which we consider are population density, points of interest, and security camera presence. Let's start by the first feature of population density. The population density is considered as a relevant factor because we believe that areas with high population density would tend to have a higher probability of electric car drivers as part of the local population due to the fact that it was defined an urban environment. The model utilized Dubai census data to calculate the number of people per square meter for each census block group, obtained by dividing Dubai into clusters using ArcGIS, where the geographic coordinates of the center of each cluster are easily determined. Using ArcGIS, the figure shows the clusters of Dubai where the green symbols show the centers of each polygon characterized by the geographic coordinates and the population density. The red flags corresponds to the actual charging stations. Points of interest determine how often people are visiting a particular location. The need for electric vehicle charging stations increase in areas that people drive too often, especially as electric vehicles grow in popularity. We rated the points of interest on a scale of 0 to 2, where 0 is non-optimal and 2 is optimal for placing electric vehicle charging spots, with 1 being somewhere in the middle. We rated emergency, medical, and industrial facilities as 0, government group quarters and education facilities as 1, and the transportation public. Places, retail, and office building as 2. Some of the charging station has lower power charging output, so it will take time until they charge their car. People want to feel safe while they are charging their cars. Most charging stations are equipped with security cameras. Those stations are more crowded by people because of safety regulations. The presence of a security camera was used as an indicator for how safe the area would be for people waiting around while charging their electric vehicles. This was a binary value of 1 if a camera existed there and 0 if not. Before we created the model itself, we decided on using a binary classification, where 0 represented a bad location and 1 represented a good location for a new charger. We chose a binary output over a score because we believed it would be easier for users to interpret a simple good-bad classification. After deciding on the output, we gathered our training data, which consisted of good locations where charging points already exist, and bad locations where were randomized points around Dubai that did not have existing charging stations. For each location, we added factors such as population density and closest points of interest, and any missing data type, we used the nearest available coordinate to assign a value. Then the security cameras and all the data are normalized. The data set is created by collecting 324 spots, where 162 points including charging station and 162 points are selected randomly as spots without charging stations. All the factors like points of interest, density, population, and security camera are determined for each location. This here is the link for the data set. As an example, let's take this points object 20 with Tesla the station charger in Dubai Mall with this geographic coordinate. This is a mall where the points of interest is encoded as 2, and because there is a camera, the camera is encoded as 1. The population density is around 1 1,886. For the model, we considered a few different classification models, such as logistic regression, k-nearest neighbors, neural nets, and support vector machines. Before we started to train our models, we split the data into 80% training, 10% for validation, and 10% for testing. The data is also normalized to make sure that each column was equally weighted to the models. Each type of model has been trained and then used for the validation set to tune the hyperparameters for each one. For SVM and logistic regression, we use the validation set to tune the regularization parameter C while also experimenting with different kinds of kernels for the SVM. We found that less regularization was helpful in both models and the radial basis function to be the most accurate kernel for SVM. We also experimented with different values for K and found that 3 nearest neighbors were the optimal K. Finally, for the neural networks, we tried different kinds of layers and neurons and found that 4 hidden layers with 150, 150, 25 neurons respectively worked the best on the validation set. In a classification of charging station problems, the metrics used to measure the model performances are F1 score and accuracy. F1 score is defined as a single score that balances both the concerns of precision and recall in one number. Precision quantifies the number of positive class predictions that actually belong to other positive class. Recall quantifies the number of positive class predictions made out of all possible examples in the dataset. The accuracy is a ratio of correctly predicted observation to the total observations. It looks at correctly classified observation, both positive and negative. Using the validation set, the neural networks and logistic regression with the tuned hyperparameters reached 76% and 79% accuracy respectively, while SVM model got 84% of accuracy on the validation set. We selected the k-nearest neighbors to be the final model, as it is the model that was achieving the highest validation accuracy, 89%. This model is used on the final test set. The final k-nearest neighbors model has a test set accuracy of 85.8% with an overall accuracy of 82.28%. In terms of results, we found that the model was largely accurate in determining where electric vehicle charging stations did and did not exist based on the 3 factors. For the overall dataset, 85% of existing electric vehicle charging stations and 93% of coordinates without charging stations were classified correctly. In the prediction set of 98 random points currently lacking any charge spots, the model recommended 16 of those points as ideal for future placement of such infrastructure. The recommended spots are shown here in red through symbol, which provide a visualization capability for the prediction by projecting them and integrate them into maps. Let's check this example where a cluster is a residential area having these geographic coordinates, a population density of 1,889. There is a recommendation to implement a charge station where no one is installed in this area based on our collected dataset as shown in this figure. Let's now recap what we've seen in this presentation. We decided that population density, points of interest, and safety using security camera were the best factors to use to determine best charging locations out of all factors that we determined would be relevant, based on the availability of the data and how relevant they were to Dubai. In addition, a classification model, yes or no to good charging spots, was determined to be the best for our project, as opposing to assigning each location a score or rank. We provide visualization capability for the predictions by projecting them and integrate them into maps. In future work, there is a need to update the data set to include the new charging stations. It will be interesting to incorporate more factors like public transportation, traffic flow, neighboring fuel stations, the tracking history car, and the daily energy consumption of each electric vehicles, then match the best location station according to the users. Other intended extensions are to look into other cities and have a real-time recommendations of interactive map given a user's custom coordinates. Here there are some references used in this work. Thank you so much for your attention.
Thanks to Dr. Marwa and the group. If you have any questions, kindly send them to the authors directly. Moving on next to the second paper to be presented, which is an efficient model for horizontal slicing in 5G network using practical simulations by Dr. Shadi Atallah, Hamza Khadar, Yassin Haimour, and Professor Wathiq Mansour.
Good afternoon, everyone. My name is Hamza Khadar. I am happy to participate in ICPS conference that takes place in Dubai University. I am an assistant professor at University of Media, Algeria, and my major research field is telecommunication and pattern recognition. Today, I will introduce our recent work entitled An Efficient Model for Horizontal Slicing in 5G Network using practical simulation. This work is co-authored by Professors Yassin Haimour, Shadi Atallah, and Wathiq Mansour. This is the outline of the presentation, and I will detail our work in the following 5 main aspects. First, introduction to 5G network. 5G radio network is an OFDM-based wireless network for mobile communication. It has 2 versions, non-standalone and standalone. Non-standalone 5G network is the early version of the mobile network, in which the radio network is supported by the existing 4G core network. Non-standalone 5G network primarily focus on enhanced mobile broadband, where the supported mobile will use millimeter waves frequencies for data communication, but will use existing 4G or LTE infrastructure for voice communication. Non-standalone 5G network will provide increased data bandwidth by using 2 radio frequency ranges. The first range is overlapped with the 4G frequencies and is called as a sub-6 GHz. These bands are numbered from 1 until 255. For the second range is a millimeter frequency band. These bands are numbered from 257 until 511. For the standalone 5G network, 3GPP finalized the standalone 5G network standards in 2018, which will have a new end-to-end architecture that will use millimeter waves and will not use existing LTE or 4G infrastructure. Standalone 5G will use enhanced mobile broadband, ultra-reliable and low-latency communication, and massive machine-type communication services to provide a multi-gigabit data rate with improved efficiency and low cost. The following table summarizes the 5G mobile network standalone network requirements. The International Telecommunication Union has classified 5G mobile network services into 3 categories: The first category will use enhanced mobile broadband, abbreviated as EMBB. The second category is ultra-reliable and low-latency communication, abbreviated with URLLC. And the third category is a massive machine-type communication, abbreviated with MMTC, to provide a high gigabit data rate with improved efficiency and low cost. The EMBB refers to the straightforward progress of today's mobile broadband services, allowing substantial data amount and a better user experience, such as supporting even higher end user data rate, ultra high definition videos, and virtual reality, augmented reality, etc. For the MMTC, this term refers to the services with a large number of devices, such as remote sensors, equipment monitoring, and controllers. Low device cost and low device energy consumptions are key needs for such services, allowing for at least several years of device battery life, because each device typically consumes low energy and produces a limited quantity of data. High data rate support is less critical. For the URLLC aims to meet expectations for the demanding digital industry and focuses on the low latency and extremely high reliability services, such as assisted and automated driving and factory monitoring. Second, background about 5G network. There are two concepts that must be studied to well understand the principle of 5G network. The first concept is a software-defined network. SDN was initially characterized as a method of planning, constructing, and administrating networks that divide the network control plane from forwarding planes. It allows the network's control plane to be directly programmable and abstract the infrastructure of application and network services, and doing so by using a logical software entity called the controller. Using SDN in 5G allows to deploy new services on demand, increasing their total efficiency. As a result, the architecture will be flexible, cost-effective, which makes it perfect for the high bandwidth and the dynamic nature of 5G use cases. The second concept is the network function virtualizations. NFV is the process of substituting network function on specialized devices like routers and firewalls, running as a software ready to use on hardware. NFV is a critical enabler of the next 5G infrastructure since it helps to virtualize all of the network equipment. Applications, devices, services, operators, and consumers may all benefit from the customizing virtual networks. In the left figure, we can see that many entities contribute to successfully establish network function virtualization, such as OSS, NFV orchestrator, NFV manager, and equipment manager. In the right figure, we can see that the SDN and FMV play a great role to establish 5G network slicing concept. Now I will explain in details the principle of the network slicing. Network slicing is an emerging technology that breaks down a common network infrastructure, such as a physical resource, to multiple virtual networks. The benefits are optimization of resource use, deployment flexibility and support for rapidity growing of the application and services, significant capacity and key characteristic of 5G according to 3GPP. Each 5G core network slice is made up of collection of network functions. Some of them may be utilized across multiple slices, while others are particular to a single slice. This is an essential consideration when slicing. The mapping between the 5G core network and the radio access network slicing can be a single slice per service or multiple slices per service. There are two types of slicing that can be used in 5G communication. The first type is the vertical slicing, aimed to promote a vertical market and industries. It is mostly focusing on 5G core network. It allows application and services to share resources and avoid or simplify classic quality of service challenges. In a vertical slice, an end-to-end traffic flows between a core network and terminals, and each of them performs similar tasks across the slices. The second category is horizontal slicing. It is a step forward in terms of increasing mobile devices capability and improving user experience. Horizontal slicing allows network nodes and devices to share radio resources. Highly competent network and devices, for example, share their resources like communication, processing, and storage with less network devices and nodes, resulting in an improved overall network throughput. Physical resources of the network hierarchy are sliced to form a horizontal slicing in the horizontal domain. A machine might work on multiple slices at the same time, like depicted in the figure. A smartphone, for example, can function in a vertical slice on a EMBB services, vertical slice on a healthcare service, and a horizontal slice supporting wearable devices, and so on. The context of our work is as follows. First, study and analyze of a vertical resource management model in a 5G network, which allow an efficient use of a full capacity of independent available resources, depending on traffic load variation and different network parameters. Second, satisfy the data rate requirements in isolation, which has different classes of services provided by one or more vertical network operators, and comply with the service priority constraint. The aim of the model and optimization problem is to find the balance between efficiency and fairness when allocating resources, taking into account customer satisfaction with different service level agreements. The optimization function is given by equation 1, and the constraints to be respected are expressed in equation 2, 3, and 4. There are consideration and assumption which must be taken into account in our simulation. So we will use 3 VNO, 3 vertical network operators. Each VNO represents an SLA, guarantee bit rate, best effort bit, with minimum guarantee, or best effort. Each VNO provides 3 services such as voice, video conference, and FTP. And we will use a simulation tool such as MATLAB plus Toolbox CVX Solver. In this experiment, we run our model through different simulation where we fix the total number of users to 300 users, and each VNO has the same number of users. And we vary the maximum capacity of the radio link in the network from minus 50% to plus 50%, with adding 25% each time to its original value. The aim is to study its influence on the overall data rate allocated to the individual users of the 3 VNOs. Regarding the influence of the quality of the VNO radio link, the result of the variation of the radio link on the weight of users are presented in figure 1, 2, and 3 for VNO1, VNO2, and VNO3 respectively. We can observe the following. The data rate allocated to each of the voice services for all 3 VNOs stayed somewhat consistent throughout all the different values of RCRMM radio link. As for the IoT services, the same can be said when it comes to VNO1 and VNO2, but in VNO3 it is noticed that by increasing the RCRMM, the data rate increases to reach its maximum value, which is plus 50% of the radio link. It is noticed that there is a significant variation in the data rate of the AMBB services depending on the value of the radio link. Especially in VNO3 also, the data rate is highly dependent on the service weight, as we can see decrease each time we pass to form a higher priority to a lower one. The increase of or decrease in the data rate assigned to each service follow a nonlinear function, which is justified by the use of the logarithmic function presented in the optimization model. Regarding the influence of the number of users, we simulated different scenarios on our model similar to the previous case. However, in this time, the radio link was fixed, and we varied the number of users by adding 20% of the maximum capacity of the network. We have studied the effect on the allocated data rate for each individual user in the different services offered in the 3 VNOs. The results of the variation of the users number on the weight of the users are described in figure 4, 5, and 6 for VN1, VN2, VN3 respectively. It is noticed that few change occurred compared to the previous experience. The maximum number of users can't go over the radio link capacity value in total, as the network is limited by the fixed value of the RCRMM. So the radio link need to be increased to increase the capacity of supported users. When it comes to the voice service, the data rate allocated to each of the three VNOs stayed consistent throughout. However, we noticed the minimal decrease in the data rate in the case of the case where the VNO3 was 100% occupied. For the first two VNOs, the data rate allocated to the IoT service stayed at its maximum value of 1 megabit per second, except when the VNO3 was at 100% of its user capacity, it decreased to 0.5 megabit per second. The data rate allocated to the EMBB in the three VNOs experienced a significant variation in values. Data rate falls as the VNO has a lower weight and the capacity of supported users gets closer to its maximum limits. Last, the conclusion. In this paper, an efficient model for horizontal slicing in 5G network using practical simulation has been introduced. We can conclude that SDN and FMV enable the ability of hardware virtualization and brought many advantage key functions to 5G network, such as network slicing orchestration. Increasing the value of RCMM, which is the radio link, maximizes the data rate allocated to the users in each VNOs. To satisfy all the users of the network, we need to set the RCMM to an optimal value dedicated by the use cases. It is noticed that using the horizontal slicing, all the VNOs are independently satisfied according to their SLA contract and whatever the radio link conditions. As challenges and perspectives, the major innovation from 5G network slicing is anticipated to be inherited to 6G. The cutting-edge 6G services present considerable difficulties for highly customized slicing with a lack of a real-time status monitoring of end-to-end slices and multidimensional resources orchestration of multiple operators. The resources provided to a slice must be changed in a timely manner to meet a dynamic use needs, since the 6G throughput is always changing. Thank you for being here.
Thanks to Dr. Hamza and the group. Moving on next to the third paper on learning analytics and machine learning that will be presented by Aisha Al-Mazimi, Ilham Karmastaji, Dr. Shadi Atallah, Dr. Hamza Al-Khazali, and Professor Wathiq Mansour.
Hello everyone, this is Aisha Al-Mazimi from University of Dubai. Today I'm going to talk about our research on learning analytics and machine learning. The authors of the research are Dr. Wathiq Mansour, Dr. Shadi Atallah, Dr. Hamza Ali, me, Aisha Al-Mazmi, and my colleague Ilham Karmastaji. The objectives of our presentation are introduction, research questions, research methodology, data set, expected results, and finally the conclusion. Learning analysis is the process of a data science that aims to build the learning process. It is the study and teaching subject at the intersection of three fields: analytics, learning, and human-centered design. People have been studying learning and teaching for a very long time. They were tracking student progress, analyzing school or university data, and also utilizing evidence to enhance teaching and learning. Learning analytics helps in different ways, such as predicting student academic achievement and also identifying individuals that are in danger of dropping out of a course or failing their studies. Our research contains 4 questions. The first question is, what is the role of the data science in learning analytics? The second question is, how will learning analytics aid in improving the academic achievement? The third question is, what is the role of learning analytics in the data science in predicting academic achievement? And the final question is, which stakeholders will have the best benefit from learning analytics and what will be their role in the process? The first question talks about the role of data science in learning analytics. Investigators could use multimodal learning analysis to acquire diverse sets of data from complicated active learning and adaptive learning settings weigh together more multiple entries of a small group of learners engaging with various sensors, including machine vision, statistics from academic material, which is applied computing components, and user-generated data. It looks at using several sensors, such as machine learning, user-generated information, and information from educational content, which is dedicated physical models, to capture high-fidelity synchronized multimedia recordings of small teams of students engaging. The second question talks about the improvement of academic achievement through learning analytics. Machine learning facilitates the use of vast amounts of data to build practical predictive learning algorithms. The efficiency of this method in forecasting post-induction high potentials shows the possibility of machine learning techniques for predictive modeling, with accuracy based on model design and suitable optimization. The third question talks about the role of learning analytics in predicting academic achievement, and it does it by relying on a more significant and more homogeneous course selection, and also addressing both intrinsic and extrinsic variables as factors influencing the learning experience. So to investigate, we use mixed linear regression. To what degree indication of students' digital learning behavior may describe the variety on final marks, and also how much of that variation is due to the curriculum and educators' internal circumstances, which are not captured by the recorded data, having investigated several forms of the behavior markers. Finally, the fourth question is talking about stakeholders benefiting from learning analytics and their role. So the present status of machine learning in crucial retail and advertising research, including ideas for future research and emphasizing potential applications for experts. The study examines the application of machine learning insights and indicators throughout the retailing sector. It evaluates the present status of machine learning in top-tier retail and advertising investigation, including proposals for future study and also highlighting possible implications for experts. For the research methodology, our research type is quantitative research methodology. Quantitative research is expressed in numbers and graphs. This type of research helps us to prove or confirm different theories and assumptions that we define or assume. With help of quantitative research, we can generate generalizable facts about any specific topic. In the research process, we have 8 steps. First, we start the research by, of course, choosing a topic, then doing a literature review, which is finding the references for the research, then formulating the problem of the research, and then developing the research questions, which are the main questions of the research. After that, we gather the data from different resources, then analyze the data, interpret the data, and finally communicate the findings. The main aim of the research is to establish the most preferred applications for machine learning. To establish the most preferred applications for machine learning, the dataset looked at is the frequency of how particular machine learning application has been adopted. Moreover, to support the research in this area, we have collected a dataset containing data from courses presented at the Open University. The uniqueness in this data is that it holds demographic data with aggregated clickstream data of students' interactions with virtual learning environments. This enables the analysis of student behavior represented by their actions. The dataset contains the information about 22 courses, 32,000 students, their assessment results, and logs of their interactions with the VLE, represented by daily summaries of student clicks, which are more than 10 million entries. In the data process, the data distinguish three different types of data: demographic, performance, and learning behavior. The selection process followed these rules. The first rule is the number of students in the selected model presentation is larger than 500. The second rule is at least two presentations of the model exist. The third rule is BLE data are available for the model presentation, since not all the models are studied in BLE. The fourth rule is the model has a significant number of failing students. In the expected results, we will analyze the data using a quantitative approach to research. This type of research helps us to understand different perceptions and opinions based on literature studies, investigating theories, and concepts. Since the research methodology is quantitative, our tool will be gathering secondary data, facts, and figures of past literary work of different scholars. Primary sources provide precise information. In using primary data, the researcher must consider three main factors. First, the data must be accurate. It must be collected from an authentic source. Second, data must be recent. It should not be too old. And the final one is the data must be relevant. Primary data produce meaningful conclusions only if it satisfies all these conditions. For the research expected results, the expected result is resurging attention in machine learning due to continuous factors that have created data processing and theorem analysis more well-liked than ever. Possessions like rising volumes and types of available knowledge, machine process that's inexpensive, and additional influent and cheap knowledge storing. All the effects mean it's achievable to rapidly manufacture prototypes that will examine more significant other progressive knowledge and distribute quicker, precise outcome on a massive scale. Moreover, by constructing detailed prototypes, a company incorporates a developed probability of characteristics, gainful prospects, or evading unknown risks. The process of learning analytics is a collective process that involves certain steps to understand or predict learning, along with advising people about learning as well. The collective process has certain factors like collection of data, measurement, analysis, and reporting as well, and this process on a whole determines the trends and preferences of learning that is quite visible and in use. In conclusion, learning analytics is a new perspective for understanding education for teachers, which is the analysis and visualization of data about learners to improve learning. Therefore, learning analytics provides new ways for teachers to comprehend their students and manage their limited resources wisely. Teachers must use learning analytics to enhance their education and influence the metrics agenda. And that concludes our presentation. Thank you all for watching, and if you have any questions, feel free to ask.
Thank you. Thank you, Aisha Al-Maazmi, for the nice presentation. And also thank you, Dr. Yasmin, for sharing the first part of this session. So let's move now to the next paper, which is entitled Recommendation System Toward Residential Energy Saving Based on Anomaly Detection, which will be presented by Dr. Shadi Atallah. And this work has been conducted in collaboration between the University of Dubai team and Prof. Abbas Amira from the University of Sharjah and Prof. Fadel Fadli from the University of Qatar.
Hello everyone, and welcome to our presentation. Recommendation system towards residential energy saving based on anomaly detection. Submitted to the 5th International Conference in Signal Processing and Information Security. My name is Shadi Atallah from University of Dubai, and this work done with collaboration between University of Dubai, University of Sharjah, Qatar University, and Jamiat Hamdard in India. This paper presents a context-aware system to promote residential energy consumption reduction behaviors. The system exploits data streams processing jointly with machine learning algorithms on real-time disaggregated power consumption, context, and weather condition data. At the end, the system helps to shape the user activity into more energy-efficient ones. Internally, the system will convert time series data into discrete order data points. These discrete data points will be regarded as an input for training the machine learning method. This method captures power anomalies and increases the accuracy of the machine learning model, comparing between the current data points and the previous time data points. The experiment evaluation on real and simulated data sets demonstrate the promising performance of the proposed method, primarily when decision tree algorithm is used to classify the features extracted using the time interleaving. Finally, the assessment of the performance, the accuracy, and the model size shows the suitability of this method to be applied in edge and energy efficient is considered a cost-effective means to tackle energy-related issues, such as economic, social implication due to high prices, energy securities, and global warming climate change. According to the International Energy Agency, the construction of buildings is responsible of almost 1/3 of the total energy globally consumed, and 15% of the direct CO2 emissions. However, the household users' behavior is critical in shaping their power consumption footprints. At the same time, adapting energy-efficient habits reduce waste in energy consumption and promotes household welfare. So it's important to note that end-user awareness of the impact of their habit on power consumption is a critical factor in changing their habit for power-saving purposes. Therefore, in this work, we used emerging information communication technologies to tackle and exploit energy-saving opportunities. The framework starts by collecting sensor data related to power consumption, related to the user home activities, like room occupancy, the temperature, the humidity. All of this information will be collected and saved into the back end. In the back end, it will be translated from real-time data into discrete event called micro-moments. And we have the machine learning algorithm that will try to classify each one of these micro-moments into two classes. One class for a good power consumption. The second class represents the bad power consumption. More details we will speak about the micro-moment classes details later. This classifier will feed the recommender system, which in turn will represent to the end user using mobile application or web application two things. The first thing, it will be messages to explain to the user good actions or bad actions he's doing. And the second one is visualization. Also to collect the end user feedback. Our recommender system built on top of habit loop theory, where we have three important events. We have the cue, represent the trigger, and the trigger that make the user make an action. The action represented by the routine, and if the system detects a good routine, he will give reward to the user, otherwise he will notify him. Repeating this loop many times, it will help the end user to reshape their behavior in order to reduce and adapt habits for energy reduction. Our work focused in specific set of residential building and small offices, where each unit or each building run autonomously in terms of power consumption. For instance, our system did not consider having a commercial building where we have many floors and each floor divided by many apartments, and the residents of this building sharing common places like the parking, the lift, and the corridors. Because this kind of scenarios required real-time systems that able to synchronize actions between different residents. However, we consider each unit is separated, autonomous in terms of power consumption. And we try to map each building into 3 layers in our application. The bottom layer, we call it physical devices layer, where we have the home appliances like the light, smart washing machine, refrigerator, etc. within the home. And each one of these appliances, we call them a load, is connected to a smart plug that able to collect instantaneous power consumption, disaggregated power consumption, connected wirelessly to build a home area network. All of these sensors will be connected to a home gateway, which will be in the second layer. We call it the gateway layer. And the information between different homes can be aggregated and stored for further processing in the cloud computing. Our architecture composed from 3 layers, and each layer we identify the suitable computing platform. For example, the physical device layer is suitable for sensors and actuator devices. This will be constrained wireless and embedded system devices, constrained in terms of memory, CPU, and a communication network. Now we have 2 sets of devices, sensors that are able to measure some data, actuators that are able to act in some devices, like turning on the light, turning off the light. And the second layer, it will be gateway layer that can be run in a fog or edge devices, for instance, can be run in a home, a gateway, or a smartphone. And it will contain 4 important modules. The data fusion modules used to collect and aggregate sensory data from different sources. These sources by nature will be heterogeneous data. It will try to harmonize and unify data representation to be used further by the system. And the second module is the recommendation module. And this will be an interface for the artificial intelligence module, where it's able to discretize the real-time data into specific data points. We call them micro moments. The second module is the visualization module, where the user can visualize his power consumptions and other features aggregated by different time scales from hours to days to weeks to months. The last module will be the action module, where the user can interact for recommended action, like turning on some device, turning off some device, and collect his feedback. The upper layer, which is suitable for cloud and fog computing, there is 3 important components: data management module to store the data. This module it will be two types of module. One to store all the data collected by the lower layer in some database, and the other module to aggregate data from different homes. This will use Elasticsearch because we need a big data. The second module configuration, where the system administrator can set parameters for the whole system. The most important module is the artificial intelligence module that is able to classify every moment of user behavior into bad moment or good moment in terms of power consumption. That to be used as the core component by the recommendation module. And he had out-of-the-box mobile application to receive messages from the system and to collect his feedback, to either to accept, dismiss, or reject the recommended action by the system. In the cloud, we build the machine learning module using MATLAB, and we wrap it with a Flask web server to get an REST API. For data management, we use MySQL server connected to the Home Assistant to collect all the sensor data and events generated by Home Assistant. And from one home, we aggregate the data into Elasticsearch as a big data lake that collect data from different homes. We have 5 classes. We call them micro-moments. Class 0 represent this moment is a good usage. Class 1 represent an advice for the user to turn on certain device. Class 2 represent an advice for the user to turn on the certain device. Like the user, the moment when the user turn on a device, it will be 1. When the user turn on a device, it will be 2. If we notice excessive power consumption, this will be class 3. Or there is a consumption while the user outside the home, it will be class 4. To validate the system, we use real data sets and we use simulated data sets. For the simulated data sets that cover all the 5 classes, we have almost 100 records, and we divided them to training and testing data set with the percentage 80% will be training, 20% will be for testing. We have one public data set, is called Red data set, 25,600 records, and divided in the same ratio for training and testing. And one of our own data sets coming from Qatar University, where we have 16,000 records, and we divided it to training and testing data set with the same ratio, 80-20%. All of these 3 data sets, we use them to validate our machine learning model. Our main objective is to investigate what kind of machine learning that considered lightweight to be able to run in the edge and fog devices where we have constraints embedded systems in terms of memory, in terms of the CPU capacity. To be able to find the optimal number of a training data set that achieve the highest accuracy, we run the learning algorithm using the machine learning nearest neighbor with k = 5 in the data set, where we can see the minimum number with a good accuracy can be around 3,000 records. And this is true for the training part and for the testing part, which means that our system can be generalized. Also, we try to change the machine learning algorithm where we use, instead of k-nearest neighbor, we use support vector machine in the same data set, where we see we need more and more data set to achieve the same similar accuracy. For instance, here we start to see we need more than 16,000 training records. Number of training records will be reflected in the size of the machine learning model. At the same time, we try to compare the pixel size. Pixel size may represent the size of the model habit loop theory, where we are able to give advices for the user, for the user to change his behavior and save time. Our system is suitable to run in edge and fog platforms, as we see from the comparison in terms of accuracy, in terms of performance, in terms of prediction time, and in terms of the model size. And thank you very much. Please, if you have any question, please forward them to my email as atalla@ud.ac.ae.
Thank you, Dr. Shadi, for the nice presentation. And let's move now to the next paper, which is entitled Enhanced Extra Trees Classifier for Epileptic Seizure Prediction. So it will be presented by Maurice Ntahobari. Peras, could you please run the presentation?
Hello everyone, my name is Maurice. Welcome to the presentation of my paper. The title is Enhanced History Classifier for Epileptic Seizure Prediction. I'm the presenter, and the rest are my supervisors. Start with introduction. What is epilepsy? Epilepsy is a neurological disorder characterized by abnormal brain activity and having more than 2 unprovoked seizures. A patient is diagnosed to have epilepsy. So it affects close to 65 million people worldwide and 3.5 million people in Australia. So the main symptom of epilepsy is temporal confusion, involuntary movement, and loss of consciousness. There are 2 types of epilepsy depending on the brain side, hemisphere that is affected, where we have for epilepsy for one side affected and for 2 hemispheres if they are affected, it's generalized seizures. The main treatment of epilepsy is use of anti-epileptic drugs, and research have shown that 75% can be assisted with medication. While the dissection surgery, which is consists of removing the brain size that is affected, research have shown that only 58% can be assisted. There are also electric stimulation, deep brain stimulation, as well as ketogenic diets. Yeah, so due to the different complications with this medication, and it does not assist all the patients, we can see from the percentage there is a need of another option, which is about seizure prediction, about predicting seizures before it occurs to assist patients, such as stopping dangerous activities like swimming or driving. The problem with the existing model, seizure prediction model, is that they have poor performance and they are computationally expensive at prediction time, which means they are based on a number of features and social efficiency. We say that a seizure prediction model should run in a small and reliable device, therefore we need most relevant features to train learning model to improve the resource efficiency. So the objective in our paper is to develop the most efficient and performant improved seizure prediction model. To achieve on that, in the past or previous research have been able to record electroencephalogram data, which is brain signal, and within time scale, with short time scale and long time scale. Then short time scale, we use 2 extract features in a window segment of less than 1 hour, while in long time scale, features are extracted from window size that is more than an hour. We can see from this figure, this is for short time scale and this is for long time scale. In our paper, we adopt the feature extraction from short time scale to be able to compare the performance of our algorithm with the benchmark. Data segments, data sets. So in this paper, we use long-term continuous EEG data, which is composed of 2 sections, which is the one of context data that have been given publicly to use in competition to improve the model performance. This data is composed of 3 patients, and continuous data, which is composed of 15 patients and have been recorded for 3 years. All these data, they are composed of pre-ictal segment and inter-ictal segment, where Pareto segment is the segment that is preceding the seizure occurrence, and interactory is the section or the segment between two seizures. The format was in MATLAB. The proposed approach for seizure prediction model, so we use the features which are univariate linear measures like statistical moments, which show the amplitude distribution in the brain signal, or spectrum bounds, or spectrum density, maximum frequency and sum frequency, and those parameters as well as zero crossing, characterizing the autocorrelation function. On total, we have 280 features, and the classifier we use is extra-tree classifier because it's have shown in the previous in the our competition and research about seizure prediction that this model is computationally efficiency in terms of computation time and have better performance in terms of area under the curve evaluation. We use SHARP for extracting the most efficient features, and only 20 features have been extracted. As a result, you can see that the star here for all 15 patients shows that the difference is statistically significant for patient 14 and other patients, you can see from the stars, and for others, there is no significant difference. Then on this figure on the right side, it shows that the evaluation for different test sets have shown that only for test 2, there is significant difference between our model and previous algorithm. And for test 1, test 2, there is no significant difference. In terms of computation efficiency, you can see that our models has this computation time than the visual algorithm, which is very important for model like seizure prediction model that we need to learn in small and wearable device. The result comparison in terms of table with the benchmark. We use two benchmark, the second place algorithm, and our competition and the one in our research. For the first two patients, patient 1 and patient 2, our algorithm gives better performance for patient-specific model, but in general, on average, our model also gives good performance, 0.8 compared to the previous algorithm. As a conclusion, we can say that few and relevant features are important for model development that concern to learning in small and portable devices, such as the prediction model, and on average, good performance can be achieved when using few features. Thank you very much for your kind attention, and I welcome questions. See you. Thank you.
Thank you, Mr. Maurice Tahobari, for the nice presentation. And let's move now to the last presentation, which mainly focus on the paper entitled Two-Stage Energy Anomaly Detection for Edge-Based Building Internet of Things Applications. So it will be presented by myself, and this work has been conducted in collaboration with Prof. Abbas Amira from the University of Sharjah and Prof. Fadil Fadli from Qatar University.
Hi everybody. Assalamu alaikum. I'm Dr. Yasin Hamar from the University of Dubai. I am assistant professor at the College of Engineering and Information Technology. I'm going to present our study developed in collaboration with Prof. Abbas Amira from the University of Sharjah and Dr. Fadil Fadli from Qatar University, which is entitled a two-stage energy anomaly detection for edge-based building Internet of Energy applications. In the window, I will follow this agenda. I will start with the introduction, and I will move to the problematic, the proposed method. After that, I will present experimental results, and finally, I will conclude my presentation with the important findings. As you know, alternative energy is a technological term that refers to upgrading and automating electricity infrastructure for energy producers and manufacturers using alternative things. Alternative energy allows energy production to move forward more efficiently and cleanly with the least amount of waste. On the other hand, building alternative energy is quite promising for curtailing energy consumption, reducing costs, and promoting building transformation. In this context, integrating artificial intelligence into building alternative energy is essential for big data analytics, and intelligent decision making. Typically, using deep learning to predict energy consumption and detect abnormal energy usage is gaining growing interest in building alternative energy. However, most of the models use supervised learning and thus require data annotation for model training. This is a tough and costly task, which is often performed by experts, and we can say that it's not doable in all the cases or all the scenarios. Additionally, energy consumption on weekdays is different than on weekends. So it is maybe rational to have two different models to analyze weekday and weekend data separately, as we can see in this figure. To that end, we propose in this work intelligent anomaly detection of energy consumption approach using an improved two-stage hybrid supervised and supervised learning process specifically to detect abnormal energy consumption. Our methodology identifies anomalies by analyzing the shape of daily energy time series instead of the consumption values. Consequently, energy consumption profiles were split into weekdays and weekends classes. Moving forward, as illustrated in this figure, after detecting energy consumption time series of weekdays, extreme gradient boosting (XG boost) is adopted to build regression model that enables labeling consumption anomalies of the weekdays class using a rule-based algorithm and residuals. On the other hand, for detected weekends energy time series, unsupervised anomaly detection is conducted using an isolation forest. Cross prediction of energy consumption is performed where the dataset is randomly split into k-folds. K-1 folds are then used for training the XG boost model, and the last fold is deployed for the validation process. That is used mainly to avoid overfitting. So this figure portrays cross prediction mechanism that is used in our study. Also, the result of the prediction is summed and compared original signal using residual training. Hence, the minimum residual has been reached by continuous optimization. After that, to validate the proposed model, we use the Dutch residential energy dataset, which is an open access, publicly available dataset from the Netherlands. It includes energy consumption measurement along with occupancy patterns and ambient condition recorded for a period of 6 months in a residential building in Netherlands. So example of weekdays, normal and abnormal energy consumption are presented in this figure. On the top we have normal consumption. On the bottom we have abnormal consumption detected using XG boost. Also here we have example of weekends normal and abnormal energy consumption. Similarly, on the top we have normal consumption. On the bottom we have abnormal consumption that is detected using isolation forest. So overall we can say that by analyzing energy consumption of the building, we noticed that most daily energy consumption on weekends is steady, while some days have higher consumption levels in the early morning due to the influence of Friday. Thus, high consumption values after 9 a.m. may be strong signal for anomalies. Also, if the peaks appear late in the day, they are more likely to be abnormal consumption profiles. So using the proposed methodology that combines XG boost and isolation forest, detected energy consumption anomalies was perfect in our approach, as we have seen in these figures. Also, as the detection of weekdays energy anomaly detection is performed in a supervised manner, it is of utmost importance to assess the accuracy and the F1 score of the proposed approach and compare it with other machine learning classifiers like SVM, naive-based logistic regression, random forest, LDA, CAN, and decision trees, ensemble classifier, and MLP. So in doing that, these algorithms have been operated using different parameter settings to identify the best configuration that accurately help detect anomalies. Moving on, only the best results are reported in this table. So obviously, the combination of XGBoost and isolation forest significantly outperforms all the models in terms of the anomaly detection accuracy and F1 score. For instance, compared to the ensemble bagging tree classifier, EBT has been ranked second after our approach. More than 8% accuracy and 7% of F1 score improvement have been achieved. Additionally, the proposed approach has been compared with recent anomaly detection of energy consumption techniques introduced in references 16, 18, 19. So this table summarizes the results obtained in terms of the abnormal detection accuracy, F1 score, and computational cost for both the training and test phases. So in this regard, superiority of the proposed scheme with reference to the accuracy and F1 score has been apparent. Also regarding the computational cost, it has been recorded on Python 3.9 that has been run on a laptop with 4 i7 and 32 GB RAM. So the proposed approach has achieved much lower time for both the training and test phases compared to the other machine learning-based techniques. So in conclusion, we introduced in this paper an improved lightweight two-stage anomaly detection of energy consumption scheme, which is principally appropriate for edge-based building Internet of Energy applications. It is also based on detecting abnormal energy usage by first analyzing weekdays consumption profiles using XGBoost and weekends energy usage using isolation forest, and second combining the outputs of the two stages to come out with the overall consumption anomaly. So the proposed scheme successfully detected overconsumption caused by the temperature variation, and anomalous usage occurred in nighttime and during the day off. Lastly, we can say that future work will focus on integrating the proposed approach into building automation and management system for sport facilities using embedded devices like Jetson TX Nano, Jetson TX1, Odroid, and so on. This will help test the proposed scheme in real-world scenarios and detect abnormal energy profiles in real time. Finally, thank you for your attention. If you have any questions or comments, please send them to me via email, and I will be very happy to reply to you. Thank you. Thank you. This was the last paper of our conference, ICSPIS. So finally, I would like to thank all the contributors, presenters, organizers for their contributions to the success of this conference. Also, I'd like to let you know that the closing ceremony will be held at 4:30. So please stay connected to not miss it. Thank you.
Okay. Welcome back, everyone, and I hope that you enjoyed the series of papers that have been presented as well as the valuable speeches delivered to us by our keynote speakers. So we have come to the much awaited session of the conference, of the 5th International Conference on Signal Processing and Information Security, which is the announcement of the Best Paper Award. So we are going to start this closing ceremony by announcing the winner for our Best Paper Award. So brace yourselves. We are now going to announce the winner. The winner is the Neural NILM Learning Paradigms from Centralized to Decentralized Learning, written by Hafsa Bosbiet and Christoph Clemenhack from University of Klagenfurt, Austria, Dr. Yassine Himour from University of Dubai, Wilfred Elmenriek from University of Klagenfurt, Austria, Dr. Abbas Amira from the University of Sharjah, Professor Wathik Mansour from the University of Dubai, and Dr. Shadi Atala from the University of Dubai as well. Congratulations to our Best Paper Award winner. Okay, thank you. Now I would like to pass the stage to our Dean, Professor Wathik Mansour, to deliver the closing remarks for the conference. Professor?
Thank you, Abigail, and I would like to congratulate all of you for the outstanding presentations. And actually, we are honored and happy to have you at this conference, although it is virtual. But your commitment to your profession were it's actually highly appreciated. Whenever we ask you about, any preparation for your paper, during the preparation of your papers, during the preparation of the video presentations. You actually made our task to organize the conference much easier with your professionals. So actually a great thanks to all of the authors who presented their paper in a professional way. Although we have just announced the best paper, but I think all the papers are of high quality, and we will actually put all the presentations, keynote speakers, panel discussion record in our in the conference website, so that all of whoever going to access the conference website will access this valuable presentation by you. So this is one point. Second point, that we will, this is the fifth edition of this conference, International Conference of Signal Processing and Information Security, and the previous four editions all were published at IEEE Explore. And we are going to submit this conference as well to IEEE. All the papers presented in this conference will be submitted to the IEEE Explore to be published at their website. So this is for sure. All your papers will be published by IEEE Explore. Although we need first to get to apply, and then we'll ask you about the copyright, all these things, and I'm sure that it will be straightforward. Once published, we will definitely notify you about their publication and the IEEE Explore website. We are actually happy and glad to announce that the sixth International Conference of Signal Processing and Information Security will be held next year. The time will be around in November, hopefully. And the good news is that it will be physical. So hopefully that we can see you next year, all of you. And I wish you all the best. And now I am officially closing the 5th International Conference of Signal Processing and Information Security. God bless you, and see you inshallah next year. Bye-bye.